Hello. Hello. That we will start. Just couple of 2-3 minutes and we'll start. Yeah, too much sound is not actually. Hello. Hello. Yeah, this is good. Okay. So, good morning, everyone. Thanks for joining today and hearing to some of the great geotechnical marvels that we will discuss today and learn from. Good morning, everyone, again to IIT Delhi campus, and it looks like a good day today. Wind is blowing, so nice weather, relatively. Uh, let's start the event for today. First of all, I'd like to thank Dr. Usmani, uh, chairperson, IGS Delhi chapter, and Professor Sumit Kumar Sinha. Both of them have been pivotal in organizing this event. I'm just filling in for Professor Sinha here, so thanks to both of them. Personally, I'm Professor Dipanshu Shirole, and I joined IIT Delhi 4 years back exactly today. And I work in the domain of rock mechanics and tunneling and geophysics. That's my area of work. With that, good morning and welcome to you all in this insightful seminar on engineering marvels of Chenab and Anji Bridge, organized by IGS Delhi chapter in association with IIT Delhi. While these bridges capture headlines for their height and span, as you might have seen, news and everywhere, it was broadcasted like as a major achievement by India. The real engineering marvel lies beneath the subsurface. So, what is happening below the what you see. Imagine building the world's highest railway bridge, that is the Chenab Bridge at 359 meters on fractured rock in one of the most seismically active zones in the world almost. So on top of that, add unstable slopes and extreme weather conditions that you face there. You have a nightmare to deal with when you have a lot of consequences and risk involved. However, our engineers have turned this nightmare into reality, and it's now under functioning condition. Another one, the Anji Bridge, that brought its own unique challenge as India's first cable-stayed bridge, railway bridge, demanded innovative foundation solutions in the treacherous Himalayan terrain. What makes these projects extraordinary is the unprecedented combination of geotechnical challenges that were encountered in these projects. Today, in today's event, you will hear from geotechnical experts who actually worked on these sites. They will share how they solved the unsolvable and build foundations that will last for generations and will, remain like a benchmark for us to move ahead. Let's dive into the fascination of, geotechnical engineering in this, treacherous Himalayan terrains, and let's discuss and, delve on how did we overcome these challenges. With that in mind, I will invite Dr. Altaf Usmani, Chairperson, IGS Delhi Chapter, to have a word. Thank you.
Yeah, a very good morning and warm welcome to all the expert speakers, members to this Premium Institute. And I think for an event like Engineering Marvels, there could not be any better institute like IIT Delhi in Delhi. So we are grateful to IIT Delhi also for hosting this event. Now, as my duty as part of the chairman of IGS Delhi chapter, I will just take few minutes to go through what our Delhi chapter is and what we are trying to do along with the members. So IGS society is a registered society, and so Delhi chapter is also as a registered society, and we are working for dissemination of the knowledge. We are doing a lot of things for the members in terms of the various events. This is the history. We started IGS in 1970 and then Delhi chapter in 82. Right now, I think we have 55 local chapters. So it's expanding every year, every month, and thanks to our thanks to our president and honorary secretary for doing a lot of work in this field. IGS Delhi chapter has been doing a lot of things. We got a lot of best awards, not from few years, but we are trying to rake up again, and we are looking for more best chapter awards in the coming years. Just introduction of the team. I think some of the members are there, some could not join. So I am heading this team as chairman. We have Dr. Manna as co-chairman, Dr. Manish Gupta from CSMRS. Then we have Dr. Sumit, very most hard-working secretary for the society. We have Dr. Dipanshu as the treasurer of the society. We have Ms. Atasi Das from GR Infra, Ms. Gitanjali, she's there from Engineers India Limited, Mr. Sharik Khan from Atkins India, and lastly, Mr. Uday from CSMRS. So this is a team of professionals from different organizations, balanced academic industry. We are trying to rope everyone, give some responsibility to everyone to do something, and we are trying to do bits and pieces for our members so that they are connected to the IGS Delhi chapter as and when required. So in terms of the membership, we have like student chapters also, we have our life members also. So student chapters, we are just having in membership of 250 until they are students, and life members, we have 1,000 for complete lifetime. So all these events what we do are free once you are a life member of IGS Delhi chapter. And we are organizing a lot of, I think we had last event also in IIT Delhi itself. We have some site visits. So we are doing a lot of activities as part of the IGS Delhi chapter on our responsibilities. So there are memberships advantages I have already discussed. We are doing activities so you can benefit from them. So we also have 3 student chapters in Delhi. The first to start was Jamia Millia Islamia. The second, it was joined from DTU. And the third, we have IIT Delhi. So we have given responsibilities to the student unions also, to the students chapter also. They can organize under the umbrella of IGS Delhi chapter and of course under the IGS main body. So just to encourage we peoples to get more and more membership and be associated with us and take advantages of these expert lectures and events. This is the website. Now it's a good thing that all local chapters are connected to the main website, so you can access local chapter activities also from the main chapter website. So welcome to the IGS fraternity, welcome to the seminar. Thank you. Thanks a lot.
So with that, we'd like to, start the felicitation of the guests of honor and the honorary speakers we have today. So I will ask Dr. Usmani to be on the stage. First, I will kind of politely ask President Indian Geotechnical Society, Dr. Anil Joseph, to be on the stage. Then I'll ask Professor T.G. Sitaram, who needs no introduction in itself. Thanks for his time today. Then I'll politely ask Professor K.S. Rao. Mr. Sandeep Gupta, who actually was involved in this project from Railways. Honorary Secretary Dr. Avdesh Pratap Singh. Thanks to you all. I will now politely ask Dr. Anil Joseph, President IGS, to give us inaugural address. Thank you.
Good morning all. The chairman of the IGS Delhi chapter, Altaf, the speakers of the day, our own role model and the hero of the man who shapes the future of engineering in the country. And I feel it's in a very safe hand, our own Professor T.G. Sitaram, the total geotechnical solution, the TGS, and our Professor K.S. Rao sir, the mentor and the backbone of the formation of the Indian Geotechnical Society, and the man who shaped Indian Geotechnical Society to this extent and giving the baton to us and guiding us always to how to take it forward. And Sandeep Gupta, and very good morning, the other members who are of Indian Geotechnical Society and students who are assembled here. Today it's going to be a great day. We have is then experience of sharing one of the marvel of engineering in the country. So that's been so proud for us to have this opportunity to listen to the speakers who were part of this journey. And I came to know that from 2004 onwards, Sitaram sir is involved in this project, and K.S. Rao sir, I think right from the site investigation or selection of the site characteristics is involved in this. And Sandeep Gupta sir was also there, and we also have Rashmi Ranjan Malik speaking to us today. So I don't take much of a time. I take about 2-3 minutes to address that. Before that, I would like all of you to welcome that Altaf has did a great job talking about taking membership in IGS Delhi. But I said don't limit to Delhi. Make part of IGS India. Be part of the national body, and don't limit there. Be part of ISSMG, International Society of Soil Mechanics and Geotechnical Engineering, where we connect 22,000 professionals who are specialists in this area, including academy, industry and research fields, coming together to share our knowledge. As Carl Tersagi always pointed out, the man from mechanical engineering who derived all the theories of our geotechnical engineering, and he always believed that sharing of knowledge is very vital, because we deal with a material which varies horizontally as well as vertically, and very difficult to predict its behavior. And always people assume that geotechnical engineering is taken for granted, because foundation is below. It's immersed below, nobody sees that. But the people who behind the work, once to a structure, I practice most as a structural engineer. Structural engineering is much more defined. You know the parameters, you know the bandwidth, how to play it around and get in that. Whereas coming to geotechnical engineering, especially the fragile Himalayas, it's such a great task. So it's with immense pride and admiration that I stand before you today to speak one of the greatest engineering achievement, not just in India but in the world, the Chenab Bridge. So there is a lot of things which attracts all of us, and I am sure that I'm not the one to talk about that. But recently, last 3 weeks back, I was in Sajanji in Chengdu in China, and what engineering marvels they have worked on, what extreme engineering. And seeing this, we feel that we have something to answer them. We have a lot to catch up, lot to grow. India, the most populous country in the world, the fourth largest economy and going to be the third largest economy in the world, has a lot to achieve, and we have to make the corrections in the grassroots level, where that is where I say the man who is shaping that, Professor T.G. Sitaram sir, has got a lot to do, especially in terms of the professional engineering council he is going to head soon, and which is going to make change that unless and until you are a practiced professional engineer in the country, you are not allowed to practice. Unfortunately, that has not been the scenario in our country, and if we can achieve that, which we are trying from 1972 onwards. So with 53 years, nothing has come up into a reality, but we are seeing the light at the end of the tunnel. And I know Sitaram sir has got such a busy scheduled day today that even though I have a written speech, I don't dare to get into that, because I know the time is very important. He has a 11:30 online meeting, and again I am meeting him in Indian Habitat Institute, where he is again going to address at 3 o'clock. And then in between here I am meeting with some of the top brass who make the policy decision in the country, and I don't want to take much more time. Thank the organizers, especially the IGS Delhi chapter. Congratulations, you people are doing a great job. And I take this, and K.S. Rao sir, the man who founded the state, and Sanjay Gupta ji, and thanks to my such a dynamic secretary we have in this thing, that I am happy to announce that we are going to open the 56th chapter in Lucknow, and 4 or 5 are more in the pipeline, and we will keep it growing, because there is lot of thing as geotechnical engineers we need to share, and then the failures are the stepping stone to success. Something buried below doesn't get reported. We have to come across, share our knowledge, learn from the failures, learn from the success stories like this. So that's why I was so excited that I came in the morning flight and leave in the evening flight. So just to listen to these talks, which has made us proud, and the depth of which will be shared to us, all of us. Let us create more marvels in the country. And I always used to tell, I travel across the world. I practice more as a structural engineer than a geotechnical engineer, because there is more money in structural engineering and there is very less money in geotechnical engineering. That was the basic route, because when you make your bread and butter from that, it matters. At least in the initial phases of your career, it was very important that I make money. So With that, you travel across the world, seeing some of the majestic buildings in the world, and even we don't have even one structure which is more than 100 floors. And in 1929, March 30th, the US put foundation stone for Empire State Building. Exactly after 367 days, on April 2nd, 1930, they inaugurated the Empire State Building, which was 103 stories. So we are 3 generations behind. So we have to catch up in leaps and bounds. And I know in the next 2-3 decades is going to be India, and we are going to see the people coming across the world. Especially I am envious of China. I told every time I'm going to China, see the horizon changing like anything. The people from US, Europe, and China will come to India to see some of the engineering marvels like Chenab and Anji Bridge, and that has to be created by our young engineers who are here to share and learn from our masters and take it forward. So we have a big task ahead. Let us all work together, be a proud civil engineer, and be part of the nation building movement. Thank you very much for this opportunity.
Thank you, Dr. Joseph. Thanks for such a wonderful, engaging talk. And now we will move forward to listening to the most, exciting talk today, Professor T.G. Sitaram. It will be our great honor to have him on the stage now. Professor Sitaram requires no, as such, introduction. He is a big name in itself. He is presently the chairman of AICT, former director IIT Guwahati, and is a visionary academic and government leader for the last 35 years. So without further delay, I will let Professor Sitaram to take the stage.
Thank you. You don't have the color mic, no?
Yeah.
Thank you. Very good morning to all of you. Dr. Altaf, Professor Dr. Anil Joseph, Dr. A.P. Singh, Professor K.S. Rao, Sri Sandeep Gupta ji, and then I think Malik will join us soon. He's not here. And all the distinguished faculty of IIT who have assembled here, and the students, ladies and gentlemen. So it's a great pleasure to be here because I started my first paper in 1986 in this IIT, even though I was a student at Indian Institute of Science. And then I completed my master's and then came here for a few months working with Professor Manoj Datta and Gulati Saab, correct. And then I left this place, went to Canada, so the history. Anyway, let me not waste my time in giving my background because many of you know me. Let me come to the problem. This Chenab Bridge is a very unique project. As Anil Joseph clearly highlighted, I think we have a lot of things to catch up. As a nation, we need to still build many more projects, but these 2 projects, Chenab and Anji, are very critical from 2 angles. One is connecting people. It has connected our crown jewel, Jammu and Kashmir, to the mainland. It's a very important time when the world is seeing a lot of changes. So in that way, when the connectivity becomes important, this bridge has come at an up time. And more about the geotechnical engineering. See, geotechnical engineering is one, the people who are doing it also very humble. Why? Because they have to be humble. Because the material is so complex, they don't even understand what it is. So, unless you are humble, you will not solve that problem. So, that is where I call, geotechnical engineering is a very, very uniquely positioned among all the materials of civil engineering. Here we are getting into a little bit of a broader brand of geo, that is rock mechanics and rock engineering and other aspects of it. So the Chenab Bridge, basically, I put it as India's crown jewel of engineering. And maybe it's a turning point for us to look at and do better things in the future. And it is also a practice of sustainable infrastructure. The challenge in this project is more of the site itself. The location of the bridge itself is a very big challenge for us. Because the people who have gone there in the very early days, they will definitely tell you that there is no way even you can reach that spot, even if you travel many days. As I was overwhelmed by the enormous talent and perseverance and technical ingenuity of the people, many people who are involved in bridging this bridge, and also who shaped this bridge, these bridges. I can even show you the other picture. Is the change is not working? No. Okay, thank you. Yeah. So I would like to start with a salute to Afghans Infrastructure Limited, because this is a project which is executed completely by them. And then Indian Railways, definitely for conceiving and bringing it. In that, Northern Railway, Konkan Railways are all part of it. And many engineers who are behind this Chenab Bridge, not one or two, thousands of them, and maybe I'll say much more than that sometimes. Why I wanted to salute them is because the site is such a complex site, not from a point of just engineering, even from the accessibility point of view. So June 6th would be definitely forever be etched in the annals of Indian engineering history. From here, we have to think big and dream big and build big. So the inauguration of the Chenab Railway Bridge by Honorable Prime Minister Narendra Modi ji was merely a culmination of the mammoth infrastructure effort which had started sometime in 2002-2003. Even though 94 it was conceived, if I am correct, and later on some work started in 2002-2003. The relocation of the audacious dream, once considered impossible, also is one such. I will narrate that in a little while. What is interesting is 359 meter above the Chenab River, higher than even the Eiffel Tower, which has been quoted many times, but those two textures are completely different. And this engineering marvel stands as a tribute to the human spirit, scientific precision, and national resolve. From indigenous geotechnical solution to advanced construction technique, the project reflects India's growing self-reliance and confidence in delivering world-class infrastructure. What is unique about this project is the Afghans infrastructure, whatever they have done, it is actually worthy of putting a world record. Whether it is a crane or anywhere, anything what they have done in this project was very unique and very big in that context. So the picture very clearly shows to you that now the trains are moving, people are connected, and I keep saying, so we have a scholarship at the AICTE for students of Jammu and Kashmir and Ladakhi students. They can study in any of our engineering colleges, diploma medical colleges, dental colleges. There are 5,000 scholarships. It's called Prime Minister's Special Scholarship Scheme. Now all those students can go back and forth very easily. Otherwise, sometimes they get stuck in the landslides which happens on the highways, even though highways have also improved, where I was also associated with the national highway from Udhampur to. So, but still, that is a risky job. But this is, it looks like we have a safe movement of people and passengers. So, this is a very beautiful picture site of this Chenab Bridge. You can see in all these three completed bridge looks very majestic and tall. And this deck height is about above the riverbed 359 meters. And this is world's highest railway bridge. And completed in December 2021. Okay. And later on, a lot of work has been testing and everything has happened. And you know when it was June 6th, which was launched. The arch span is about 467 meters. And the length of the entire bridge is 1.3 kilometers. So the Chenab Bridge, friends, first of my visit went as early as 2005. So when I went there, it was really a story to tell you. Because so they took me in a boat and exact location we have to trek close to about 500 meters. Okay, there were no roads, nothing. No construction also started that time. Then at the same time, when I went several times, little later in 2005, the Konkan Railway started the road construction to Bakkali end as well as the Riyasi end. So this project is a monumental in that context. And 2007, they were even thinking of abandoning this site, considering geotechnically this is not buildable. And that did happen to Anji Bridge, I will tell you. And then Anji Bridge was handed over to some other contractor, because otherwise Gammon India was actually at the same time they started. Gammon India on Anji Bridge and Afghans on the Chenab Bridge. So this world's highest railway bridge has many new things. This connects Udhampur-Srinagar-Baramulla Rail Link project. Is a USBRL project, and it is in Himalayas, very active young mountains of the world, and it is sub-zero temperatures. You can go to sub-zero temperatures, and also difficult to access, and disturbances also was there when it started construction. And what is most important is there are many new technologies and many new innovations have happened while constructing this bridge. That's some of them I'm going to talk about it, but not all, because this is a very complex project involving truly multidisciplinary expertise. So what I am going to talk to you is only on the ground, what we did on the slope stability and an accessibility, and then the foundation design, foundation aspect. But what I was part of the Afghans Infrastructure Limited as a consultant from Bangalore. So from the beginning, we were involved till the end of the project, because every analysis, I will tell you, has been done through as a consulting mode from the Indian Institute of Science. Several of my colleagues were part of me. We went together. Many of my students are also went their site at the site. We did investigations as well, like multi-channel shear waves. Many as such experiments have been done, and even large plate load tests were also, we were part of the witnessing along with Afghans infrastructure. But every document is vetted by us on the geotechnical side from Indian Institute of Science as a consulting project. So there were many others who were part of the railways, because railways also independently checked all those calculations. They had chief engineers, many of them, and some of them will explain what they did. For the people who doesn't know where is this location, there are these 3-4 points you have to know: Jammu, Udhampur, Srinagar, Baramulla. This is basically the USBRL link, and this is what it looks like. See, up to Katra, 2017, the railway line came in. 2017, Honorable Prime Minister actually inaugurated the Udhampur to Katra railway line, and then the blue line, which is from Banihal, Kozhikode, in the valley, the trains were running earlier, okay, in the valley. So the connection between the Katra to Banihal, that's where there are many tunnels, many bridges. Only I am showing you the only one. That is the Chenab Bridge. Okay. So there are many rivers. You can see this. But all of them have to be passed through. Many tunnels are there. So it goes from tunnel to a bridge to a tunnel, bridge to a, many such complex conditions are there. So just to understand for you, Katra to Banihal is about 111 kilometers. And that's where the stretch took a lot of time to build. And as I told you, Banihal to Baramulla is 137, Udhampur to Katra is 25. And all of you know now the story of this. What is the uniqueness of this? What I told you is geotechnical aspects of it. We have done the slope stability part of it and the foundation design part of it, where it is a very complex geological condition. The foundation design had to deal with highly fractured rock masses, varying geotechnical strata in a Himalayan seismic zone. Very high slope stabilization challenges, the steep slopes at both banks. So very high steep slopes, I will show you in a little while. And the Chenab River required extensive slope stability analysis and stabilization measures like rock bolting, shotcreting and anchoring. And also deep foundations on steep terrain. Foundations have to be securely embedded into the sloped rocky terrain, customized excavation and blasting, because you cannot randomly excavate and blast also. Why? Because the entire thing will go and choke the river. Again, you might have built a temporary dam in the river. So, seismic and wind load integration into the groundwork, because the slopes and foundation designs uniquely address seismic and wind loads at the geotechnical level, ensuring stability under dynamic conditions. And then last is the customized foundation types, use of open foundations. It's a very challenging project, actually, very huge foundations, particularly the P10 and P50 are the critical foundations which are on the either side of the arch. So arch, why it has been selected, there are many people, structural engineers will tell you the story, but I will not get into that, but that's not my domain as well. So unique features of the bridge before I move on the geotechnical side. The world's highest railway bridge, steel arch designed in seismic zone. Please note this, first of its kind steel arch railway bridge in a highly seismic zone. Even though it comes under zone 4, but it is designed for zone 5. Use of weathering steel to minimize maintenance in a remote inaccessible location. Weathering steel was used. That selection itself went on. They have to discard the first round of steels procured. And remember, taking that steel to that site was also a big job, because some lengths have to be restricted. It cannot be whatever lengths they can do it. So erection by aerial cable cranes, 2 cable cranes. Again, they are all world records. The cable crane itself is a world record, Guinness Book of World Records. And strung across the gorge, a rare and innovative construction method globally due to inaccessibility and height. Designed for 120-year lifespan, that's a very unique of this project. Bridge was designed for an exceptionally long service life of 120 years, which required a special altercation to fatigue, corrosion, and maintenance planning. Wind tunnel testing has been done extensively in this project. And monitoring, full-scale wind tunnel testing and real-time wind monitoring systems were used. Blast-resistant design, that's again a very unique project of this kind. That means due to strategic importance, the bridge was designed to be blast-resistant, which is highly unusual for civilian railway bridges. And then design speed. Design speed is about 100 kilometers per hour and carrying heavy loads, requiring robust design standards, usually reserved for major railway corridors. Remote location logistics. This is what I will say most challenging, because even to carry your material, it was a big task. Sometimes even for me to go there, I have to sit and close my eyes. The rugged jeeps were very confident. Jeep drivers of Jammu and Kashmir very confident. Sir, hum leke jayenge aapko, don't worry. That did take me every time I went there. So that's but for us, close your eyes, pray. Then only when you reach the destination, you open your eyes. Problem statement, and it's important, ladies and gentlemen, for geotechnical students. Highly jointed rock mass, which is predominant in the Himalayan region, where the ground was subjected to severe tectonic activity due to pushing of the plate tectonic movements. Okay, highly jointed rock mass is close to this, almost like a soil. From strength point of view, yet the behavior is governed. Yet the behavior is governed by joint characteristics. They are younger dolomitic. Even they had several cavities. Huge cavities actually at site, many locations. First time when I went, even they were saying, sir, there are like caverns. So they found even wild animals and everything there. This is a strange thing. The analysis of the slopes and the assessment of safe bearing capacity of foundation coming on the slopes involve elaborate work treating the strata as a continuum on one hand and as a discrete material on the other. So I think Professor Rao will highlight to you on discrete modeling of the entire bridge, but I will not get into those things, please. So Chenab project is determination of for us as a civil engineer or a geotechnical engineer or a rock mechanics specialist, determination of the intact rock or rock mass parameters is very critical for us for modeling. And the design of slopes in jointed rock mass. Suggestions of the appropriate parameter based on the detailed investigations. So there are all kinds of investigation I will highlight to you for the design of slopes in jointed rock mass. Determination of stability of slopes and suggestion for the appropriate stability analysis and stabilization methods. Lay down the principle of design as you go approach. I will explain to you how this is very unique and also what corresponds closest to the codes available in geotechnical engineering. So this is what the closest to the codes available in geotechnical engineering, that is called interactive design. So interactive design is currently actually undefined in geotechnical engineering. It appears to be same as the observational method, which has a body of references and is already referred to in guides and codes as Eurocodes ISO, but our codes doesn't talk about it. Indian codes doesn't talk about it. So this observational method is actually, there is a committee, TC 206. Once upon a time, I was also briefly a member of that. And interactive geotechnical design is a design approach that requires design refinement throughout the project execution period, until a suitable technique and an optimum scheme are applied to the problem at hand. That means as you excavate, you find new properties, you use them and design, and again go back, change your cross sections, and keep going there. That's what is called as design as you go approach. In general, the use of interactive geotechnical design is not frequent. Generally, we don't do this in engineering practice. However, in large projects, it has to be iterative. So as we learn more about the ground realities, design is modified and updated. That is the basic concept of the whole design as you go approach. In mountainous terrain, stabilization of slope is inevitable. Highways, railways, power generation facility, mining. That means everywhere we have done this. It's not a project of a unique kind that we haven't dealt with. Okay? Because we have built so many power projects in the Himalayas. Okay? It is not a new thing for Indians. But somehow it has been made as if you cannot do it. In 2007, in the TAB board, I still remember in Mumbai, I went there and stood up as a young person. And they asked me to make a presentation. I made a presentation, I told. And everybody was saying this bridge is not going to be safe. And we should not build it here. And I calculated with numbers and showed the bridge itself. They were worried about the entire hills sliding away. Okay, and that was the same decision was taken for the Anji Bridge to change. Okay, but here also that was the question. But I clearly told the bridge what you are building, the loads what you are putting in is like ant on the elephant. This is the word I used. Ant on the elephant, nothing is going to happen. But still, we need to do all the kinds of improvements to put the foundation. When you look at the foundation, close to the foundation, that's where the challenge is. It is nothing to worry about the location. If we can definitely build this project. But the TAB accepted this and went ahead with the same location for the Chenab Bridge, but Anji Bridge, also same location, but the type of bridge was changed. Anji also, arch bridge was planned. Anji also, arch bridge was planned, and actually the pillars were already constructed. I have been so many times to the Anji site. Pillars were done by Gammons India, but later on, Gammon India project, Gammon withdrew, or railways cancelled it. I don't know the logistic of the way they did it, but finally, Hindustan Construction came and built the cable stayed bridge. Design as you go is basically an interactive geotechnical design. So establish guidelines and technical recommendation within the framework of the interactive design. So this is the basic structure. You can very clearly see this is what I said, S40 and S50 locations. These are all the location 10, 20, 30, 40, and then again 50, 60, 70, 80, up to 180. This is the slopes. You can see very, very steep slopes. Okay, even the final slopes, what we have achieved is about 70 degrees. So you can clearly see other side also, S50 to S80. This was the slope, what it was earlier and what has been constructed at that location. Okay. Similarly, what you are seeing, the bolting, the excavations were very huge. Rock bolting is very long, rock bolting. I will not get into the numbers because numbers might have changed at the end, because these are all the numbers what I had during my construction time. So I will not get into too much of the numbers. It may be more than what I have put it here. Okay, that much I can tell you. So these are the dividic bars, very unique installation of the slope below S60 foundation, which is completed. You can see very clearly. These are all double corrosion protection rock anchors. And slope profiles before commencement of the work. Once again, I will show you how steep they are. Very, very clearly see, and very difficult to reach. But there is no question of water coming and touching the foundation except the rainfall water, because water level in the Chenab river is at the almost very low at bottom, and even at S50 what we have selected is very high. So there is no chance for water to be integrating, but the rainfall water can be coming there. Geological investigations, which is logging, you can see. So this is what from a long distance you can, from the other end you can see. This is the audit what has been done to more than 2 meter diameter. Okay, and this decision I was there on that day when Ramamurthy insisted, oh, we have to do this. Professor Ramamurthy said it has to be, an audit has to be done. Then, the railways took very seriously and his suggestions, because he was a consultant to railways. And then I was also there I supported his view, and then finally the audit was done, and it was almost like 100 meters inside into the tent, and also cross cutting the audit also was done. So these are the joint variations of the drift faces you can see, and you can clearly see the height of the audit. Okay. A person is standing there, that means it's more than 6, 7 feet, 8 feet. So these are the geological log of the pit which has been excavated at the site. So it's a very highly jointed rock mass, and at S50, this is the phenological geological mass. So just to summarize, what is the geologically highly fractured dolomite? Joint spacing is 20 millimeter to 500 millimeters, and joints filled with silty sand and silty gravel, and presence of open joints and cavities. RQD is about 10%, that means it's almost like a soil. RMR is about 35 to 42, and UCS 16 to 62 MPa is also varying. Permeability is more than 50 lugins, and then there is no groundwater. Very clearly I said, and this is this parameter, even though we confidently I showed you one, this is what not we have used. We have used varied parameters. Several trials we have done, and IIT Delhi used something differently. I used something differently. I myself used parameters with bounding several things which I will not get into the details here. So we had discussion, 3 different properties we have selected. Okay, based on our assessment and analogy. So investigations, plenty of investigations are done. By the time I have even visited the site, actually Afghans had carried out boreholes on both sides. First level of investigations were done by 2005 already. So they had given us the geotechnical report when even during my first visit of 2005 for both Chenab and Anji. So plate load tests we did ask for them to do it, in situ box shear test. Borehole data for RQD, UCS and RMR was available with depth. And then settlement characteristics, borehole data, RQD, UCS, RMR, plate load test data, dilatrometer also was conducted. MSW, our own team did it, as well as the rock mechanics, NIRM, as well as NGRI has also done the tomography test. And slope stabilization, while doing slope stabilization also a lot of testing were conducted. It is not one time. Okay, plate load test data are also many, whenever we suggested, they were very, very willing to do this investigation. That is one thing I could tell you confidently, because Afghans have never hesitated to do a test. So this is the peak ground acceleration, what is given by IIT Roorkee. Actually, this is the Roorkee's work, 0.36 G, maximum horizontal acceleration. That is what is the entire bridge is designed for. Okay. Design basis earthquake, even though is 0.18 G, but maximum credible earthquake is 0.36 G. So the minimum factor of safety, some of the parameters which are being assigned, jointly with railways, Afghans and IASC team, and I don't know who else was involved, but from 3 of us, we have a design document, where very clearly we say static load, under static load factor of safety be 1.5, with static load and DBE, seismic loads 1.2, with static load MCE seismic loads 1. This was under discussion. The 1.0, the factor of safety was under discussion in 2007 TAB. They were very, very worried about how you can design for 1. I said this is the practice, because this is the maximum credible earthquake which will never really happens in reality. Okay. That's where the one limit is coming. That is the limiting parameter to actually back calculate your strength of the material, which is there. Okay, that's the argument I had put it. And that is where I said very confidently that the bridge loads which are coming on the entire slope of that height is like an ant on the elephant. So coming to the pore water pressure, even though there was no water, as I told you earlier, though there is no groundwater, even then RU factor of 0.3 was considered. And the analysis, in our all analysis, differential settlement of foundation, these are all works like an additional factor of safety for you, 0.3. Okay? And then differential settlement between the foundation should be less than 20 millimeter. This is again very, very rigid for even geotechnical side itself. So coming to the programs and analysis, what we have done at IISc, okay, Professor Rao has gone to FLAG 3D, but I didn't actually venture into it because it was even though we had FLAG 3D, but I said I will not be able to model this rock as a three-dimensional model because continuum is quite good enough. That's my argument was. Okay, average dip direction and dip of joint sets, dips we have used, kinematicals, rock science we have used, wedge failure analysis, wedge we have used, global failure analysis, continuum approach, pseudostatic condition, FLAC we used, Itascas as well as slide, and we did compare all those results because both are different conceptually. You know, one is a limit equilibrium, one is the other one is a not. So global failure analysis, continuum approach, dynamic analysis we have done with FLAC, and toppling failure we have particularly looked at some locations by Hook and Bray model. So this is the making of approach roads. That itself is a big challenge, ladies and gentlemen. Getting to these locations. They were thinking, how do we put these foundations at these locations where, how do we take the material? How do we concrete them? That was a big task. Initially, otherwise we were thinking that, put it right there in the, using a cranes, but this is not possible. This is not possible, but that is why this project took large amount of time. See, remember, in the entire project, assuming that it is 2004, sir, beginning, 2004 is the beginning, ending is 2021. Okay, after that railways have taken over to test it. So that means 17 years. Out of 17 years, 15 years has gone into geotechnical, slope stability and foundation engineering work. 2 years the bridge. So you can now see the beautiful bridge is standing, but lot of work has actually gone below, as I think one of the speaker earlier said very categorically. The majority of the complexity of this project is about geotechnical engineering. And that is where it took a lot of time. And from that consideration, we are all proud to be part of this journey of making of the entire Chenab Bridge. So some of these excavated shotcretes, how they used to do and all that, I'll just skip it. Cleaning of the excavated slope with water jets, and then do the facilitated rock bolts, and then you can see how the rock bolts are inserted, and then you see, you can very clearly see and installation of rock bolts, and finally you can see the David bars installation in the slope below S60. So reaching out, standing there and doing things is a mind-boggling. So this is last, that is about the Chenab Bridge. I will not get into much more details than this. And the Anji Bridge, as I told you, originally designed as a asymmetric arch with a main span of 265 meter, and the Gammons was the India at that time. I was a consultant to Gammons as well. So almost 4.5 years I have worked with them, and then they withdrew the project. I think 2017 Hindustan Construction Company started. They built the entire bridge in 6 years. It's a beautiful bridge. It's a Kebastate bridge of the Chenab Bridge. So this is a gate 186 meter high, 200 meter span. These two bridges are very critical in that USBRL project. These bridges are very, very critical. And this is where I think railways have also are very proud that they have completed these two projects. And I think simply whatever involvement we all had, we are only the learners. And the real heroes are the railways taking up this project. And the real heroes are Afghan's infrastructure and HCC. So this is the details about the Anji Bridge. So what did we learn from the Chenab Bridge? So it is more than just a transportation corridor. It is a symbol of national integration, scientific triumph and engineering vision. As Anil Joseph said, this is the beginning for us to think big in India. And redefines what is possible when a nation dares to dream and it is engineers' resolve to deliver. And similar kind of projects have been done. It is not that we are the first time doing this. For example, in the Kolkata Metro, again Metro I have to quote, the underground metro station is about minus 45 meters below the river bed level of in Kolkata. So that kind of many projects. For students who are here, for young engineers across India, this bridge must serve as not just a structural landmark, but as a living classroom. I appeal all of you to visit. AICT will actually have a scheme to support your travel. So if you don't have money, you please apply there, and there will be a lot of competition. We do fund to visit this project, and we will take the appropriate necessary permission from railways to visit to the site, and we can do. True strength of engineering lies not in the textbooks alone, ladies and gentlemen, but in the courage to take an impossible odds and the competence to solve them, one calculation at a time. That is really what we did in this slope stability analysis and excavation projects. There are many things which I have not narrated today, because it's going to be a long story. Even I can give half a day lecture itself on this, because we have a lot of material, but I will not get into there. It inspires generations to come to reach higher, dig deeper, and build stronger. So let us honor not just the bridge, but the countless bridge builders who made this marvel a reality. Thank you very much. Namaskar. If you have any questions, I will take few questions.
I will put one question. Excellent presentation. I'm not a geotechnical engineer. Now with the global change and climate change, and which would last for say 25 years, the changes of the contemplated data, have we taken progress in this?
Exactly. That's why I told you, it is not design normal design, bridge design may make it. It's about 120 years lifespan, and all these aspects have been deliberated, discussed, and taken into consideration. Even instrumentation, what they have done afterwards, also will clearly indicate to serve accessibility to every part of the bridge. Also is there for maintenance. So it's a very, very detailed discussions have gone in. It is not simply, one time you decided it and built it. No. I think railways were involved. See, two railway groups were involved. Imagine, in Northern Railway as well as Coastal Railways. They were even questioning each other, because they are all smartest of our students, among our students, smartest. So they did a fantastic job. That's why I said this is tribute to them more than anybody else. But I have to tell you one more thing, that none of one engineer in railways stayed there, because they were transferred. Of them come and gone. But some of us consultants like me, Rao and Giridhar from Afghans were the one who were there from the beginning to the end. Very few of them who stayed with the project from beginning to the end. Correct, sir? Anybody else? See, slope instrumentation was not much done. I'm talking about the bridge instrumentation has been done. Slope instrumentations were, as I told you, the analysis were done with a large number of parametric variation. We had selected 3 parameters of rock masses properties and analyzed and come with a stable slope. And more than that, we have also avoided any see, what is the best worst condition? There are 2 things. One is earthquakes, one is water from the rainwaters. So we have seen that rainwater doesn't get into the slope. We have seen that it has been diverted, good drainage has been provided, okay, and shotcrete is being done. This shotcrete is also very unique shotcrete with fibers, steel fibers. So all that care is taken, but even then, initially we did have some minor slips, which in many projects we don't say about it. Minor slips were there, and then we also found a wedge kind of failure in one of those audits what we have done. Okay, it's a very complex one, but no instrumentation is done on the slopes. Yeah.
We have done some instrumentation of the slopes also.
Oh.
So we have methods also. And then we have provided some parameter answer the bifocal reflectors for 3D mounting. We have provided total stereotypes 24 hours they are looking at it. So the 3D mounting is the slightest movement of the slope.
Is the based on satellite? Okay. That is now common everywhere now.
Yes, the satellite is global navigation satellite system is there. Then we can get XYZ coordinates on real time.
On a millimeter accuracy.
And everything is photo the cloud. You can get on your mobile also.
Anybody else?
How the managed of differential settlement for the open foundation as well as deep foundation? Like
Deep foundation was not at all considered here. Okay, because pile foundations are not been part of this. This is completely a shallow foundation. Okay, but this resting on rock and also improved rock. We have grouted the entire base, and actually that is again another big story. Lots of cement bags of cement grout went. We don't know where it is went. It didn't even come out. It didn't even come out. Then we need to stop somewhere. So cutoffs for grouting was also redefined, redecided many times because it is infinite grouting. Infinite grouting. Let me tell you, particularly in S40, I think. S40 was infinite grouting because several lakhs of cement bags have gone and we don't know where it is going. So then, I said there is, all these ideas, where did it come from? Because we have done only irrigation projects there. There, water permeability is very important. But in this project, it is not. I said, why are you putting that 2 lugans restriction? You don't need to put it, but still, they have some guideline and the code they were insisting and the contractor were doing. Finally, they couldn't finish that. They stopped somewhere in between and come with a logical reasoning why we have to stop that. And we also did some tests using non-destructive testing to verify there are no big cavities, there are no major problem cases, and all that we have ensured and stopped the growth. Thank you.
Actually, you said that these dolomites, calcareous rocks, they have a lot of cavities. Even you can't predict. You can have many cavities.
I did say that, when I went first sight, I told you, I saw a huge cavity like this where even I can walk in. Okay.
Dolomite has a problem. Limestone reacts with water. Dolomites can even react with the air.
Yes. I agree with you. See,
Rock to play with.
no, their cavities are formed because of air circulation also was there. But the wind velocities, if they increase, and as you rightly said, we have seen that in maybe Ladakhi region also, quite a lot in Ladakh also.
Dolomite can react
Yes,
with air.
air also. Very right. I agree.
It is difficult to stimulate or model the beyond complex condition in the software. Then how you manage the design as you go approach?
Say it again.
Sir, it is difficult to stimulate or model the real complex situation in software. Then how you...
No, it is not difficult. See, today, software is anything you can model. Only thing is what properties you use is a challenge. Okay,
Then how-
but only thing is I told you I did not use any 3D modeling here at all, myself, from Indian Institute of Science. Because I did clearly say that I will not be able to handle 3D modeling. Even though we were doing some research using students and some papers have come, you might have seen my papers on this topic also, on the same case study also. But I clearly told the consultant that this is not in our domain. I will not be able to do it because they were also working with against the time. So coming to the point of question of us, how did we model? The cross sections are very clear. We varied, and whatever cross section we have given, they have adopted that at the site. It's a construction is as I told you. As you go approach with the cross section, what I give, they did, and then they give me back the feedback. And some places we had some small slips, and that time we have to redesign the slope and go ahead like that.
Thank you, sir.
Okay. So thank you very much. I think there are 3 other experts giving you the talk. They will definitely clarify all your doubts. Thank you very much.
Also, we would like to give you a memento. I will ask Dr. Anil Joseph to present Professor Sitaram with a memento for this excellent talk. What we read in books, seeing that in reality is really nice.
I have to leave, kindly excuse me. So, I have heard from Sir how many times.
So it was great to see the presentation and, the fact that so much effort had gone into the investigation part, because as rightly said, it's a garbage in, garbage out kind of thing when you work with softwares. Unless you put the right properties inside, you never know what you're going to get. So yeah, the investigation part is a big, should be a big component of any project, and it's very clearly, it's tangibly it's there that a lot of investigation has got into the project so that we get the right properties. We'll just one or couple of minutes and we'll invite Professor Rao for his talk. So, So with that, it is our great honor and privilege to extend our warm welcome to our own Professor K.S. Rao. And it is with great respect and administration I'd like to welcome Sir to the stage for the presentations. He has been with us for more than 30 years and published, numerous 430 technical publications, an expert in rock mechanical testing, site investigation, geology, design, all in go, all solutions you can find, and, and also a very good human being, and he was critical in the geotechnical modeling of the Chenab and Anji Bridge projects. And I'm sure must have been involved in a lot of meetings with the railways to convince them that this is indeed possible. His leadership is also instrumental in steering professional bodies like Indian Geotechnical Society and Indian Society of Engineering Geology. With that, I will extend a heartfelt welcome to Sir, and Sir, we can...
Yeah, okay. Thank you, Sirali, so for the nice introduction. And ladies and gentlemen, I think most of us are also the students of the institute, isn't it? So very good morning still, and definitely so that I will take it to the good afternoon later. So we listened to the Professor Sitaram, a fantastic presentation. They have been they involved from the contractor side. FCONS is actually the contractor, and Northern Railway, Konkan Railway. So these are the owner side. So I am they worked for the owner side. Say that is Northern Railway and the Konkan Railway. So, but anyway, so the both sides should actually the merge ultimately to make this engineering, say the marvel. So my title of the talk is making of world's highest Chenab bridge, technical and social challenges. So we are engineers mostly, and we do the technical problems. We solve the technical problems. Convergence on the technical problems, so the whichever party you belong, so you will be able to come to a reasonable solution. But when the social challenges are actually the comes and they spoil the whole scenario. The social challenges, so they're normally spoken. But in this case, say the social challenges, say the took a very important role, and I am going to, say the deal with them as well. I feel that, so that I am blessed and unique position where I can actually take the not only the technical and social challenges. Very interesting. So the bridge details, so the Professor Sitaram, so the nicely elaborated. So the Indian Railways has ambitious, so the plan to connect the Kashmir with the rest of the India by rail. So it is desperately the Kashmir is actually looking to have, say the connection. See, from rest of the India, if you see it, say we see the trains, say from the childhood, but the Kashmiris, so they never seen that, so they're running the trains, so in their areas. And the country has actually almost, so the 60 years of independence, but still they have not actually seen the trains, so they're running in their areas. How desperately, say that they will be looking, say to have such, say the facility, isn't it? The present railway line available, so the only up to Udhampur, and then this is planned, so that to extend to the Baramulla, and this line needs, so the two bridges, so the iconic bridges. There are of course, so the several bridges are actually there. So one is, so the, as discussed, so the Chenab, and the other one is, so the Anji. So these two special bridges, so the crossing the Chenab River, Chenab Bridge, and then whereas, say the Anji is, say the tributary to the Chenab. So that particular, say riverlet also should be crossed, say with the Anji Bridge. Northern Railway wants to assess the global stability of the slopes at both these sites. So Professor Sitaram, so that has indicated that, say the analysis has been actually done, so the basis on the continuum mechanics. Means whether it is a 3 sets of joints or, say 4 sets of joints. So the joints are actually from one end to one end to the other end, say they are continuous. And we will be seeing it, say these are not ordinary slopes. So the slopes which are actually having, say the 600 by 550 square meters area. Did you ever, say the students have done, say any numerical modeling of a slope size, say the 600 by 550 square meters? That is impossible. Normally we do it, say the 20 by 30 or 20 by 30 by 20 or so. That is the type of, say the slopes normally, say we handle it. So these are, say the gigantic, say the slopes. So the project, say the starts with that Katra, and then, say the goes like this, and then this is, say the Benihal to Baramulla. As has been already said that, say the route is working, and, say the trains are actually going. In this, say that we have, say the unique bridge, that is the Pir Panjal bridge. So Pir Panjal, is almost like 11 kilometers length, and say 1.9 kilometers say overburden. You must be knowing it. Say the Pir Panjal is say the all the time say the cover with the ice, and then underneath say the tunnel is actually the constructed, and then this is actually the handled by the IRCON. So the trains are actually the running say the from there to there already. So this is say the Baramulla, and say the going say the from the Jammu. So these are the different say the tunnels and bridges are actually the coming huge amount of say the tunnels and bridges. The count is actually the here in 4 segments so the so many tunnels and say the bridges which are actually constructed in that. And then the Chenab and say the Anji Card so these are the 2 iconic say the bridges say the that's what actually we are discussing it. The Chenab river, that is that, and then so it is originating it say from there, and so the gradually it is going and going say to the Pakistan later, and the Chenab bridge is actually the coming here because this is the railway route, and then so the next bridge is actually the tributary of the Chenab is Anji Card, and so the here the Anji Card bridge is actually the going to be. So this is the time so the we entered so the to look into this the site and the project. So this red line so it is not actually the existing it, and then you have the lowly end, and then so the Katra end, P50 and P40. So 1, 2, 3, 4. So this is the abutment so the bridge, and then here the pier. And then this is another so the P50 is another abutment, and then there is no say the piers so the in between. So that is what actually makes this bridge so the very iconic so the in character. It's an arch, and then the total length is actually the going to be so the almost like 1 say the 3 kilometers. So this is a very a nice way of so the doing the comparison so the Eiffel Tower plus another 35 meters. So then you will be getting into the level of the deck of the bridge. So it's a huge valley. So the wind forces and not only the height, the wind forces are actually the tremendous. So my role is say the is this the stability concerns so the of the abutments and so the rest of the bridge. The construction of the bridge has altered so in July 2008 after concerns were raised over its safety and alignment. So the bridge is actually under construction. So all the piers are actually getting ready at different locations. Some amount of planning that has been actually done. So from 2003 onwards also the planning, 5 years done. And 2008 so the questions are actually raised. So this is what actually I am telling, like so the social issues so the comes into the mega project. That is, I am fortunate so that to be in that position so that to take on these social challenges and get the project so the put it on the rail. So the Railways has constituted a 7-member committee headed by former chairman Railway Board so the Mr. Ravindran to examine the issue. So this is exactly so the July 2008 so the some of the piers so the already constructed, and some of them so the 90 meters and 100 meters so the height they have been done. So then so the project so the got to a halt because due to certain reasons. So what is that so the concern at that time is the whole analysis of stability has been actually done based on say the limit equilibrium methods, assuming that say the joints are continuous through and through, and you have certain say the joint properties obtained say through the testing. And will it be valid? It is a discontinuous so the mass in a discontinuous mass so you should adopt so the discontinuum mechanics based so the analysis that has not actually been done. So thereby the railways so the wants to so the get it done, so the universal distant element code, and then, so the using the 3-deck. So not only the 2-dimensional, so 3-dimensional, so the as well. So these are the salient features of, so the bridge. Some of them already, so we are aware, and 1.3 kilometers, and, so this is very laughable thing, so this is what actually they estimated, so the 500 crores, so the but, and when the project is actually completed, so it has, so the expanded like anything. So the span configuration is, so the 505 meters. So in between, so there is no support, the single span, and the rest of the things, so that you can see it. And then the foundation type is RCC, rock anchors, and the file foundations in some locations, and it is considered as, so the zone 5. So the seismic forces, so the initial stages, so the lesser than this, so that has been actually suggested, because as per the zone 4. And then, say the site specific studies, so they have been conducted, and whatever that, so the we got, say that is what actually the finally decided to for the design. So this we have seen, so the earlier there are number of, so the piers which are actually the coming. These going to be, so the tallest almost like 113 meters, so the height, and this height is what actually the 359, so the meters, so the height. Here it is, it is a steel bridge, so the top, if you see it, tapered to provide the stiffness. So at this section, so the width is of the deck is, say 17 meters, and whereas, so the elsewhere, so it is much larger. So from the top view, if you see it, so it is getting narrowed. So the stiffness is actually going to increase it, so in the system. So this is some of the details about, say the piers, etc. Design basis is that, like, say the virtually the 2 tracks or 2 timbers, but presently, so the 1 track is only seeing. So maybe, so the in future, so it is going to be the 2 tracks, and we have seen, like, so the design life is actually the 120 years, and then, say that this is the speed at which, so the trains are actually going to run. So the now, so the some of the other highlights are there. So this we have seen like 1.3 kilometers, and say the arch span is, say the as that, and lot of site investigations, so they have been conducted. So in the earlier presentation also we have seen, like, so the so much of, so the investigations, so they have been actually done, and the laboratory testing on the intact rocks, so the as well as jointed rock mass, so that has been conducted, so the at IIT Delhi, and so many geophysical, so the tests are also conducted, so to get it. And then IIT Delhi is also, because the IIT Roorkee has actually done 2003 the site specific studies for any important project, so the one needs to do the site specific analysis, not really following, so the caudal provisions. Caudal provisions are actually not based on purely the scientific, so the monitoring it is based on, so the geology and the tectonics. So thereby Himalayas normally, so you classify at zone 5. So zone 5 seismic forces, so they normally adapt for the ordinary structures. But if you are doing it, so the very important structure like this, so that you need to do the site specific study. Site specific study is very, very involved, so that is what has been actually done by the IIT Roorkee 10 years before. And then, but subsequently, so the many earthquakes, so they have occurred. So thereby, we did, say again site specific study for designing, say the for fixing the design parameters. So this is what actually when we entered, so the no bridge, nothing, and so the only the drift is there. The drift is actually that. So this is one side, and the other side slope, and then, so the bridge is actually going to go come like that. and this is the maybe the expected location where so the two abatements are going to come, like so the P40 and P50 so they are going to be here. So thereby, how do you get so the in spite of all your best so the geotechnical investigations, still you won't so the get so the real feel of the rock mass, because on the top layers so the you will be always having it so the more amount of cracking and the material will be weathered, etc. So what we do is so that we go to the drift in the sense so that there is roughly say 4 or 5 meters so the diameter cavity that is been created into the rock mass, into the hill, and so the length goes so the up to 100, and then there is going to be a cross drift also so that will be made. So from the other side so if you see that so the small rat hole is there, so that is the rat hole which is actually the virtually going so the along the axis of the bridge, so thereby you will be able to know it so the what are the rock condition so there. So the other side of the slope is actually looks like this, huge channels of so the water channels are actually there, so the drift is actually created there. So the both sides so the you have the drift to get the rock mechanics so the characteristics. So in any slope stability so the toe is very important. So we just so wanted to see it. This is so the almost like so the center of the axis of the bridge, and then so the toe, if you see it it is like this. The formations are dipping against the flow of the water. The river is actually flowing this way, and then beautifully so the laid so the dolomitic so the rock is there. The close up looks like this. 3 sets of joints are actually there. You do have so the J1 so the J1 is the joint so the or the foliation plane is actually there, and then so the this is one set of joint, this is another set. So it comes from the like so the dolomite is a calcium magnesium carbonate, and calcium carbonate is calcite is rhombohedral, and it is a 3 sets of so the planes will be there. The same thing is getting repeated so the as well here. The angles are not perfect cube or perfect so the rectangle, but so the you have so the differences of angles will be there everywhere. So the rock is actually having the same. This is one set of joint, horizontal joint, then the 2 vertical joints, they make so some angle that will get repeated everywhere, but rock mass is so the in a very tight condition. Even if you have so the any the excavation you make it say a tunnel or so, it is not just say free flowing. Say normally so the people talk Himalayas means very loose rocks. Before the project really took off so that they're great so the rock mechanics people elsewhere from the world so that they came and they said that so why this project, it is a very the Himalayas are so the or so having lot of so the joints and things like that, and so the any major project should not be done. This is absolute nonsense so the Himalayas are not actually free flowing type of mountains. They are the world's largest mountains so the 10 kilometers on the top, and then almost like 100 kilometers below there is a route which is actually there. That is what actually gives so the 3000 the length so the meters of the kilometers of so the horizontal, and then almost so the 500 so the kilometers of so width is there. There is a mighty mountains so in the Himalayas. If we know our engineering well, we can actually do many so wonderful projects in this. I will come back so again to that. So this is the exactly so three joint sets so will be there. This will repeat because the character of this material is actually such that so it forms the say the 3 orthogonal so the joints which actually form. So more clearly this is the joint so the J1, and then so this is the J2, and this is the J3. Roughnesses are actually the different. If this is actually the controlling it so the shearing is easy, but if it is a little bit difficulty, roughness is actually slightly more than this, and whereas so this is very rough joint. if the J3 is controlling, so your slope, so the stability, so then, so you will be rest assured, because so much of interlocking is actually going to be there. So thereby sliding is not actually the easy to happen. But whereas, so if this joint is actually the controlling, so your slope, so then, so you will be having the issue. And many times, so there are shear zones are there. This is what actually the since it is a lime based, so if the joint forms, so after that, so it will get, so the joint together. Say if you take a granite and if you break it, so it never, so the joint together. But this particular, that is the reason why the Himalayas are actually the maintaining that height, because even with intense, so the stress is actually they acting it, even if they are breaking it, but then, so they will get joined like our bone. So if a bone fracture is there and you set it, and then, so it will get actually the set, isn't it? The same character is actually there, so in the lime based rocks. This is a lime based, so the carbonaceous rock rose from the, so the sea water. So this type of, so the joining is actually going to there. That is one of the reasons, so the why Himalayas are actually standing it in spite of, so the intense, so the stresses. Okay, so lot of, so the geological, whatever the investigations that have been actually done, we are not really satisfied. So thereby we did, so the additional, investigations, say for our, activity. So you see that, so the group after group, so we go to the field, and, so the many of my students, so they got so much of good training, so in these places. It's a fantastic, so to map the joints and their character, and then, so the properties of the material. Many places, so somebody has already told, so not only the clean cut, so the joints, the 3 sets of joints, so but, so due to the weathering, due to the flow of the water, so you can get the some of these, say the cavities and, say caverns which may be there, so in these rocks. So also like, so they you see that, say a good rock, but, so because of the flow of the water, so over the millions of years, so you will be getting this type of, so the channels as well. It is not that, so everywhere, so the channels are actually the present, especially the surfacial, say the slopes, so you may be having, say this type of indications. So summary is, say the site geology is, these are the Shivalik formations, free tertiary, and, say the 66 to 2.6, say the million years back, these formations, they are younger formations of the Himalayas. Okay. Dolomitic limestone with different degree of, say fracturing and weathering, 3 sets of joints, as I said that, and there are, say chetty, bouldery, brecciated, and moderate to highly weathered in some places, and no major shear zones are there. This is the most important, so the positive point, so the in the rock. So the rock mass is highly interlocked. So this is also one of the beautiful, so the thing to happen, so that the rock mass or the hills are actually fairly stable. Massive and compact, dolomite, that is the magnesium calcium bicarbonate, so that is what actually the normal composition. It is not actually no solubility in the water. It is not just, quickly, so if you put it in the water, it is going to dissolve. So this is the boreholes which have been actually conducted, gone up to the 150 meters below. 150 meters, so you see that fairly the similar type of, say the bedded, say the dolomitic, so that. So when you do the number of boreholes, so along the slope, so you put it, so as a combined diagram, so thereby you will be knowing it, so if there is any variations are there, so they can be accounted very well. So similarly the other side, so the slope. So once the slope is actually there, let's see like, so the S40 or, so the and 50, this is one slope. So that is what actually the slope, and, so we will be cutting it, so for the foundations, so the different, so the piers which are actually going to come at different locations, we will be taking the top layers, so and getting, so the proper foundations, so you will be cutting it. So thereby the stability is, say for the natural slopes as well as, say for the cut slopes we'll be getting it left and both left and right. So this is the drift that has been actually spoken earlier also. So these drifts are actually the holes which are actually made so that you can actually map the joints, so they very well, and also like so you can conduct the in situ stresses, so they here like the plate load test and the direct shear test can be actually done on the rock mass which is actually there. This is my head. So, so you can see that, say the 1 meter by 1 meter, say square block, that is you cut it in the rock and then, so you apply the normal load and shear it. How do you apply the normal load? Yeah, this is the mapping. So along the axis and across the axis, the joint mapping is actually done, the RQD, RMR, these classification systems which qualifies, say the rock condition. So that all comes, say from these, say the of course the previous one is, so the either side, this is the kinematic analysis, very powerful, because if you have the joint directions, so you will be knowing it, so whether the joints are actually getting intersected, so thereby any wedges are actually forming it, and if the wedges are actually forming it, so that you will be making the stabilize them, so that, so your slopes are actually, this is the normal process, and then we established the left and right, so the strike dip and dip direction, and so the number of joints, so their directions etc. all done. Not only that, so even in the earlier presentation also you have seen like, say for the different piers, so that you have done the excavation, and that excavation, say the pit you can, say get the joint mapping, so that thereby the orientation of the joints, so the known. So the number of piers are actually coming on the top layers, so that you have the weathered materials are actually there. So thereby definitely your foundations are actually going to go on the farm rock. So similarly, like, so the huge amount of geophysical testing has been actually done. We have done the geophysical testing, to do the site specific, so the seismic coefficients. So for this, the attempt has been actually made. Before talking about the stability, the UDEC and 3DEC, so I need this information, these parameters are actually required and when to do the modeling. So thereby I am introducing, so all these studies that has been actually done. So we did the seismic refraction, we did the MSW, so we did the micro tremors, small earthquakes, and then, so this is the OYO equipment from the Japan. As you know, like, so the Himalayas are along this, say because the Indian continent is actually pushing it, so thereby the range of the Himalayas are actually happening it, and most of these along this MBT, so you will be having it, so the most of the earthquakes. Even 2 days back, so we have the shocks, so of course that is, so in Haryana. This is the equipment, so the IIT Delhi got it, so we acquired it in 2001, so after the Bhuj earthquake. At the time, so we got this equipment, very, very sophisticated equipment that is actually available in IIT. This is established by us, so we have used it for the several microgeneration studies, etc. So this has been, so they used it, and so you can get the VP and VS, so through this particular, so the software. So these are how we do the assessment of, say and also the micro tremors study is, say very, very important, say for the earthquake geotechnical, so the engineering it. So we don't, say the much believe in these, say say they are based on, say the whatever the joints which have been actually mapped, say the RQD, RMR, Q, and say the GSA classification systems, and say the real testing. This is the dolomite. Dolomite looks like this, so it is a gray color, so the rock. So you see that, say how do you get the Poisson's ratio and say the modulus of velocity? We say that we assume it. We assume it, so the most of the designs are actually done by assuming it point of, say the 0.2, 0.3 or something. Rocks are different. In soils, so the maybe, say Poisson's ratio is 0.2 or 0.25. But in rock, so it is a positive values. It is, say the 1, 2, 3, 4, 5. Can you imagine that? So it's a huge amount of, so the testing has been actually gone into it, stress strain curves, etc. And say this is the field test which I was talking about it. Say in the drift you can actually do the plate load test, large scale plate load test, and get the cyclic test that has been actually done. So thereby you can get the modulus values. So the close up of is actually that. This is done by the CSMRS, so the in this area. So similarly, like you have a you have the plate load test is also done. Plate load test at different normal loads. So you need to do it like so they at least so the 5-6 blocks you cut it and you exert the normal loads, and under that so you do the shear. Then only you will be getting the joint shear strength properties. Otherwise how do you so the with what parameters you will be doing the design. Apart from that, so the IIT Delhi has actually developed a beautiful facility, that is the direct shear, so the apparatus. Direct shear apparatus is 30 by 30, not by 6 by 6. 30 by 30 centimeters, so the rock joints, you can actually do the test under the CNL and CNS conditions. So we have, this is the equipment which is actually there in IIT Delhi Rock Mechanics Lab. And you see, why did we use it this? So this is so to get the parameters for the design parameters for this particular so the bridge. So this is the Itasca team. Itasca is say 3-deck and U-deck, so they are the owners. Itasca is actually this is the Itasca package. So Itasca, so the people they came and so then they were just so they seeing it, so how we are actually getting the joint parameters, etc. So this is the Itasca team in my lab, so they were discussing it. You see that say the broken say the rock pieces. We wanted to get the shear strength characteristics of those. How do you get it? You cast it in the plaster of Paris and one over the other, and then so you shear it so they are different normal loads. So this is the so apart from that so we know it so the stress state is 3-dimensional, isn't it? You have a sigma 1, sigma 2, sigma 3, and you have the 3 sets of joints are there. How that joints are actually going to be affected so by the in situ stress state. The Himalayas are actually having a very huge amount of horizontal so the stress. That is the reason why they rose to that levels. So are you simulating it so that type of stress condition? If you are not doing it, so and you take some sample and do some tests, that is no relevance. You need to exert so the stresses under which say this particular material is existing it. This is another say the true triaxial tests. We have developed a facility, and then using that facility say the conducted say the so finally say you got these parameters. And then I said that so that we have done the site specific so the studies as well. That itself is a major so the study, and say the normally the site specific studies are actually conducted so the if your site is say the here 350 kilometers radius so the whatever the events that have been actually occurred in the past, and say the also the joints which are actually available, they all will be taken. It is a very intense say study, and I will be just say the quickly there are so many joints so the major fault systems which have been actually identified in the Himalayas within the 350 kilometers, and say the so the based on the different models say the you get what is the amount of say the energy that can create so the or what type of the earthquakes so the what magnitude earthquakes so they can be created so that will be accounted. So then you have so the you create the hazard so the curves, and then again those peak ground accelerations so the finally you will be capturing it what type of joint is actually they can create, so what type of P ground acceleration. That depends upon, so the how far from the site, So that is the reason why we have taken, so the 350 kilometers. Normally, so the 300 kilometers away, if the earthquake happens, so its influence, so the on the it will be very, very less. So thereby 350 kilometers, so it goes. So finally, so you have the response spectra, so for 5%, so the damping that has been actually there. So we got, so all the material, so or the conditions or the properties, which are there to do the analysis. So these are the peers, so which already, so we discussed, P10 to, so the P90. Just, so look at P40 and P50. What is the size of these footings? The size of the footings is, so the 50 by 36 square meters. The foundation of the pier, so the abutment pier, either side of the hill is, so the 50 by 36. 50 by 36 to cut it, that how much area you are, means, how much amount of material that is being, so the removed, so the from the hill, so that to make this particular foundations. Huge foundations. Rest of the other foundations are actually the fairly, smaller. This is where actually the after 80 slides, so I am coming, so to my modeling. This introduction is actually the required. So, but anyway, so you see that numerical methods, you all know it, and continuum based, so the mechanics, FEM, FDM, BEM. And the numerical codes, so the flag, phase, flaxes and abacus. All students normally we use it. This is a continuum based. The joint is actually having the same properties, and they are continuous from the top to bottom. So, but whereas, so the railways have actually asked us this, means they have something in mind. When they came here, they came to us, so we were not knowing it, so what was the intensity. They said that we just wanted to, so study the slopes, so the using, so numerical codes, that is the UDEC and 3DEC. So as usual, so the professors are always, so they very, they won't understand, so the matlab ka cheez. So thereby I said that, okay, we will do it. We'll do it in 3 months or 2 months. So something like that, and very peanuts. So we agreed it, but then that is our entry point into the system. And then since then, so we have been actually working, so on different, say project of the railways. So I won't take, so the much. This is you can get it, so allows the finite displacement and rotations of the discrete bodies. If you have the 2, 3, 4 sets of joints are there, so it is a broken rock. So these blocks under the stress, so or under the excavation, they will be moving it. So there is a rotation, there is a sliding is actually going to take place. That should be accounted, so in your modeling it. Means your package, whatever, so you have, that should take into account. So recognize the new contacts automatically, and so the calculation, so the progresses. So the blocks will be moving it, so the little bit, so as the loading is actually taking place. So that is the basis on which, say this particular program, so UDEC works. It is extensively used for the underground structures and slopes, influence of the rock joints, faults and bedding planes, explicit time marching, so they solve the equations of motion, progressive failure, and to study the potential modes of failures. Potential modes of failures are also you will be able to get it, so through this modeling it. It's a very sophisticated modeling. When did we do this? We did it, so in 2011, 2010. 2010, so you don't have the computing facilities, and one program, to run it 18 days we used to take it. And if you combine, so the dynamic motions, dynamic the forces, so the model won't actually run at all. So such a say the computing power is actually required. So thereby now, so I will be skipping all these things. So this is how actually the whole mechanics of the UDEC and 3DEC, so works. So also you can actually give the earthquake, so the forces. So that is what actually we did it. So first you do the static analysis, and then after that, so you get into the dynamic analysis. This is a discontinuum basis. Continuum basis, let us say one set of joint, second set, third set, 4 sets of joints. They are end to end, so they are continuous. But whereas if you see this model, this is, say 600 by, say the 550. And then each joint is actually having the bridge and gap. Bridge and gap means, say if you have, say the 300 meters of joint, that 300 meters of joint is actually the cut into number of bridges, number of, say the gaps. So thereby now just imagine that, say the how much computational, say the vigor is required to, it's not one single joint. Each joint is actually now cut into 10 pieces, 20 pieces, and that need to be, so they accounted separately. Now this is what actually you have a model. This is all actually discontinuum model, and then after that, so you subject that, so to the whole model is actually, the whole slope is actually subjected to the earthquake forces. It is a tremendous, so the challenge that has actually gone into it. To finally you see that left abutment, right abutment, what are the critical? So you run the model, so with the jointed rock with the pier loads, because ultimately the pier loads are going to come, plus the jointed rock with pier load and the seismic loads. This is the most, so the critical cases, isn't it? The yellow one is the most critical in all the categories. This is the natural slope, and then this is the cut slope. What is the difference? The natural slope is, so whatever the profile which is actually the existing it, but the cut slope is, we cut it as per our foundation requirements. Let's see, like, is it natural? Yes, it is natural, so the slope. Natural slope, and these are the points which have been actually fixed. These are the points at which, so we will be having the foundations. And not only that, since, so the cutting was actually not done, so when we are doing this analysis, so thereby 10 meters below, so again we put the monitoring points, because assuming that, so it is a rock, but still, so up to 10 meters they will be chopping it off, so for their foundations, etc., until they get, so the good rock conditions, etc. So thereby we did the analysis. So the cut slope is actually something like this. This is going to be the different than, so the what is really done, so the when they have cut it. So this is the major thing, so that has been actually contributed by IIT Delhi. All the analysis, so whoever is actually done, that is actually taken these parameters. So these parameters have been actually fixed. This many parameters are actually required, so to do the analysis. So, but we did the slide and slide. So why did we do the slide? Because that is easy. So when you start the problem, so the already limit equilibrium methods are available. So thereby you run it, and so you see it, so the what happens, and then subsequently UDEC and 3DEC, so the for both, so we did not only the Chenab, so the Anji also has been actually told that it is a originally thought, so the arch bridge, and so for that also we did it. This many number of, so the properties which are actually required for each location, and then to cut the story short, so you get the factor of safeties. Factor of safety 2.6, and all these, so critical cases, cut slope with pier and seismic loads, it is 1.4 and so the 1.4 roughly. So fairly, so the stable, and these are, so the different, so the at each point the numbers are actually indicating the monitoring points which we have selected. So this summary is actually very important, because the critical cases have been actually accounted here. So the jointed rock, that is 1.96. Jointed rock, so the pier loads are exerted, that is 1.6 roughly, same. Means these pier loads are not really affecting it, anything, because they are very nominal. Then, so the 1.94, this is critical, this is most critical. You have the jointed rock, and you have taken the pier loads, and you have also taken the seismic loads. So obviously the 1.6, so the 3 gives that. Then similarly the second slope, and then the analysis, and then summary we will see it, say that. Yeah, this is the summary. Left and right, say the both the slopes, so they are fairly having it, say the good amount of, say the factor of safety. So you summarize it, and then so it goes something like that. Limit equilibrium, the bishops and janbus and other things, but then say the the UDEC, say the results are fairly, say the good, and summary you give it, say that factor safeties are very good in all the conditions, so the taken into account. That is all the joints and all the say the pier loads, and also like say the maximum seismic forces that has been actually the subjected to, and under that condition say the as Professor Sitaram said that say if it is more than one say that you don't have to worry, because that is the worst condition you have. Here it is say that we proved that say it is 1.6, 1.4 or so the worst condition, so thereby the stability is not say an issue at all. And how do you know it? Yeah, we have say the in the history there are so many important say the structures that have been actually there. We compared it, say we took say that the factors of safety worked out are highly adequate. Further, it shall not reduce with passage of time. These comments so that I will respond it subsequently why I am writing this. So now the interesting part is actually the starts here, say the first you establish it technically, say the your slopes are actually the good, and then say the we need to clean up the people mind as well, their understanding so they as well so the with this. So I will skip so these are the different outputs so which automatically comes so the 3-deck is much more say the complex. Why 3-deck is actually much more complex? Earlier you are doing it so the only the height and so the length of the cross section of the but here so the whole chunk of mountain so you are going to do the modeling it. What it means? Earlier I was taking it so the only say this and then this face so I am taking it. Now so you take the 3-dimensional. So if you take it so this is the center of the bridge say the axis, and either side 100 meters means 200 meters, the whole mountain is actually the cut, and all the joints so which are actually available so they are taken into. Can your computer will work? The UDEC itself is actually having the problem, and now I will be doing it so the whole mountain so the is discretized, and so they divided into smaller elements, and each element is having a rotation, and each element is having the moving. So it is a tremendous so the challenge that has been done. Like your brain is can be actually studied in the doctor's language so the into 63 slices from starting to the end so the you all these so the you put together, so then you will be getting full frame of your brain. Same way this is so the you divide into slices and get say the forces which are actually there. Finally no, don't think that so I am ending with this. Conclusions means normally. The real story starts now. So the extensive numerical analysis is carried out so for both abutments, UDEC and 3-deck, and discontinuities of the joint sets are simulated in the analysis. Both static and dynamic classes are considering into different loading systems, etc. Somebody asked like monitoring karta hai. Numerically monitoring so that we can do it so the how the movements are actually taking place say in the system. Okay, so even otherwise also so that we have suggested to the what Sandeep Gupta ji so they said that monitoring is actually the going on so the in the slopes as well in the system wherever it is required. So the dynamic cases are most critical, obviously, and and then no considerable changes are observed in the foundations. Somebody asked like so what is the differential settlements, etc. So they are very very minimal. So this study takes care of so the every location so the what type of movements are actually the possible UDEC and 3DEC analysis revealed the slopes are stable with respect to the factor of safety under the different loading. Long-term stability measures are suggested. This is what actually you have to do it. Today is you establish that is stable, but then so if it is 120 years, so it has to last. Are you sure? How do you make it sure? So that is our role, to make it, so thereby the slope itself is stable. It doesn't mean that why to spend the more money on making it more further slow. So no, you have to do it. You have to do it because today is not that you are talking about it is 100. Oh, sorry. More than 75 cases were analyzed and detailed reports submitted to the committee after the peer review and independent vetting by the Scott Wilson. That is the agency that has been actually created for vetting all the designs, etc. So the Ravindran's committee accepted for the adoption. All stability issues are settled. We started with a problem that somebody said that it is unsafe, and you do these studies, did the studies, and then thereby proved that it is safe. So thereby the committee said that no, so no fine, so that you go ahead with the stability. Means tab tak the project band ho jata hai. If a project stopped, who is at loss? The project is actually going to pay heavy price, to the contractor, etc. Contractor labor, contractor force, contractor equipment, etc. They are all idle, but for that, you need to pay it. The project got the green signal for its resumption. Fine. This is what actually happened. This is very interesting for me. Say my name came, so that KSRO has actually done, so the studies, and then the bridge is now safe, and so then the new energy comes into because the project stopped and the project is actually getting, सबसे ऊंचा रेल पोल का रास्ता साफ, or say the सबसे ऊंचे second largest, say it's a very beautiful everywhere, so it is then say the railway minister, say the Mamta ji, and she also on radio, and see that how the progress, so the starts. Once you got the oxygen, and you will be, say the project is actually going, so with next. These are the pylons, say which will be installed 127 meters, so the high pylons either side, because every bit of the bridge is actually taken and put it there. There no say the support from any bottom or anything. It has to go through this crane only. We will come back to that. See that say all the slopes are getting cut, and say the properly shotcreted, gunneted, grouted, say the wherever whatever is required, say that is being say the attend to. And then now, so they got a shock. Shock is, say the PEL, that is the public litigation interest, public interest litigation. In the Delhi High Court, so the case was actually filed by somebody, and 2014, 2015. So Alok proposed an alternate crossing of Chenab on a Google, say the A4 map, and with support of the Prashant Bhushan. Who is Prashant Bhushan? Okay. So I am Alok, take a A4 size sheet, and I say that from Baramulla to Jammu, this is the route. Okay. No, you are going in this route, but that is not correct, and then this is the route. They can go to the court, and then so the railway people cannot actually stop that, because it is a government of India, so if somebody is actually put a case, so obviously it has to be settled, so properly. Whether the person who is actually putting the case is, so is correct or not, so they have to evaluate. And until that, so the work stopped. As it is a technical matter, the High Court, because this is actually put into the High Court referred to 4-member committee, again headed by engineer ES. I won't actually decode, so what is that. You can actually do that. I will just put it there. So that means, say this, it is already, what this sentence very as it is a technical matter, the matter referred so that to a 4-member committee, again headed by, again means earlier also committee, that committee is also headed by the same person and with the members, and that this time is also referred. Okay, this is court has actually referred. The committee met for 2 days in Delhi. I made a very, say the, I don't say that I have done a wonderful presentation, but I did it so very well, giving all the technical details and things like that. The detailed presentations were made and clarified. Other stakeholders are also made the presentations, etc., about the details. And then, so we thought that, so okay. He said that, so the Professor Rao, you have made a fantastic, so the presentation, very detailed, and I got, so the good answers, so from all the thing. Second fatal blow to the project. This is the committee sends an adverse report raising mixed up issues and changing the goalpost. See, please, so the understand this language, so the I put it in very. So you have a goal post, and if I am changing the goal post, you never got into the goal, isn't it? So the committee is actually changing the goal post in their comments. Northern Railway, because Northern Railway is the owner, so they have to, whatever the comments, so which are there, so we all struggled and, so they put it together, responding it, so to the court, say these comments, response to the comments. That is, we made, say 500 page, say the strong rebuttal, and then put to the normally the railway board won't come into the picture, and so you submit to the court. But this is such an important, say the project. So the railways, say in their wisdom, so they said that, so we'll put it to the railway board. So some more strength, so we can get it from the railway board. The presentations was made, say to the railway board. This, I have to tell this, say the railway board is, say the 6 or 7 members with the chairman in his chamber, and then, say the CEO of the railway, Konkan Railway, is making the presentation on complete, say the different issues, different tunnels, different this one, full project he is explaining it, and including, so the Chenab. Luckily, the railways, they requested me to come and sit there in a table corner, so that I was sitting it, because I did the analysis. Okay, that is the luckiest moment, so that I am telling you, like, so that I was sitting it. A CEO is actually presenting it. 1 hour passed, they were listening, they were just chit-chatting it, all like any other. So they were asking the questions, and now and then, so that I was responding it about the slope and other things. And somehow, after 1 hour of discussions, I felt that, say the things are going out of the grip. It's a do or die. Then I got, some sort of, so the bold energy in my presentation is actually getting completed. Now the board is actually going to say anything. So before that happens, so I told that, say the look, sir, say the stability of the Chenab is the main crux. The analysis is actually done by the IIT Delhi. When I say that, I always take the IIT Delhi, because that is the strength, so on which we are actually living it. It is not me. So IIT Delhi has actually done, and I have the presentation with me. I wanted to do the full presentation, so that to you, if you have the time. Chairman, so the Professor Rao, so the fantastic, so the, we wanted to listen to you. But give us half an hour, because in the in the next door, so the railway ministry is actually coming it. Siliguri, the line is actually going to be operated. That is only the electronically, so they have to switch, they press the button. We will come back, so the here in half an hour, and so we wanted to listen to you. They went away. And then, so the meanwhile, so the railway people, the Northern Railway, they said that is a big hall, and then, so they put the chairs with the rest of the other stakeholders who are all there, foreigners, etc. They're all sitting in the downstairs. They all, so the brought up, and then, so everybody is ready, and I was actually ready, and then I gave the presentation. Responding, so the finally to the queries, what, so the has been raised by the ES. These are the 5 things, so which they have the same slides. So please mind you, like, so the same slides which I have actually I have been using it. My presentation title is, so the technical and social issues. This is the type of, so the things. Okay, first one is, so the factors of safety worked out are inadequate. Further, it shall reduce with the passage of time. That is one comment. The second thing, Chenab Bridge is located near the MBT, main boundary thrust in the Himalayas. So you have the major fault systems are there. So you are close to it. So thereby you are asking for the trouble. So here hence prone to the high seismic hazard. The bridge is located near the LOC line of control. So the unloading of hill slopes may result, so the instability. The bridge location is near the landslide prone area, thereby endangering the stability. Professor Golsar, Geoconsult, has raised concerns on the stability of slopes. Do you know who is Golsar? We don't know. I don't know it. We will come. So the first question is, so the factor of safeties that have been actually obtained, so they are inadequate. That is what actually. It is, so the taking into consideration of the highest, so the seismic forces. Okay. And, so the earthquake of, so the 8 plus, so the can generate that type of coefficients. So we have used that, so the for the design. So, but how do you prove it? So you get the complete, so the elsewhere across the world, whatever the major structures that have been actually constructed under the seismic loads, what factor of safety is, that have been actually taken, that I have taken it here. See, like I am showing it, so this table, earth dams, earth designs, or federal highway, so the ESA recommendations, etc., etc. And many more, so that we have everywhere. You see that, so the factor of safeties are, so in the static condition 1.4 and in the dynamic condition. So thereby the factor of safeties worked out are highly adequate. Further, it shall not reduce with passage of time. So the comment is, so with time, so the factor of safety gat jayega. No, it won't happen, because we are going to do a lot of, so the stabilization measures, etc. Okay. The next comment is, so the located near the MBT and hence the prone to the high seismic, so the hazard. As regards to the proximity of site near MBT, this is to place on record that IIT Delhi as well as is well aware of the seismotectonic activity of the region and has considered all the available structural features like faults, lineaments within 350 kilometers radius of the location. And 55 seismotectonic, so the features from far field and near field, such as, say MBT, MCT, Jwalamuki faults, etc. considered. With 15,000, say the past earthquake events have been actually considered here. 15,000 past earthquake, say that have been actually taken into account to generate the earthquake forces. Further, both the deterministic and probabilistic, so the analysis were actually carried out. Based on this study, IIT Delhi finally recommended a value of seismic coefficient of 0.33 G for the Chenab Bridge. So, in fact, Jwalamuki fault turned out to be the more hazardous as compared to the MBT. MBT is actually the much farther than, so the location of the bridge. So, thereby, what we are telling is, Jwalamuki is actually closer to it. As such, there should not be any reason to unduly worry about it. The maximum seismic forces have already, so considered, so for the design. That is the a very decent, so the response. Now you talk about, so the bridge is located near the the line of control. This is a fact that so the bridge location is near the LOC and cannot be changed. It is not the railways have taken means so the LOC, yeah, it is close to the LOC. What is the problem? However, the government of India is constructing number of hydroelectric projects near the LOC. Hydel projects are always so the more complex and intense than railway projects. Failure of hydro project is much more disastrous than a railway project. So far, none in India. We have so many more than say the 6,000 hydel projects which are actually there so they're very close to the LOC. But so so far so the Indian dams failed or Indian hydel projects so they failed. It never happened. So far so we not had 6,000 so the projects were actually there. What is bridge? Bridge is nothing. It is a steel bridge. Even if something is actually goes wrong so you weld it and so they run the train. There is nothing so the great about so the bridge. So I told to the committee, so we should actually do all our projects so on the LOC. You align all your projects on the LOC. At least your LOC is so the clear Your LOC is clear now. So defense is not yours. Railways are not actually the RB so that. They only so what is good for the transport so they designed it, they constructed it, they are constructing it. So if any problem is there so they report to the army will take care of it. So thereby at least so your LOC should be pakka. All project so you put it align on the LOC, so that at least we know it so what is the boundary for the country. This is exactly the words so I used it so to the railway board. For the development of border areas, we have to take this risk. Are there not people? They don't have to see the train. They don't have to travel so that. Why on the road so they have to travel, and in between so the Benihal and so the there so always the landslides will be there. The trucks will be actually the station for days together. So this nonsense should be stopped. So thereby so they also so the required so the good facilities. We are very proud of China at the time. So China is actually doing the under the Himalayas so many projects are coming. China the other side, and we are this. The Himalayas are there. Same rock conditions. You feel happy so with the China is doing a project. Then I told to the committee, if you are not doing this project so you are pushing the country another 30 years. What is that so that we hear in the every day in the newspapers, some rape, some looting, some so the dacoity. That is what actually 1.4 billion people so the every day is so worried about their daily life. If a engineering marvel is actually done so by the Indian engineers, what will be the psyche of the country? It will be fantastic, isn't it? One cricket match so we win so we feel so happy. So why don't you give say this when we say that it is safe and everything so why don't you take so and push this so the project? Exactly, because I don't have to lose anything. I am a professor. मेरे को कोई touch नहीं कर सकता है. So that type of so the guts so the has been actually told to the committee, and then so the China is also developing so the mega projects. Fine. You see this so the unloading of hill slopes may result in instability. Unloading results. This contest so that came into this one when I was actually explaining to the chairman first time, like we are doing so the so much so material is actually cut for making the foundations. So thereby they are worried. At the time they are thinking, huge amount of concrete so and the bridge is actually being put it on the hill, so thereby the hill is actually going to settle down. That was actually the opinion. Then to counteract, so what I said to all the engineers and so the committee, so this is the load which you are putting it. For that, you are doing unloading it, and I made them calculate, how much unloading you are doing it. So this much of weight you are removing it from the hill. So thereby, what happens is, say if the load is unloaded on the immediate formations, they will warp up. So unloading may create some say slope instability. This is the word I used it. So Professor Rao is telling that, so by cutting the hill, so the unloading we are doing it, so thereby the hill is actually going to be unstable. So this is what actually the comment, so the origin of this comment is actually this. Unloading results, so the only in dilation, opening of rock joints, so at the top 1 meter, 2 meter, say that's it. The unloading of the hill slopes does not make them unstable. The excavated, so the surface should be therefore strengthened after the excavation by means of, shotcreting and other methods. Why we are putting these methods? You put a bolt of, so the 32 meters, 40 meters, 50 meters inside, and you grout it and you tighten it. Why are doing it? Because you wanted to keep everything, so that together so that, they never come off. So these measures are already taken, taken at the site. So this will also improve the general stability of the site. So with the provision of, say proper drainage system, due maintenance, and the factor of safeties are not likely to reduce, with the passage of time. That is the engineering, all about it. See that this is, say the non-existence. He says that, say the landslides are very close by. So the landslides are not actually in the site. So thereby we can dispense, say the this one. This is very important. The last comment is, say Professor Golsar, the GeoConsult has raised the concerns on the stability of the slopes. To the best of our knowledge, Professor Golsar has not carried out any detailed stability analysis of Chenab Bridge. Without any analysis and supporting documents, the general comments should not be given undue importance when IIT Delhi has carried out extensive studies on the subject. Now you enjoy that. You take me to the project as an expert, and I will say that, wow, Sandeep Gupta ji, so that you are doing a great job, fantastic. Oh, आपने बहुत अच्छा बनाया, करो. ऐसे बोलता है तो then tomorrow you won't call me. I had to tell, oh, what man, so what are you doing it? What did you do with the slope? Oh, this slope is actually the unstable finish. So then he will ask me, please, give the solution, what I should do it or something. This is the way things goes. So the same slides, whatever I have presented, so that to the committee, I am presenting it to you. Same, nothing is changed, so the here. Then what happens? I never seen that, so that reaction. The chairman, so the pin drop silence. He said that Professor Rao, so we have not listened to any presentation like this. You are not from railways, but so you are so working for the railways. We feel so proud that so today we are so having listened to you. Rest assured, it is done. Court cases, all these things, so is all, it will get finished, so immediately. The RB, that is the railway board, so the bold and took a unanimous decision and signed. They also said one more thing, I don't know whether it is correct or not. We never write, we discuss, we never write minutes. We don't have to agree, so or disagree. We have expressed our opinion, and people who matters, we if they ask us, so we give our opinion. But in this case, we are writing the minutes and we are signing, all of us, so the signing and submitting to the government. So RB bold and so they took unanimous decision and signed. Met railway minister, in turn met PMO. The final decision was made, so by the government of India. What it means is all the cases are actually finished. and the announcement came from the Srinagar, so by the railway minister, that still, so the 15 days, so in the site we were not able to. Everybody is happy because the project is actually got the second life, etc. But all the dumpers and everything is all there, so the people are there, farmers are there, and nobody is having some lethargy because 2 years, so the work stopped. So then I said that, so is there any temple here? So they said that no temple hai. So nariyal milta hai. So lay आओ, so the 100, so the nariyals lay आओ. So पूजा करेंगे, पूजा करके, so work will start. That is the first coconut, so the breaking by me, so that everybody is actually so happy. See, you need a trigger. You need a triggering point, so in a situation where, so the complex situations are there, so you need a trigger. You need a funny fellow. And then that is what actually, so I acted as a funny, and I said that, we'll do the puja, and then, so the work will start. Uninterrupted. No more, so the, yes, people, so the attempted. You see that now the slopes, so the reinforcement, etc. It is not just ordinary slopes. A lot of reinforcement is done. You see that, so the how things are actually going on, and the wind forces are actually so huge there. Say the wind tunnel tests were actually carried out by the force technology, Norway, and the terrain model, so the arch models was actually carried out in these tests, and the wind speed of 266 kilometers per hour has been tested. Nothing happens. Bridge is stable. Bridge is going to be stable. And then, so the blast loads. So professor also, so they earlier mentioned, considering the importance of the bridge, say several loads have been actually considered. DRDO, 40 kg TNT equivalent contact blast, you put it to the track, or 100 kg TNT equivalent, so the 20 meters away, means somebody bomb फेंक के भाग जाएगा. So फिर क्या होगा? कुछ नहीं होगा. Nothing is actually going to happen, so the small damage, so the may be there, so that can be. The bridge shall not collapse. Bridge remain repairable. Removal of one card element, so the or the diagonal arch, the train operations, so the on one track will continue with the 30 kilometers, so the per hour. Bridge remain repairable. It is a steel bridge. It is a steel bridge. It is not actually going to, so the so the design basis note, so the differential settlement, somebody asked, so the differential settlement, so the 20 mm between the two consecutive foundations considered, expected settlement shall be less than, so the 20 mm, and the temperature variations, so the large temperature variations are actually taken into the system, and the design basis of, so the bridge, say these are the standards which have been actually followed it. And material for the design, so the M40 concrete, and then also the steel is also very high grade, so the and fully killed and normalized. And then, so the design consultants, so that is the viaduct and foundations, so the WSP, so the Finland, arch is actually that, and then, so roof consultants are there, JV, and then URS, so the UK, that is what actually the Flint and Neil partnerships, and the URS Scott Wilson. So they are there, and now see that, see the how the deck is coming, and then each piece of, so they, as I said that, so they will be carried by the crane. See that, how arch is actually coming. It's not, so the one single piece, you put it either side and fix it. No, it is a bit by bit, so the you need to get the support from the piers which have been actually casted, and then you complete it. And then the deck is actually going to come. Disparate third attempt is also made. Even at this stage, disparate third attempt to stop this project, so that has been made. Third attempt was actually made. So when JNK was actually burning it, JNK was, so the having problem, and then at that time, so they choose to, so the put a spanner into it. The burning, but the gone into the din, means nobody listened, unheard. So almost all locations of the bridge are accessible, so the piers and other things, for the further maintenance, etc. I'm talking. You see that, so these are gigantic, so the activity. This is only the P20, so if you see the P40, so it is a mind-boggling. It's a beauty, like, so the seeing these foundations, etc., so the this is the steel deck, and, so the fabricate, and then, so the push it. And it is not straight pushing it, so the 1.315, so the kilometers either side, so the you need to push it. And some parts are actually the curved pushing it, so, and some are, so the deck is actually the straight line, so they as well. Yes, this piece is actually being carried, so by the cranes, and then place it, say where it is required. And then this is how actually the deck, and the arch is actually the coming up. I explained also, like, so these are not actually at the same, so the levels. So because you got a good rock condition, so thereby the arch is, so the slightly one side lower than the other side, say the. You cannot really capture it, so the standing nearby, you cannot capture the scene, so it looks like this, so the, because so they are so gigantic. That is what actually Sitaram explained, like, so the whole hill is actually the stitched, almost like 60 meters, so the rock anchors, cable anchors, so they have been actually put it, so that those pads are the concrete pads, so the 1 meter by 1 meter. 1 meter by 1 meter is looking like a dot there. This is on the, from the top of the bridge, so you are seeing it. The deck is actually the getting, so the connected. Awesome, isn't it? The bridge is, so the finally, so the meeting it, and, so the getting closed. The bridge is done. This is on the deck. So my association with this project is not actually the over. I am actually doing a lot of, so the tunnels and other on the way, so there are so many things are there. Yeah, this is, I think, so the thankful to, so the Sandeep ji, so because he was actually the CEO, and we were actually inspecting the track 1 year before, so the inauguration of that, and also, like, so the final track commissioner of railways, so even along with that also, so we were associated, and, so that. So Northern Railway, all these, so the gentlemen, so who are actually listed here, and, so the Sandeep is actually here, and then the other people are also there, and then, so the KRC, so the thanks to them, and then URS, so the thanks to them. IIT Delhi, I am alone, but then, so I have, so the a bunch of, so the students, they have done a wonderful, so the modeling. Then, so the from IIC Bangalore, Sitaram and the group, and then Itasca, so the lowered and lowering, and, so the other gentlemen, and then, so you have the this the FCONs, so the CVPU, that is what actually they designated it. Girdhar is an excellent Jammu person, so who knows it. And then we are forgetting it. GSA has done, so the original geological surveys, and then CSMR has actually done those testing in the drift, so I have explained. It's a fantastic, so the testing they have done. NIRM, Rock Mechanics Institute, National Institute of Rock Mechanics, they have also conducted the studies, initial stages. And IIT Roorkee, as I said that, so they have done the, so the initial seismic studies. So thanks to all. So this is my group, so the Ganesh, who is actually now in Johannesburg, and he is the one who is actually the spearhead, the complete, so the modeling. Nilima and Pranita, Amit, Alex, Tejas, Ankesh, Rebecca, Pratima, Akshay, Avajit, Alekhya, Likit, Sandeep, These are all actually the students who actually worked on different aspects of, say this particular project, say that. And the geotechnical lab or IIT Delhi, say rock mechanics lab with fantastic, say the facilities we have developed it. There also, say yeah, we are on the deck. So this is Ganesh, and of course, so batch after batch, so you see that, so the students thrill, so if they are there on the deck or, say in the tunnel, the amount of, so the these are the real future, so the engineer going to be. And, so if you allow them to talk, they will talk volumes, so they about this. This is what actually the educational institutions, so they give the training to the students. It is a lifelong experience, so that to get into such mega projects and, so the listen to the this is all these people are actually the sitting, so the on the 56 by 36, so the 38 foundation ka niche, abutment foundation ka major Chenab bridge foundation ka niche baitha hai log, so the either side, so the you have that. This is, so the KRCL campus, so the very good food, so they used to supply. This is another batch of, so the students, so the who have got. We have not actually stopped this, so we have been giving, so the lot of training, so the to the KRCL and, so Northern Railway. I think we can see the Gupta ji, where are you? Yeah, here, so the Gupta ji is there. He is the CEO, so the Sachin Saab, so the this I conducted, so the in IIT Jammu, because at that time, so the as a Dean Infra from IIT Delhi, I was operating, say that IIT as well. So thereby in IIT, this is the first course we have conducted, say for the railways, analysis and design of tunnels, so the course in the KRCL for the Northern Railway engineers. So this, so that definitely I wanted to read it, so please have a patience, so for one more minute. And, say that has been actually inaugurated by Modi ji, and, say it is a proud feeling and a great tribute to all the engineers and the workforce day and night, say the toil for the last, say the 20 years. And I salute, say for their contributions and dedication in this regard, say I did play some role. So when it is needed most, and blessed the opportunity I got it. Those two things, the chairman, so the meetings, etc. If that not happened, yes, still maybe bridge might have actually come. I am not actually telling that, but then, so that is a very important coincidence. Then what we did it, so I feel that conducted extensive geological, geotechnical, so the field and lab testing. And alignment finalization is actually done in based on the properties, and freezing the final design parameters for the stability analysis. Conducted extensive discontinuum based UDEC and 3DEC analysis. The site specific seismic studies have been actually conducted. Defended the project when questioned its stability by the expert committee, the railway board, and other stakeholders, and provided solutions for several bridges, tunnels, slopes along the route of Katra to Baramulla. These are some of the examples, the tunnels I have given it. Conducted several training programs to the KRCL, Northern Railway, IRCON engineers. The project experienced several ups and downs along its, say the long journey, and finally it is commissioned. I am the happiest person. I might have delivered more than 100 lectures in India and abroad, making of the world highest Chenab bridge, technical and social challenges, thanks to my students and, so the engineers who have become the part of this wonderful, so the journey. The title is actually the same. I have spoken, so with the same title, but every time, so the material is actually the keep adding it, because as the progress of the happening it, the first thing, so the first the talk which I have given it in the outside the country, at that time only the analysis part. Say part of the analysis is actually completed, in that was, so the 2011. So that was the first results came, and I presented that, so the and then after that, so we keep actually adding it, see the all the things whatever is actually happened. It's a nice journey for me, and, so the And so the overall design comes. This people should actually understand. If somebody says that so the we have made the bridge, no, you cannot actually make the bridge like that. You know it, so that now how many the engineers so the toiled so the day and night, how many stakeholders are actually the toiled it. There are so many consultants are actually there, the experts are actually there. Unfortunately, I requested so the railways also to give say the a press conference. I know just before or after the, and then tell that so the what went so the in making this bridge. So thereby the country and the other countries so will be knowing it so that instead of actually the gossiping it and so the making wistful so the aspirations. So and then arch design is actually done by these people. See that the overall design and construction so the FCONS has actually done. FCONS is the contractor and he has his engineering force. And then with the association, and then arch design, viaduct and foundation designed by these people, Finland, and foundation protection is so the, that is what actually the IS Bangalore. And then say the slope stability analysis, IIT Delhi conducted slope stability analysis. This is the main job, but there are so many other things happened. And the blast proofing is DRDO. Steel supplier is actually the Steel Authority of India, and and then the bearings have actually done by the Switzerland. So how can you say that so the, and then finally the credit should actually go to the Northern Railway to dream big, to connect say the Kashmir to the India. In 4 hours so that you can travel it nicely in air condition, seeing the complete so the Kashmir Valley. It is a lifetime so the experience see if you travel it. And KRC and ESCOM and many more so that. Thank you very much for that.
As a geologist, my small question is, how could you make the geological map?
Geological map.
Right.
Sir, geological map is so the done by not me. I have only so the locations where the foundations are coming, because we came so much later. The GSA has actually conducted. GSA are the authority. So they do the geological mapping, etc., detailed mapping for the whole area, not that so the only those locations, etc. And then NIRM is also so they done some studies, and then CSMRS is also conducted. These are the government organizations. Their credit never so they're told by anybody, isn't it? They are the government organizations. So who is actually talking about the Northern Railway, etc.? Their engineers, they are champions. I am telling you, so I am so fortunate that to have the interaction with these people. They are meticulous. I am telling you, day and night they dream, and then fortunately or unfortunately they only stay so the 2 years, 3 years in the project. They will be shunted to some other project. I asked this question also, so why are you changing? That person is actually knows so well and conversant with the whole project. Why don't you say allow them to? No sir, और बिस्तर और वो बांध के रखता है हम लोग. सो जब so बोलता है लेकिन तुरंत शाम को निकलना है. I was just aghast. A person who is actually got so much of experience in that project, and now you are shunting, and then a new person is actually coming, he will take so the ages to understand it. It is not beginning. It is so the, all of a sudden so the some in between so contracts, in between so the activity. If somebody is actually has to pick it up, that is not so the possible. But anyway, that is the system so that they have. Maybe it is working well for them. Sir, you have any other questions? You got exhausted, I think. More than please. 266 kilometers per hour. Model. See, all the tests, all bridges, all mega structures, so the equivalent material modeling, so the karta hai. Same means, so the small scale models, but so the everything is equivalent. Maybe you 1:100. 1:100 means, so the 100 times, so you are actually increasing it. But the character of, so the material choosing it, model, etc., everything you have to, say proportionately you have to take into account. Then only the model. Otherwise, how do you construct it? Say any large structure, has to be modeled it. Yeah. Like, so we are doing the tunnel models, so in that tunnel, impacting it. In our lab, rock mechanics lab, you see that, so the models made and lined, unlined tunnel. Small tunnel we make it, but that is, so is equal to, so the 10 meters diameter tunnel outside. Material is also same. Everything is similar. Yeah, no more questions. So thank you.
It was an excellent presentation given with lot of insights and inside knowledge that we could have never got, and it was wonderful from Professor Rao. I will now ask Sanjay Gupta ji to please give a memento to our honorary speaker here.
He is thinking that, you are calling him for giving the speech,
मैं भी वही सोचा, मैंने कहा यार मेरे को कैसे बुलाने.
Sir.
Hey, it's a honor, yaar, so to getting the praise for you.
इतना बुढ़ा नहीं हुआ. ये देना है लेना.
Thank you, sir. So I also did a small project with Northwestern Railway, and I had the similar, experience. In 1 year time during, I dealt with 4 devices. So, to explain them every situation, every 3 months, it was a difficult task. Anyhow, so now we will run to our lunch on first floor, and we will reconvene at 1:30 p.m. For the next lecture. So. All are, please join us for the lunch, and you can have further discussion with Professor Rao and any questions there itself, and Mr. Gupta also. And thank you. Hello, hello. Hello, hello. Hello. So, good afternoon, guys. I hope everybody had some good lunch, not too much though. So, you know, so without further delay, shall we start? Yep, I think we can start now. After a great lecture by Professor Rao, now we have the real person who actually, was instrumental in guiding the project and eventually, having it executed, and it is the way it is now. So, it is our with immense pleasure, we like to welcome Mr. Sandeep Gupta, former Chief Administrative Officer of the Udhampur-Srinagar-Baramulla Rail Link project, USBRL. You must have, everybody has heard about it. Northern Railway, which is a flagship infrastructure initiative of national importance. He is a seasoned civil engineer and project leader, and is a postgraduate in structural engineering from NIT Allahabad and a graduate of NIT Kurukshetra with over 30 years of experience in the planning, design and execution of major transportation infrastructure in the challenging terrain that is the Himalayas. Joining the Indian Railway Service of Engineers in 1991, Mr. Gupta has held critical roles across the USBRL project, overseeing the execution of several strategic sections, including Jammu, Udhampur, Katra, and Banihal. His international exposure spans technical visits to Italy, France, Denmark, and Switzerland, and an advanced management training at INSEAD, Singapore, and ICLIF, Malaysia. We are honored to learn from his, remarkable experience over the years and expertise. Let's welcome Mr. Gupta for the presentation. Thank you.
Well, good afternoon, everybody. I hope you had a good lunch, but I'll ensure that you don't feel sleepy. My presentation will be a sort of a practical presentation. It will be interlaced with certain short films, which we will find very interesting. I'll be touching on the practical aspects of the project. As I have been introduced, I can just say like that. I spent about 35 years in railways since joining. Out of these 35 years, I spent about 27 years on J&K railway project only. And out of these 27 years, I was at site for about 25 years in various capacities. I'll just show you the slide. So this is a very good photograph of this Chenab bridge. You must have heard about Meaux viaduct in France. We say bridge over the clouds. Our Chenab bridge is like that. The bridge over the clouds. Anyway. इसका पॉइंटर नहीं चल रहा क्या? Now this is Jammu. The railhead at Jammu became operational sometime in 71-72. From 72 onwards, there was no railway network in J&K beyond Jammu. The first of all, Jammu to Udhampur was linked in year 2004. And I was associated with Jammu Udhampur as a probationer. Then on my second posting, I was one of the jokers, as the people say. I went to Jammu on my own request on this project. So I had a ambition of working in the Himalayas. So on my own choice, I went to Jammu. At that time, it was about 93, I remember. We did survey from Jammu to Udhampur. And after about 2 years, I again left that project. Came back in 97-98, did survey in the valley. That is in this between Banihal to Baramulla. For 1 year, I was the survey in charge. I did the survey when militancy was at its peak. Then on promotion, I became deputy chief engineer. I came to Jammu and played a pivotal role in completing Jammu to Udhampur in 2004. Then from 2004 to 2007, I was in headquarters, again involved with the same project. Then on becoming chief engineer in 2012, I was handpicked and posted again to Jammu for this USBRL project. From 2012 March till my retirement this year in February, I continued on the project and commissioned it, completed it. So as you see, from Udhampur to Baramulla, exactly there are 25 stations, and the whole project was not taken up simultaneously. It was broken up into 4 parts. First of all, I'll just tell you what was the vision of the project. The project vision was one of connectivity and change and creation of a technological marvel. It was a commitment to people to change their lives and minds forever. आप ये एक एक्सपेक्ट करिए कि वैली में या जम्मू के बियॉन्ड आई हैव सीन पीपल लिविंग देयर जिन्होंने कभी ट्रेन नहीं देखी थी. इट वॉज ए ड्रीम फॉर देम कि भाई ट्रेन भी देखने को मिलेगा. एंड इन द इंटीरियर तो था कि वहाँ सड़क भी नहीं थी. फिर दिस प्रोजेक्ट इज गोइंग टू गेम चेंजर इन द ओवरऑल डेवलपमेंट JNK. अब जैसे ट्रेन चलनी शुरू हो गई है, वहाँ से जो प्रोड्यूस है, जो उनका फ्रूट्स है, ड्राई फ्रूट्स हैं, दे विल कम टू द मेन लाइन बाय ट्रेन. अभी क्या होता है, वो ट्रक से आता है, रास्ता बंद हो जाता है, 4-4, 5-5 दिन से लेके 20 दिन तक ट्रक बंद रहते हैं, प्रोड्यूस ख़राब हो जाता है, और सारा का सारा फूड ट्रेन और जो यूटिलिटीज़ हैं बाय रोड जाती है, अब बाय ट्रेन जाएगी. तो अब कितना कॉस्ट इफेक्टिव होगा आप समझ सकते हैं इसके बारे में. फिर इट इज़ अ मिशन विच वॉज ड्रीम्ड ऑफ मेनी टाइम्स बट इट इज़ अ रियलिटी नाउ. ये राजा हरि सिंह के ज़माने से सोचा जाता है कि कभी ट्रेन से हम कश्मीर वैली को लिंक करेंगे, बट वी आर नेवर सक्सेसफुल. वी केप्ट ऑन ड्रीमिंग. लोगों ने कहा था कभी प्रोजेक्ट पूरा नहीं होगा, बट इंडियन इंजीनियर मेड इट पॉसिबल. और रियलिटी है, नाउ ट्रेन्स आर रनिंग बिटवीन श्रीनगर एंड कटरा. एंड अभी क्योंकि जम्मू में यार्ड रिमॉडलिंग चल रही है, तो शॉर्टली इट विल बी एक्सटेंडेड टू जम्मू एंड फाइनली टू दिल्ली. Commissioning of your project is a key chapter in our Honorable Prime Minister's vision of a new India, that is Viksit Bharat. Now, जो वैली को नेशनल मेन स्ट्रीम से इंटीग्रेट करने का एक काम इन्होंने किया है. अभी कोई रेल कनेक्टिविटी कश्मीर में नहीं थी, अब हो चुकी है. जो एग्जिस्टिंग हाईवे है, दो वी आर डूइंग डबलिंग ऑफ द हाईवे, बट द हाईवे ऑलवेज रिमेन्स चोक्ड. देयर आर स्टेबिलिटी इशूज इन एवरी monsoons. The highway gets struck or blocked for years, for days to come. Then the journey is very uncomfortable. People think twice by going by road. Air fares are very costly. Then strategic considerations are very important. Economy and tourism तो आप दिख रहे हैं improve होगा. Now this is a Google map. इसमें आप देखेंगे कि पूरे प्रोजेक्ट को if you divide, हमने अलग अलग 5 पार्ट्स में डिवाइड किया है. जो easiest part था, that is the valley portion between Kazigund to Baramulla, spanning 118 kilometers. I was the man who did the entire survey from Kazigund to Baramulla in the year 97-98, and in 99 the project was given to IRCON on nomination basis. Then the construction was carried out by IRCON under the overall leadership of Northern Railway. Northern Railway was the main client. This section was commissioned in year 2009. Then Udhampur and Katra, this portion of 25 kilometers was also taken up simultaneously with the valley portion. This was done entirely by Northern Railway. Northern Railway did it, and the section was commissioned in July 2014. Prime Minister Modi this was the first project which PM Modi sir inaugurated after becoming PM. Then a small portion is there, Banial to Kazigund. It houses the longest transportation tunnel of that time, that is 11.15 kilometers, the Pir Panjal tunnel. This section was thrown open in June 2013. Now the balance portion between Katra to Banial, this is 111 km long. This is the toughest portion. Now these are the salient features of the project. The entire length is 272 kilometers. I have just highlighted Katra Banial section because I will be concentrating only on this part. These sections were comparatively easier. If you see, 87% of this 100 km is in tunnels. That is 97 km is tunneling, 7 km is bridges, only 7 km is in open, where we have located our 7 stations. Therefore, you can just imagine the enormity of the challenges which we had to face. The longest tunnel was 12.77 km long. Further, for safety and rescue, we had constructed 67 kilometer escape tunnels. That is 8 tunnels. In every tunnel which is more than 3 kilometers in length, we have constructed a parallel escape tunnel for safety and rescue of passengers. So the tunneling work was enormous. The percentage tunneling आप देख सकते हैं इसमें उधमपुर कटरा was 44%, कटरा बनियाल was 87%, Kazipur Banial is 62%, having only one tunnel, and Valley was a simple thing. It's like simple, there's nothing important. If you want, I can show you a small video of the so that you won't get bored.
Limited surface accessibility to the rest of the country in the year 2002. Udhampur-Srinagar-Baramulla Rail Link project was announced as a national project. Northern Railway, under the guidance of Railway Board, is responsible for coordination.
इसको स्टार्ट से शुरू तक कर दीजिए, जैसे स्क्रीन शेयरिंग नहीं हो रही ना इसमें. इस पे हाईलाइट करके.
For a long time, the government of India had been planning of providing a reliable transport system in Jammu and Kashmir, which has limited surface accessibility to the rest of the country. In the year 2002, Udhampur-Srinagar-Baramulla Rail Link project was announced as a national project. Northern Railway, under the guidance of Railway Board, is responsible for coordination and overall progress of this project. The 25-kilometer Udhampur-Katra section was constructed by Northern Railway and thrown open for public on the 4th of July 2014. Work on the most difficult 111-kilometer Katra-Banihal section was being carried out at a fast pace. This segment will have the highest bridge in the world over River Chenab. It will be 359 meters high from the bed level, having an arc span of 467 meters and the total length of around 1.3 kilometers. In this project, new Austrian tunnel method is being adopted for constructing tunnels. The daring task of constructing tunnels and mega bridges through this difficult terrain has been a big challenge for Indian Railways. For logistic support to the men at work and to reach the construction sites, 200-kilometer approach roads connecting inaccessible hilly habitations of the area have been constructed. The Katra-Banihal rail line, once completed, will link Kashmir Valley with the rest of the country. Some of the main objectives of this project of national importance are reducing the travel time to various destinations in the state considerably, providing a all-weather transportation system in this difficult terrain to generate employment for local people as well as for others, and last but not the least, boosting the socio-economic development of the state.
ये हर बार जब भी हवा जाना पड़ेगा तो हवा जाना देखने में. So now I only consider on Katra Banihal section, which is the most difficult one. The special feature of this section is construction of more than 250 km network of access roads. None of the sites on Katra Banihal section were approachable. So we were required to first acquire the land, do the survey and construct these roads, which was a challenge and it was a project in itself. So we can say once, even before the project was commissioned, the development has already taken place in the state. Then the longest transport tunnel, this is 12.7 km long, T50, it is operational. At the moment, it is the longest transport tunnel. Before Rishikesh-Kanpiyar project gets commissioned, it will be having about 14 km long tunnel. As I already said, 97 km out of 111, that is 81% inside tunnels. We have made 67 km escape tunnels. First time of Indian Railways, we have constructed escape tunnels as per international standards for safety and rescue of passengers. Then, due to space constraint or paucity of space, all the station yards are located either on tunnels or bridges or both. I'll be showing you the photographs. Then all the entire Katra Banial section is not having a ballastless track. It is having a ballastless track. That is, it is a concrete track which will be maintenance free. It will be smooth. The riding will be very smooth. Even the yards are having concreted turnouts, canted turnouts. तो जैसे आप ट्रेन से आप जर्नी करते हैं ना, वो जो क्रॉस स्टेशन यार्ड, आपको नींद में भी झटका आ जाता है कि भाई जैसे टर्नआउट को क्रॉस करते हैं देयर इज ए जर्क, बट यहाँ पर आपको कोई जर्क नहीं लगे क्योंकि ये टर्नआउट्स कंक्रीट पे हैं और वो कैंटेड है. देयर विल बी नो कैंटिंग एंड कैंटेड आउट. तो आप 100 की स्पीड से जा रहे हैं, विल गो स्मूथली. तो दिस इज फॉर द फर्स्ट टाइम इट हैज़ बीन डन. जस्ट लाइक मेट्रो से जो किया गया, ये फर्स्ट टाइम ब्रॉड गेज पे हमने रेप्लिकेट किया है, जो आगे अब नॉर्दर्न इंडियन रेलवे इसको कैरी फॉरवर्ड करेगा. तो फर्स्ट केबल स्ट्रेट ब्रिज ऑफ इंडिया इस सेक्शन में है. वर्ल्ड का हाईएस्ट रेलवे आर्च इस सेक्शन में चेनाब ब्रिज. सुबह से उसी की बात हो रही है, मैं इसको रिपीट नहीं करूँगा. फर्स्ट टाइम इंडियन रेलवेज में हमने रीइंफोर्स अर्थवर्क का इस्तेमाल किया है, जो जनरली हम रोड्स में करते हैं, हाईवेज़ में करते हैं, बट रेलवे लोडिंग के लिए नहीं किया गया. लेकिन इस प्रोजेक्ट में वी हैव मेड अप टू 60 मीटर हाई एम्बैंकमेंट्स using reinforced technology. So it is very successful. It is like making a hill out of nowhere. Then provision of rigid overhead conductor system, ROCS कहते हैं. आप लोगों ने देखा होगा कि जनरली जो ओवरचीज इक्विपमेंट होता है वो फ्लेक्सिबल होता है, बट इन केस ऑफ टनल्स इन मेट्रोज एक रॉड लगा देते हैं उस पर, एल्यूमिनियम रॉड, वो उसको रिजिड सिस्टम कहते हैं. तो फर्स्ट टाइम हमने इंडियन रेलवेज में इस सेक्शन में पूरा ROCS सिस्टम लगाया है, जो कि दो इट इज़ 3 times कॉस्टली, बट ये लाइफ साइकिल टाइम कॉस्ट अगर कैलकुलेट करेंगे इट गेट्स चीपर. दैट इज सिंस कटरा बनियाल सेक्शन इज इन ए वेरी रिमोट सेक्शन, सो ट्रैक इज मेंटेनेंस फ्री, OHE इक्विपमेंट इज मेंटेनेंस फ्री. द एंडीवर इज दैट कि वी शुड मेक अ स्ट्रक्चर सिस्टम विच रिक्वायर्स मिनिमम ऑफ मेंटेनेंस. This is a breakup how we did the work, what was the project management. Indian Railways, that is Northern Railway, is the overall client. We did of Katra Banial section, first 5 kilometers was done entirely by Northern Railway. Then 54 kilometers were distributed between Ircon and Konkan Railway. These two are Indian Railways PSUs, and the work was given to them by Railway Board on nomination basis. So whatever work they did, they used to get 10% profit. So entire contracting was being done by PSUs, not by Northern Railway. We were the clients. We used to approve the GADs. We used to do the project monitoring. We used to do the land acquisition, local security issues, local licensing. But actual contracting was being done by these PSUs. These are one of the, I would say, recent achievement means I became Chief Administrative Officer in September 2023. Till that time, Katra Banial section, none of the section was opened. So it was my endeavor to see that entire section gets commissioned. So we started from Banial end towards Katra. So Banial to Sangaldan, that is, there were 3 block sections of 48 kilometers long. These were completed and commissioned by Honorable PM Sir on 20th of Feb. That is, the new line was commissioned, and electrification right from Baramulla to Sangaldan. This was also commissioned. I'll just show you a small video. Again, आप लोग help करेंगे इसमें. ये तो ये इस पे चल जाना चाहिए. Sorry. ये मैंने ही बनाया था जब हम स्पीड ट्रायल कर रहे थे. CRS होता है तो फ्रॉम संगलदान टू, अब देखिए सारा का सारा ट्रैक कंक्रीट का, यू नो ब्रिजेस. These are all ROCS. These are cable trays.
देखिए पूरा स्टेशन, सिर्फ स्टेशन है जो हिल पे है, बाकी पूरा यार्ड ब्रिजेस भी है टनल्स के अंदर है. This is the longest transportation tunnel. Now, this is the first electric train from Baramulla to Sangaldan. That day, in 20th Feb, it was snowing heavily in the valley. Then, as the second part, from Sangaldan to Riasi, that is 46 kilometer combining of 4 block sections. We did CRS on 26-27 June. Speed trial was on 20th June and we got the authorization on 1st of July. This is the trial run on the Chenab Bridge. Then the last section, that is Katra to Riasi, is hardly 17 kilometers. This section could not be commissioned earlier because there was a tunnel which I will be coming later on, a tunnel number T1 initially, now revised is T33. It was crossing main boundary thrust, which Professor also described. We got struck up with that tunnel for about 10 years. We changed the system from NATM to ITM. We succeeded it. And finally, in January 25, we were able to commission this section also, this balance section. The speed trial was done on 8 January. The only difference was that initially, because we were coming from Kashmir end, we were only having MEMUs, that is multiple electrical units, which is a light train. Now the Commissioner Railway Safety said, since the entire section has been completed, connected, he will be doing speed trial using a proper train. So we got 2 electric locos, a proper 8 LHB coach train, and he wanted to do a speed trial right from Katra to Banial and Banial to Katra, which we got it done. I'll just show you the glimpses of that. This is the speed trial when we did over Anji Bridge. This is a special train, CRS Commissioner Railway Safety Special Train. The proper electric loco we have used it, which is WEB 7. And this is the inspection car. Then before commissioning, we did trials for Vande Bharat train. This is one of the trial for small videos. Sorry. It is a small Vande Bharat. It is 8 coach train, not 16 coach. Slowly we'll increase it. Finally, the project got commissioned. It got dedicated to nation on 6 June 25. This was a proud moment. I am also there in that picture. I am happy that post-retirement they invited me. I was the only retired officer to be there. So I am standing here. This one. देखिए आपको आना पड़ेगा जरा इसको कॉम्प्लिकेट करने के लिए ना फोटोग्राफ है ये वाली इसके ऊपर लिंक है
वैष्णो देवी के आशीर्वाद से आज वादी कश्मीर भारत के रेल नेटवर्क से जुड़ गई। उधमपुर, श्रीनगर, बारामूला ये रेल लाइन प्रोजेक्ट ये सिर्फ नाम नहीं है, ये जम्मू कश्मीर के नए सामर्थ्य की पहचान है। भारत के नए सामर्थ्य का जयघोष है। चेनाब ब्रिज दुनिया का सबसे ऊंचा रेलवे आर्च ब्रिज है। हमारा अंजी ब्रिज भी इंजीनियरिंग का बेहतरीन नमूना ये प्रोजेक्ट पूरा करना मुश्किल था, चुनौतीपूर्ण था, लेकिन हमारी सरकार ने चुनौती को ही चुनौती देने का रास्ता चुना है। ये दिखाता है विकसित भारत का सपना जितना बड़ा है उतना ही बुलंद हमारा हौसला है, हमारा सामर्थ्य है।
अब कटरा में टनलिंग में एज आई ऑलरेडी टोल्ड यू इट इन्वॉल्व्स a large amount of tunneling. Basically for main line tunneling 97.42 kilometers there, 25 tunnels. For 8 tunnels we have constructed 66 kilometers of escape tunnel, parallel escape tunnels for safety and rescue. 6.7 kilometers of 13 number edits have been made for ease of construction for creating more faces. Then there are cross passages totaling 4.27 kilometers. That every 375 kilometers we have made some cross passages. There are total 8 tunnels ranging of 5 to 12.7 km long on Katra-Banial section. This is a typical layout of the tunneling system. This is the main tunnel. This is the escape tunnel. And every 375 meters we have got cross passages so that in case of any eventuality, there is a cross passage through which passenger can escape and can be evacuated from the escape tunnel. This is the cross section. This is cross section of escape tunnel. This is a lay-by. This is the plan. This is the main tunnel. When people actually these are pressurized cross passages. We have got fire doors. Then there ventilator fans are there so that smoke should not come. And these are lay-bys. If in case of emergency, so that we can overtake, 2 vehicles can overtake. This is the longest tunnel. These are basically tunnel features. Any tunnel which is more than 3 km, we have constructed parallel escape tunnel. CP is at every 375 meters. All the tunnels which are more than 2 km long, we have provided artificial ventilation system which aids in ventilation as well as for fire rescue system. Then access roads to all the portals for emergency exit and rescue. there is a side walkway, that is pathway, width ranging from 75 to 1.2 meter. There are safety niches at every 100 meters for rescue, for taking refuge. Then 2.7 lux level illumination is at walkway level. There are laybys at every CP location. Then fire hydrant system is there in all the tunnels. At every 185 meter, there is a fire hydrant. This is a typical photograph showing all the fixtures. These are the ventilation fans. These are cameras. At every 100 meters on both the walls in a staggered manner, CCTV cameras have been provided. PA system has been provided. Then there is a leaky cable for tunnel communication system, that is tunnel radio communication. Then there is these are all cable trays for my E&M systems. This is a water hydrant pipeline. And this is the track, basically the concrete track you can very well see. This is a tunnel control room. At every station, there are 7 stations. We have got 7 control rooms. We have got 2 panels. एक पैनल है जो आगे वाले सेक्शन को जो मास्टर होगा और वहीं पर एक उसका शेडो होगा. इन केस ऑफ फेलियर दूसरा सेशन काम करेगा. तो ऐसे 7 कंट्रोल है हमारे पास. ये जो लॉन्गेस्ट टनल 350 मैंने आपको बताया था, ये 12.7 लॉन्ग, ये एक क्रॉस सेक्शन है इसका. ये ट्विन ट्यूब है, बेसिकली मेन टनल है और एस्केप टनल है. अभी सिस्टम क्या है कि हमारा एस्केप टनल का साइज़ मेन टनल से आधा होता है. नाउ बेस्ड ऑन आवर रिकमेंडेशंस, now railway board has taken a considered call that henceforth whenever we construct an escape tunnel, it will be having a same dia of main tunnel so that it can be used for future capacity enhancement. It has a challenging geology. It was executed through Ramban and Ramsu formations. It is an engineering marvel, gradient 180 and speed 100 kmph. Now coming to the most difficult tunnel, I would say, in the world. We got stuck up. We did more than about 180 kilometer tunneling, but this is a tunnel just at the foothills of Mata Vaishno Devi, जिसको हम त्रिकुटा हिल्स कहते हैं. Just when we come out of Katra, this tunnel is located. This tunnel is 3.2 kilometer long. However, the tunnel crosses main boundary thrust. We were doing the tunneling with NATM, that is New Austen tunneling method. The strata, as I have already told, geologically this area is lesser Himalayas. The tunnel alignment crosses main boundary thrust in 336 meter. The strata encounter tunneling through is highly fractured, sheared, and along with water. It behaves like a viscoelastic plastic medium. It is practically water. It's like being you are tunneling through water. So NATM is just as possible. So इसका कोई practical stand-up time भी नहीं है. Finally, what we have to do, we have to change the type of system of tunneling which we wanted to do. अब आप इसे देखेंगे, ये क्रॉस सेक्शन है, ये शिवालिक है, ये रेड में आप देख रहे हैं, ये मेन बाउंड्री थ्रस्ट है, और ये सर्बन डोलोमाइट है. तो इनिशियली व्हेन यू सी द अलाइनमेंट वाज फिक्स्ड लाइक दिस, इट वाज गोइंग ऑलमोस्ट पैरेलल टू द मेन बाउंड्री थ्रस्ट, और इस तरह निकल रहा था. अगर हम इस अलाइनमेंट को स्टिक करते तो शायद ये प्रोजेक्ट कभी कंप्लीट नहीं होता और ये अबंडन नहीं आता. 2010-11 में जब रविंद्रा कमेटी बनी थी, देन वी डिड ए मिड कोर्स करेक्शन. वी हैड टू क्रॉस एमबीटी इन एनी केस. So the shortest length is you go at 90 degree. So we turned the alignment almost at 90 degree so that the distance can be minimized, and finally it became about 400 meters. This is another section. This is the MBT. This is portal 2 location of tunnel T33. Here we have got Mata Vaishno Devi shrine. This is tunnel number T2. This incident occurred in 2017. We were not aware कि what we are entering into it, and suddenly one day, fortunately it was Eid holiday, nobody was at the face, and this is what has happened. We were just near to MBT, we punctured MBT and whole after this, we cleared the muck. ये देखिए, this is the condition of muck. So this Pokhlian machine was rolled out by 250 meters. इतना impact था, और करीब 17,000 किलोमीटर of debris थी जिसको clear किया गया. And what we did, we just built a bund at the face to stop any further ingress of water. And we started brainstorming what to do. NATM was not successful. Then we resorted to a system known as I system of tunneling, ITM. Though it is not a new technique, but in India it was used for the first time, and for the first time in such a large way. Now this is the tunnel portal P2, and here is a sinkhole. तो 315 मीटर ऊपर पहाड़ के ऊपर एक सिंक होल बन गया था, जिसका डायमीटर 80 मीटर था, डेप्थ 20 मीटर थी, बिकॉज ऑल द मटेरियल फ्लोन आउट, तो इट वॉज कनेक्टेड. तो इसको आप इससे इनॉर्मिटी समझ लीजिए कितनी डिफिकल्ट था कि पानी में इसको जब when we were thinking there were only two solutions. Since we were tunneling through a medium which was viscoelastic plastic like water-like thing, so either we could have gone for ground freezing technique. Ground freezing technique is available in European countries. By nitrogen gas से हम plant को use करके we freeze the strata, we excavate, support and उसको freezing आगे बढ़ाते जाते हैं. However, in our country, it is very very difficult because the way we work, nitrogen gas is very abrasive. It could have been very very dangerous. Then we went for I-system tunneling, which involves extensive pre-ground support and consolidation of the strata. This is what we did. After completing it, this is a double ribs we provided, then a concrete bund, and when we did the excavation, we did in a drift. That 1/3 we left on this side so that we could take care of the cavity, the forces. Now this is I-system tunneling, the method for tackling MBT. This is a represents sketch basically. Extensive pre-support. We use umbrella pipe roof. 114 mm डाया के पाइप्स होते हैं जिसको हम वो स्लॉटेड होते हैं, उनको हम एक बूमर में से, जिसको ड्रिलिंग जंबो कहते हैं, उसको 7 डिग्री एंगल पे हम ड्रिल करते हैं और वो बिल्कुल सटे होते हैं, करीब 10 सेंटीमीटर गैप होता है उस पर. तो अम्ब्रेला बना दिया हमने हेडिंग में पार्ट में. उसके बाद उसके अंदर हम 2 कंपोनेंट PU ग्राउट करते हैं विद प्रेशर ऑफ 50 बार. वो होल से बाहर निकल के एक अम्ब्रेला शीट पेल बना देता है. तो आपको यू गेट ए स्पेस फॉर वर्किंग. तो उसको जो 9 मीटर के पाइप रूफ करते हैं उनको हर 3 मीटर पे हम ओवरलैप करते थे, जैसे इफेक्टिवली यूज टू गेट 6 फीट ऑफ वर्किंग स्पेस. उसके बाद उसको हम बिफोर एक्सकेवेशन मल्टी मेथड से करते थे. हम उसकी फेस बोल्टिंग करते थे. 6 मीटर के सेल्फ ड्रिलिंग एंकर्स लगाते थे जो स्लॉटेड होते थे, फाइबर ग्लास के होते थे जिसको हम काट सकते हैं. अगेन उससे PU ग्राउट करते थे. तो उससे पूरा का पूरा 6 मीटर को हम उसको कंसोलिडेट करते थे. आप समझ लें जैसे बर्फ़ का पानी जमाते हैं उसको जमा देते थे. उसके बाद हम उस पर सिक्वेंशियल एक्सक्यूशन करते थे, एक वे में नहीं. पहले लेफ्ट में करते थे, मल्टी यूज करते थे, रिजिड सपोर्ट सिस्टम लगाना, उसको मैं आगे फोटो दिखाता हूँ. फिर स्टील फाइबर इनको उसको हम एनकेस करते थे. दिस मेथड इज़ टाइम कंज्यूमिंग, इट हैज़ टू एग्जीक्यूट वेरी सेफली एंड प्रूडेंस, और ये बहुत कॉस्टली होता है. ITM इज़ 10 टाइम कॉस्टली देन NATM. अगर आप 10 लाख रुपए पर मीटर खर्च कर रहे हैं NATM में, इसमें 1 करोड़ रुपए पर मीटर खर्च होता है, 1 करोड़ पर मीटर. जस्ट इमेजिन वी स्पेंड 400 करोड़ रुपीज़ इन जस्ट टैकलिंग 400 मीटर ऑफ MBT. इसको क्योंकि बड़ा सेक्शन था, इसको आपने 60% हेडिंग में करा, 25% बेंचिंग एंड 50% इनवर्ट. तो क्रॉस सेक्शनल एरिया 50% इंक्रीज़ हुआ है क्योंकि पाइप प्रूफिंग करने के लिए हमको सेक्शन बड़ा चाहिए. ये आप देखिए पाइप प्रूफिंग कैसे कर रहे हैं हम, ये ड्रिलिंग जंबो से. दीज आर द पाइप्स, यू कैन सी द डिफरेंस. तो करीब एक हेडिंग में 80 to 90 पाइप्स आते थे. उसके बाद इनकी हम PU ग्राउट करा, ये फेस बोल्टिंग की ग्राउटिंग कर ली. ये सिक्वेंशियल डिगिंग चल रही है, पहले लेफ्ट पे करा, फिर राइट पे करके ये डेडमैन होता है. अब ड्यूरिंग द ड्रिफ्ट की तरफ से हम लोग NAT या ITM ही कर रहे थे, देन दिस इज व्हाट हैज हैपेंड. फिर आगे से लूज फ्लो आया. ये मैं आपको फोटो पिक्चर दिखा रहा हूँ कि इस तरह के स्टेटस को हम लोगों ने हैंडल किया है. इट्स जस्ट लाइक वाटर. ये जुलाई 22 में हुआ था. तो वी हैड दिस सेटबैक्स. हर सेटबैक हमको 3-4 महीने पीछे ले जाता था. हर 6 महीने में मेरे को कैपसैक में खड़ा कर दिया जाता था. ये बोलते थे कि बताओ ये पूरा प्रोजेक्ट बन गए, T1 कब बनेगी. When I used to show them this film, they used to get irritated. They thought कि I am making excuses, क्यों नहीं हो रहा है. But I was the man at the job. मैंने करा, but finally मैंने इसको ओवरकम किया. मैं अपने लिए कह रहा हूँ, फॉर 6 months सितंबर इनफैक्ट आप लगा 24 में जुलाई से मई से लेकर के नवंबर तक मैं रात को सोया नहीं हूँ। जब जितना हम लोगों को डांट पड़ी गई थी टनल के लिए काम क्यों नहीं हो रहा है, व्हाट वी डिड, दोनों टनल पोर्टल पे हमने 2 कंट्रोल रूम बनाए, सारा काम हो चुका, सब अफसरों को वहाँ लगा दिया, चाहे कोंकण रेलवे के, चाहे नॉर्दर्न रेलवे के, चाहे कॉन्ट्रैक्टर के, सब एक साथ काम कर रहे थे। सीसीटीवी कैमरास को टनल के फेस पे लगाया, जिसका कंट्रोल सबके मोबाइल फ़ोन पे था। हर हाफ एन आवर में एक व्हाट्सएप मैसेज आता था कि जो हमने प्लान किया है उससे काम हो रहा है कि नहीं हो रहा है। जैसे मैसेज आता, रात को मैं उठ के कैमरे रोटेट करता था, देखता था, गाली बकता था, जो करना है जो करते थे। एवरी डे 7 o'clock एक टेली कॉन्फ्रेंस करते थे हम लोग। उन्हें पता सीओ आएंगे तो बहुत डांट पड़ेगी, तो लोग डरते थे उसको लेकर के। मेरा कहने का मतलब कि हम लोग इंडियंस हैं, बिना डंडे के काम नहीं करते। दिस इज़ व्हाट आई हैड लर्न। ये अब पूरा का पूरा टनलिंग में हमको एक कहते हैं कि VDI, वाइब्रेशन इंड्यूस डैमेज को, हमें VID को बचाना था। इसलिए हम ना वहाँ ब्लास्टिंग कर सकते हैं, ना वहाँ कोई न्यूमेटिक ब्रेकर यूज़ कर सकते हैं। वी यूज़ दिस रोटरी ड्रम कटर, इसको कहते थे छीलते हैं, छील करके आगे बढ़े हैं। मतलब 1-1 मीटर बढ़ना भी एक चैलेंज था। जब हम लोगों ने हेडिंग थ्रू कर दी थी, हम लोग हेडिंग गए दिसंबर 23 में, हमने हेडिंग थ्रू कर दी थी। वी स्टार्टेड बेंचिंग वर्क एंड दिस इज़ व्हाट हैज हैपेंड। अब देखिए उसी में ड्रिफ्ट को हम छील रहे थे, जगह बना रहे थे पाइप प्रूफिंग के लिए। अब देखिए यहाँ पर क्या होता है। ये तो लंबा वीडियो, जब आपको देखें आपको इनॉर्मिटी पता चलेगी कितना डिफिकल्ट ये टनल था। पानी देखिए सर, पानी मग सबको आएगा। अब देखिए सर, अभी तो लाइव CCTV कैमरा से था, हम लोग जम्मू में थे, इससे पहले रश करते। ये 21 जनवरी 2024 की बात है। हम कहते हैं इसके पीछे भूत छुपा है। अभी आप देखिए जस्ट रॉक, ये MDT है, ये इट इज क्रश्ड डोलोमाइट विद वाटर। और आप देखिए ओनली सीरिंग रेट पर आपको पता होगा, हम लोग सिलक्यारा गए थे, हम लोग कहते हैं वहाँ क्या प्रॉब्लम हुआ था। दे आर डूइंग दिस इडियोटिक वर्क और फेस पे आदमी काम कर रहे थे, वो दे आर डूइंग रिप्रोफाइलिंग और पीपल वर्क के। हम लोग ने इसको तब टच किया जब हमारी टर्न थ्रू हो चुकी थी, सो दैट देयर वाज एस्केप फॉर पीपल। तो जो लोग यहाँ खड़े थे सेफली दे कुड हैव इवैक्यूएटेड। तो हमें कोई ऐसा कोई अनसेफ काम नहीं हुआ, ठीक है। वी वेंट बैक बाय 2-3 मंथ। एनीवे ये खत्म हो गया था, आगे चलते हैं। तो इसको करने के बाद में व्हाट हैपेंड, वी हैव टू स्पेंड 3 months ओनली इन कंसोलिडेटेड थिंग्स स्टार्टा। जितना लूज निकल गया था उसको फिर दोबारा PU ग्राउट करके पूरा ग्रेड बना करके काम करने में उनको 3 महीने लगा। तो दूसरे फेज से काम करते रहे, इस फेज से हमारा काम बंद रहा था। तो फाइनली इसलिए डिले चलते रहे। इन डिले को आपको ऊपर वालों को समझाना बड़ा मुश्किल होता है, दे वोंट अप्रिशिएट इट। वो सोचेगा आप बहाना करें, बट इट इज़ साइड पे खड़े होकर के ऑनेस्टली आप काम कर रहे हैं, एक चैलेंज को फेस कर रहे हैं, चैलेंज को किस तरह आपने ओवरकम किया, ये उससे बताता है। फिर ये जब हेडिंग पूरी कर ली थी तो बेंचिंग में भी सेम प्रॉब्लम थी। बेंचिंग में भी आपको पाइप प्रूफिंग करना था, पाइप प्रूफिंग को ग्राउटिंग करना था और फिर इसको काट करके फिर आगे बढ़ना था। ये देखिए कितने क्लियरली दिखा रखा है कि आपने बेंचिंग करी, उसके लिए रिब्स लगाई, रिब्स को एक्सटेंड किया, फिर शॉर्ट फीडिंग करी, फिर इन्वर्ट को भी आपको क्या करना है, आपको काम करना है तो आप पूरे फेस को एक साथ नहीं कर सकते। तो 50% को आप इन्वर्ट बनाएंगे, 50% को भी बाद में करेंगे। तो अपने 50% को टैकल कर रहे हैं यहाँ करके। ये देखिए एक्सटेंड किया, रिब्स को एक्सटेंड करा, फिर से आपने शॉर्ट फीडिंग करके कंक्रीटिंग कर दी, ये खत्म हो गया। फिर लाइनिंग एक्टिविटीज़, ये वो WPC जो मेम्ब्रेन है, वाटर प्रूफिंग मेम्ब्रेन है। ये जो गैंट्री है 12 मीटर का लाइनर एक साथ में कास्ट करता है। ये लाइनिंग चल रही है। ये फाइनली जब हमने टैकल कर लिया, ये ट्रैक भी आ गया इसमें। और अगेन ट्रैक। अब सर मैं एक चीज़ ऐड करना चाहता हूँ राव सर आपको बताने के लिए, द लेसन आई लर्न फ्रॉम सिलकेरा टनल। हम लोग जब आपको बताया जाता है जो उत्तराखंड में टनल कोलैप्स हुआ था, जब चादरे आदमी फंस गए थे, तो आई वॉज द फर्स्ट मैन फ्रॉम रेलवेज टू बी सेंट टू द साइट फ्रॉम मिनिस्ट्री ऑफ रेलवेज कि आप जा करके जो भी आपको करना करिए, आदमी निकालना है। दैन समाउ आई वॉज नॉट इन्वॉल्व इन द साइट, तो हमने आर्मी को दिया, मैं निकल गया था। फाइनली फॉर द इन्वेस्टिगेशन कमेटी आई वॉज अ मेंबर ऑफ द कमेटी, राव साहब भी कमेटी के मेंबर थे। वॉट वी हैड ऑब्जर्व देयर वॉज दैट दे वर ट्राइंग टू डू अ रिप्रोफाइलिंग when the people are working at the face. The lesson was that कि we should disturb the tunnel to the minimum, क्योंकि जब टनल आप बनाते हैं एक बार वो इक्विलिब्रियम ले लिया उसने उसको, तो अगर आप उसको डिस्टर्ब करेंगे तो थिंग्स कैन गो रॉन्ग, कोलैप्स हो सकते हैं। तो हमारा जो एरिया था जो मैं आपको दिखा, जब जहाँ पे एक हमने कंक्रीट का कंट्रोल बनाया था, लास्ट मैंने वीडियो दिखाया था कितना फ्लो हुआ था, जो हमारा कंसल्टेंट था एम्बर का, ही इंसिस्टेड ऑन फॉलोइंग दिस प्रोफाइल, जो इलेक्ट्रिकल प्रोफाइल को। आई गेव एन आइडिया दैट आई विल नॉट गो फॉर इलेक्ट्रिकल प्रोफाइल, आई विल गो फॉर अ डी शेप। डी शेप करने में, क्योंकि डी शेप और जगह भी था, हमें वो जहाँ से फ्लो हुआ था उसको मिनिमम डिस्टर्ब करना पड़ता। ऑन द ऑन साइड ही रिफ्यूज, बट लेटर ऑन ही एग्रीड, और हमने काम किया। और जब रेलवे बोर्ड को वो बोलता है दैट वॉज हिज आइडिया। एनीवे पर्पज से काम पूरा हुआ। फाइनली अक्टूबर 24 को, दिवाली से एक दिन पहले, हमने लाइनिंग पूरी कर दी थी और पैडल में हमने ट्रैक डालना शुरू कर दिया था। एंड बाय 10th ऑफ दिसंबर हमारा ट्रैक डल चुका था। और 25 दिसंबर को हम लोग तैयार थे सेफ्टी इंस्पेक्शन कराने के लिए, बट CRS वॉज नॉट अवेलेबल, तो फाइनली वो 25 में चला गया। वरना सर कंक्रीट लाइनिंग वो 30 सेंट ठीक होती है, RCC लाइनिंग होती है सर। अब एक स्लाइड में सिर्फ आपको इसे दिखा रहा हूँ कि प्रोफेसर राव ने आपको काफ़ी डिटेल में बताया था कि इन्होंने कैसे प्रोजेक्ट को सैबोटेज होने से बचाया था। हमारे ऑफिसर्स थे जिन्होंने कहा था कि PIL करी कि अलाइनमेंट ख़राब है, इसको प्रोजेक्ट को बंद कर दिया, अबेंडन कर दीजिए, सब चलता रहा। बिकॉज ऑफ डॉक्टर राव, जो उन्होंने एफर्ट किया था, हम लोगों ने एफर्ट किया था, द अलाइनमेंट वॉज नॉट शिफ्टेड, द प्रोजेक्ट वॉज नॉट कंटिन्यू लाइक दैट। जो रविंद्रा कमेटी ने अलाइनमेंट को फिक्स किया था, वी स्टक टू इट, और हमने उस रेलवे बोर्ड ने स्टैंड लिया था कि इट इज़ वर्केबल, फिजिबल एंड डूएबल, और उस स्टैंड को हमने विंडिकेट किया सर। मैं वो बताना चाहता हूँ। नाउ ट्रेन आर सक्सेस रनिंग, और आप देखिए 15-16 से पहले जब तक वो डिस्प्यूट चल रहा था, व्हाट वर्क हैज़ बीन डन, एंड आफ्टर 15-16 कितना काम हुआ। सबसे डिफिकल्ट सेक्शन था यही वाला, जिस पर क्लोज टू 36,000 करोड़ हमें खर्च करा। हार्डली 10% वी कैन डू इन बिफोर दैट, और 90% हमने लास्ट 8 ईयर्स में किया है। मैं ये नहीं कह रहा मैंने पैसा कितना खर्च किया, जितना पैसा खर्च करोगे उतना काम किया आपने। 134 किलोमीटर टर्निंग करी, 146 किलोमीटर की आपने लाइनिंग करी, 37 ब्रिज बनाए, सारे मेगा ब्रिज आपने उसी के बाद बनाए, सारी ट्रैक लिंकिंग बाद में हुई, सारे स्टेशन बिल्डिंग बाद में बनी है, ENA वर्क्स, ROCS, SNT सारे उसके बाद हुए। सर इन द लास्ट 8 वर्क्स 8 साल में प्रोजेक्ट बना है बेसिकली, क्योंकि 10 साल तो हम लड़ाई झगड़ा करते रहे। अगर वो 10 साल हमने ख़राब नहीं करते, कि चाइना की बात कर रहे थे वो साहब कि अब चाइना गए थे, बड़ा दे आर डूइंग एक्सट्रीम इंजीनियरिंग। हमारे में अगर ऐसा काम करते हो तो चाइना में उनको फांसी लटकाया जाता है, हम लोग नहीं कर सकते। यू टू फॉलो डेमोक्रेटिक रूल्स। नाउ मेगा ब्रिजेस, चनाब पे मैं ज़्यादा नहीं जाऊँगा। दिस इज पिक्चर 2013 में क्या था, देखिए बारह नथिंग, सिर्फ ये टावर्स खड़े हैं केबल केट के, केबल केट में नहीं लगी है, सब 13 के बाद में काम हुआ। उसके बाद ये सीतारमन साहब बार बार अक्टूबर की बात कर रहे थे, 21 की। तो ब्रिज वॉज कम्प्लीटेड इन अगस्त 22 व्हेन द गोल्डन जॉइंट वॉज बिल्ट। एक्चुअली तब उस तक अप्रैल 21 में आज कंप्लीट हुआ था। जो हमने ये डेक कंप्लीट किया वो अगस्त 22 में। अगस्त 22 ब्रिज वॉज कंप्लीटेड बट ट्रैक वॉज नॉट कंप्लीटेड। ट्रैक वॉज फाइनली कंप्लीटेड 23 और 24 में फिर हमने इसका CRS कराया था। ये सब तो मैं बता ही चुका आपको। अगर टाइम हो तो कहना शो यू स्मॉल वीडियो ऑफ चेनाब ब्रिज, तो मेरे को आपको हेल्प करना पड़ेगा यार आके। ये इसको यहाँ से प्ले करें, इसको प्रेजेंटेशन में बाहर आ जाओ। कोई 3 मिनट की है मूवी।
देश का मुकुट कहे जाने वाले जम्मू और कश्मीर को प्रगतिशील और समृद्ध बनाने के लिए भारतीय सरकार प्रतिबद्ध है। इसका सबसे बड़ा उदाहरण है उत्तर रेलवे द्वारा बनाई जा रही उधमपुर बारामूला रेल लिंक परियोजना, जिसके पूर्ण होने के बाद कश्मीर से कन्याकुमारी तक सीधी रेल कनेक्टिविटी उपलब्ध हो। इस प्रोजेक्ट में सबसे महत्वपूर्ण निर्माण कार्य है कटरा बनिहाल सेक्शन पर उत्तर रेलवे द्वारा बनाया जा रहा 359 मीटर ऊंचा चिनाब ब्रिज, जो कि दुनिया का सबसे ऊंचा रेलवे ब्रिज है, जिसे अत्याधुनिक तकनीक के साथ पूरा किया जा रहा है। इस ब्रिज की कुल लंबाई 1315 मीटर है और इसके कुल 17 स्पैन है। मुख्य आर्क का कुल वजन 10,619 मीट्रिक टन है। यह पुल 266 किलोमीटर प्रति घंटे की रफ्तार की हवा का सामना करने में सक्षम है। दुनिया में पहली बार DRDO की सहायता से इस पुल को ब्लास्ट रेजिस्टेंट बनाया गया है। इसे बड़े से बड़े भूकंपों से सुरक्षित रखने के दृष्टिकोण से डिजाइन किया गया है। साथ ही पहली बार भारत में पुलों को वेल्डिंग निरीक्षण के लिए फेज्ड एरे अल्ट्रासोनिक टेस्टिंग मशीन का उपयोग किया जा रहा है। इसमें की गई वेल्डिंग लेंथ का टोटल लगभग 584 किलोमीटर है, जो कि नई दिल्ली से जम्मू तवी के बीच की दूरी के बराबर है। इस ब्रिज की सबसे बड़ी फाउंडेशन S4 का आकार किसी फुटबॉल ग्राउंड के 1/3 के बराबर है। ब्रिज के निर्माण कार्य में सहायता के लिए 915 मीटर लंबी केबल क्रेन नदी के आर पार स्थापित की गई है। यह विश्व की सबसे बड़ी केबल क्रेन है। इस ब्रिज के निर्माण कार्य में 10 लाख क्यूबिक मीटर अर्थवर्क और 66,000 क्यूबिक मीटर कंक्रीट का इस्तेमाल हुआ है। उत्तर रेलवे ने कोविड महामारी के मुश्किल दौर में चिनाब ब्रिज के आर्क के कार्य को करने के लक्ष्य को हासिल कर लिया है। उत्तर रेलवे द्वारा बनाया जा रहा यह इंजीनियरिंग चमत्कार विश्व में भारत का नाम ऊंचा कर रहा है। यह परियोजना भारतीय प्रौद्योगिकी विकास और आत्मनिर्भरता को साबित कर रही है और यह रेल लिंक एक रेल एक भारत और एक भारत श्रेष्ठ भारत का सपना साकार कर रहा है।
The arch was closed on in April 21 जब कोविड चल रहा था। दैट वाज अ बिग माइलस्टोन। ये फिल्म तभी बनी थी, ये तो आपको पुरानी लग रही है। प्रोजेक्ट पूरा होने का हमने कोई फिल्म बनाई नहीं है। जैसे बताई चुके, फर्स्ट टाइम इंडिया में किसी वेल्डिंग ब्रिज के वेल्डिंग के लिए NABL एक्रेडिट लैब को साइट पे बनाया था हमने, जिससे कि टेस्टिंग के लिए बाहर ना भेजना पड़े। और अर्थक्वेक जोन 5 के लिए डिज़ाइन किया है, लेकिन साइट से स्ट्रक्चर बनाया गया उसके हिसाब से डिज़ाइन किया है। स्टेट ऑफ द आर्ट इंस्ट्रूमेंट सिस्टम हमने रखा है। हमने 4 ब्रिजेस जो मेगा ब्रिजेस सबको हमने इंस्ट्रूमेंट किया है और सबका एक कंट्रोल ब्रिज कंट्रोल सेंटर है और अभी उसको सबको कंट्रोल को एक साथ एक सेंट्रल कंट्रोल में लाने की तैयारी चल रही है। 266 kmph की क्रिटिकल स्पीड है, जैसे सर ने बताया था, विंड टनल टेस्टिंग हुई थी इसमें। ये GAD आई वोंट रिपीट इट। ये डेक है, डेक में ये देखिए ये ग्रेटिंग लगी है दोनों तरफ। ये उस ब्लास्ट रेजिस्टेंट के लिए कि अगर आप कोई 40 kg TNT के ब्लास्ट करेंगे तो ये इसको टेक केयर कर लेगा, डेक को बचा लेगा। ये सिर्फ आर्च के ऊपर है। ये एक और फोटोग्राफ है। इस पे फोटोग्राफ पे अगर आप देखेंगे पीछे एक और आपको बड़ा ब्रिज दिख रहा है। ये एक और मेगा ब्रिज है, इसको बक्कल ब्रिज कहते हैं। 777 मीटर लॉन्ग है। अगर आप बर्ड्स आई व्यू में देखेंगे तो आपको पूरा एक ही ब्रिज दिखेगा। तो करीब 2 किलोमीटर का लंबा एक ब्रिज बन जाता है। बीच में हार्डली 50 मीटर का एक गैप है। एक और व्यू आर्च का, ये ओवर द क्लाउड्स। ये आंजी ब्रिज आ गया। इसके बारे में मैं आपको आगे डिटेल बताऊंगा, तो इसमें भी ज़्यादा विल नॉट ड्वेल ऑन इट। ये रियासी ब्रिज है। ये टिपिकल इसलिए कि इसके ऊपर स्टेशन यार्ड है। ये 490 मीटर लॉन्ग है। पूरा एक कंटिन्यूस वेल्डेड स्टील कंपोजिट गर्डर है, यानी कि पूरा इससे कोई जॉइंट नहीं है, पूरा वेल्डेड है। इस एंड से इसको पुश किया गया था और इस पर 2 लाइन्स हैं, एक मेन लाइन है, एक लूप लाइन है और कंक्रीट की है और दोनों तरफ 2 हाई लेवल प्लेटफॉर्म्स भी हैं। बेरिंग है सर, बेरिंग इन पे है, लेकिन इट्स कंट्रोल ब्रिज। ये सब पे फ्री बेरिंग्स हैं, ये फ्री है, ये फिक्स्ड है। और इसमें जो सबसे बड़ी बात है सर, इसमें एक, क्योंकि 500 मीटर लंबा ब्रिज है, इसमें बिकॉज ऑफ अर्थक्वेक जो फोर्सेज आएंगे, जो नॉर्मल हमारे अर्थक्वेक रेजिस्टेंट डिवाइसेस है वो काम नहीं करेंगे। हम जनरली स्टॉपर कंक्रीट स्टॉपर्स लगाते हैं, तो इस पर हमने फर्स्ट टाइम इंडियन रेलवेज में, शायद इंडिया में फर्स्ट टाइम, वी हैव यूज प्री लोडेड स्प्रिंग डैम्पर्स। ये हमने इटली टेंसा से इंपोर्ट किए थे। ये प्री लोडेड का मतलब होता है सर, हमने 6 सिलेंडर्स को डेक और अबटमेंट के बीच में फिक्स कर दिया कि जब प्री लोड मतलब कि हमने अगर सपोज 100 टन के लिए डिज़ाइन है तो 40 टन हमने प्री लोड कर दिया। दैट मीन्स कि जो ट्रैक्टिव फोर्सेज आएंगे, टेम्परेचर के फोर्सेज आएंगे और कोई फोर्सेज आएंगे, उसको ले लेगा, वो उसको रोकेगा नहीं। तब मोमेंट कोई अर्थक्वेक आता है तो वो एक्टिवेट हो जाएगा, वो फिर उसको जाने नहीं देगा। तो इट विल ट्रांसफर ऑल द फोर्सेज टू द अबटमेंट के थ्रू। तो ये उसका काम है। तो इतने फोर्सेज के लेने के लिए वो लगाया गया है। तो 2 ब्रिजेज हमने PSS लगाया है। ये यूनिक फीचर है इसका सर। इसका अभी टॉलेस्ट पियर 105 मीटर था।
ये ब्रिज आइसोलेशन हो गया।
हाँ, ये इस पे पूरा ये स्टेशन है रियासी का, और ये यार्ड हो गया इसके ऊपर। ये बकल ब्रिज है जस्ट बिफोर चनाब ब्रिज, 777 मीटर लॉन्ग है सर। ये भी पूरा कंक्रीट कंपोजिट गर्डर है। इस पर भी 2 लाइन है, लेकिन इस पर हाई लेवल प्लेटफॉर्म नहीं है। इस पर सिर्फ 2 लाइन्स हैं। इसमें भी PST प्री लोडेड स्प्रिंग डैम्पर्स लगाए हैं। ये एक और व्यू है, बर्ड्स आई व्यू है। ये पूरा ब्रिज जा रहा है और ये चनाब ब्रिज है, और इधर बकल स्टेशन है। अब मैं स्टेशन पर नहीं दिखाऊंगा, दोनों पास है, जस्ट कंक्लूडिंग। ये रियासी स्टेशन है। आप देखिए जगह बिल्कुल नहीं है। इसको बनाने के लिए हमें पूरा फ्रेम नीचे से लाना पड़ा। तो हमने क्या किया, स्टेशन बिल्डिंग के ऊपर है, नीचे हमने RPF के और GRP के बैरक्स बनाए, यूज द स्पेस, एंड दिस इज द वे वी हैव स्टेबलाइज द हिल। ये अंदर से फोटोग्राफ है, मेन लाइन, लूप लाइन, ये टर्न होगी, दोनों टर्न है, ये ब्रिज है। ये अगला से बकल आता है। ये देखिए इसमें ये टर्न से निकला, और ये सब कंक्रीट का है। ये दुग्गा स्टेशन है, उससे अगला ब्लॉक सेक्शन है। इसमें भी आप देखेंगे मेन लाइन, लूप लाइन, हाई लाइन प्लेटफॉर्म से ये दोनों ब्रिज है। फिर बीच में जगह वहाँ स्टेशन बिल्डिंग बनी है, इधर ही ब्रिज है, इधर ही ब्रिज है। एक और फोटो है दुग्गा की। फिर एक सावलकोट स्टेशन है, ये सबसे एक्सट्रीम लोकेशन पे है प्रोजेक्ट के। इसमें आप देखेंगे पूरा का पूरा मेन लाइन, लूप लाइन ब्रिज के ऊपर जा रहा है, और दोनों हाई लेवल प्लेटफॉर्म है, ट्रेक टनल है, और ये एस्केप टनल है। ये संगलदान स्टेशन है। ये इस सेक्शन का सबसे बड़ा स्टेशन है। यहाँ पर की 4 लाइन है, मतलब कि वी हैव गॉट 1 मेन लाइन और 3 लूप लाइन है। तो जो मैक्सिमम क्रॉसिंग इसी जगह होंगी। कभी जब हमने काम शुरू 2004-05 में किया था, इट वॉज अ स्मॉल हैमलेट ऑफ हार्डली 100 पीपल। आज इसे बस्टिंग सिटी, लोगों को इतना रोज़गार मिला, देवर वरीड के जो लाइन आ जाएगी हमारा क्या होगा, और उनको पता है कि जब ट्रेन आती तो बहुत डेवलपमेंट होता है। तो पूरा शहर बस गया है। एक और व्यू है, कितना अच्छा सुंदर है। ये आप देखिए सब स्लोप प्रोटेक्शन है टर्न्स के ऊपर। तो दोनों तरफ टर्न है। आप यार्ड को देखिए, कोई बैलेंस सब कंक्रीट के ट्रैक्स है। फिर ये सुपर स्टेशन है सर। इसमें ये पूरा हिल हमारा स्लिप कर रहा था, तो इसमें हमने पूरा प्रोटेक्शंस कर रखे हैं इसमें। ये अंदर से इसका व्यू है सुपर स्टेशन का। फिर ये खड़ी लास्ट स्टेशन है। इस पर आप देखिए प्रोटेक्शंस को। ये अंदर से जब बर्फ़ पड़ी, तब सुंबर तक बर्फ़ पड़ती है, सुंबर के आगे बर्फ़ नहीं पड़ती, तो उस टाइम पे जो फोटो ली, ये बर्फ़ पड़ी होती है। सोशो इकोनॉमिक इफेक्ट तो बताई दे आपको। हम लोगों ने जिनका लैंड 75% से ज़्यादा एक्वायर हुआ था, उसमें हर फैमिली के एक आदमी को पक्की रेलवे की नौकरी दी है। तो अबाउट 800 लोगों को नौकरी मिली है। इनडायरेक्ट एम्प्लॉयमेंट जो कॉन्ट्रैक्टर के थ्रू होता है, 570 लाख मैन डेज का हमने एम्प्लॉयमेंट जनरेट किया। 65% लोकल से, जिनकी मल्टी स्किलिंग हुई, नाउ देयर एक्सपर्ट और इसी कंपेयर और हाइड्रो प्रोजेक्ट आगे काम कर रहे हैं। स्किल डेवलपमेंट तो ही क्या, जो मैं मल्टी स्किलिंग की बात कर रहा हूँ। फिर अप्रोच रोड, ये मेजर था जो हम लोगों ने पता अप्रोच रोड बनाई, जिसमें एक टनल भी थी और 320 ब्रिज थे, और करीब 95 विलेजेस को पार्ट में कनेक्ट किया। 1.5 लाख लोगों को बेनिफिट हुआ। 3 से रोड उनसे निकली, एक नेटवर्क बना रोड्स का। मतलब इमीडिएट बेनिफिट मिला प्रोजेक्ट का। जो प्रोजेक्ट भले अभी कमीशन हुआ है, क्योंकि रोड ऑलरेडी वहाँ पे डेवलप्ड हो चुका था। ये वो एक ब्रिज है चनाब के ऊपर, हम लोगों ने, रेलवे ने बनाया ये फॉर आवर ओन लॉजिस्टिक्स, जो अब परमानेंट हो गया। अब ये उनके काम आता है ऊपर। सीएट के, ये चनाब जाने के लिए एक टनल बनानी पड़ी हमको सर, ये बक्कल एंड पे टू अप्रोच द बक्कल एंड ऑफ चनाब ब्रिज, ये टनल को हमें बनाना पड़ा था। ये बेले ब्रिजेज है कई सारे। अब आप देखिए अप्रोच रोड्स कैसी है, तो सी और उनको मेंटेन कैसे करना है। अब किस तरह से टनलें बन रही है, देखिए सब पे पहाड़ काट के 30 डिग्री पे भी आपको फोटोग्राफ दिखाते हैं, देखिए जस्ट सी। अभी आपने 70 डिग्री की सड़कें बनते देखी है रेलवे में, ये देखिए किस तरह बन रही है, 4-5 प्रोग्राम ये करिए। मेरा अपना एग्जाम्पल है, मेरे उन दिनों कोविड चल रहा था सर, इसी एडिट के लिए सड़क के लिए फॉरेस्ट डाइवर्जन का केस चल रहा था, तो ऑन वीसी चंडीगढ़ में पीसीसीएफ मीटिंग ले रहे थे, तो उन्होंने एक ही चीज़ बोले कि मेरे को ये बताइए ऐसे उस पर सड़क कैसे बनाओगे आप। तो जम्मू कश्मीर के जो सीसीएफ थे उन्होंने बोला सर रेलवे वाले कुछ भी कर सकते हैं, एंड ही एग्रीड, और सड़क बन गई। ये देखिए और इस सड़क को फिर मेंटेन करना सर, इट्स ए जॉब इन इंस्टेंस। अभी ये झगड़ा ये चल रहा है कि प्रोजेक्ट कमीशन हो गया, ये रोड को कौन मेंटेन करेगा। तो हम कह स्टेट वाले कर नहीं सकते, हमारा ओपोनेंट कर नहीं सकता, और इट्स अ बिग प्रॉब्लम, इसको मैनेज कैसे करेंगे, क्योंकि डिजास्टर मैनेजमेंट के लिए बहुत ज़रूरी है। थैंक्स। ये मेरा यूएस प्रोजेक्ट का पूरा हो गया, ब्रेक देना नहीं तो मैं आगे आंजी में चलता हूँ। या इट इज रोड पर एक्चुअली मैं आपको बताता हूँ, यूएसी को होता है, यूएसी 779 आर में वर्ल्ड स्टैंडर्ड है कि जो लॉन्ग टर्म होती है उसको सेफ्टी एस्केप के लिए नीड टू हैव ए पैरेलल एस्केप। इंडिया में तो पहले 3 किलोमीटर टर्म होती नहीं थी, जब बड़ी टर्म आई तो हमें एस्केप बनाने के लिए तो उसमें डिसाइड किया गया कि आधा सेक्शन रखिए पैसा होता है। आई गिव रिकमेंडेशन, मेरे कमेटी में रखा गया था कि रोड वालों ने कि हमें रेलवे लाइन से सड़क वालों को बनानी पड़ेगी एस्केप रोड, तो कॉस्ट आती है। तो कमेटी वॉज मेड की वेदर इट इज रिक्वायर्ड और नॉट। हमने पूरी वर्ल्ड में स्टडी किया, सिर्फ जापान में पता चला कि दे आर नॉट मेकिंग एनी एस्केप। रीजन क्या है, एस्केप वाला उन्हें रिक्वायर्ड एक ही हमारा हैजार्ड हो सकता है, आग लगना सबसे डिफिकल्ट है। आग लगने पर क्या होगा, तो वी हैव गॉट वेंटिलेशन टाइम्स, तो आपके स्मोक को डिफरेंट डायरेक्शन में करेंगे, लोग एस्केप एस्केप करा। When we made a study, we found कि जापान में 20 किलोमीटर ग्राउंड है विदाउट एनी एस्केप। When we discussed with डॉक्टर रिपाठी का डिटेल में गए, उनका कहना था कि आग लगती कैसे, आग लगती है ट्रेन में, बोलते हमारी ट्रेन आग नहीं लगेगी, तब मटीरियल उनके ट्रेन में होता है, बोलता आग लगने में 2 घंटे लगेगी, तो आप लगाओगे पूरे करेंगे, तो इसलिए नहीं लगाना ना। तो उनकी मोटी पावर इतनी है कि अगर आग लगेगी ट्रेन में तो विल नॉट स्टॉप इन दैट ट्रेन को भाग। इसलिए जब हाई स्पीड का प्रोजेक्ट चल रहा है मेरे इंडिया का, वो सिंगल ट्यूब बना रहे हैं इंडिया में 2019 द सेम मेरा प्रोजेक्ट ओनली 350 टन का शाफ्ट ताकि हमें एडिट, क्योंकि हमारा ओवरलोड बहुत ज़्यादा था, शाफ्ट कहीं भी पॉसिबल था, सिर्फ T8 की कहीं तो मैंने वहाँ पे एडिट क्या वहाँ पे कभी ओवरलोड कम था और एडिट बहुत पॉसिबल नहीं था। शाफ्ट बनाने का 2 ही रीज़न होता है, या तो वेंटिलेशन के लिए, वेंटिलेशन को प्रोवाइड करना ही है, हमें शाफ्ट पे एडिशनल स्पेस मिलता है। तो हमने जितने एडिट्स बनाए, एडिट्स का करके देखिए हमने जो लॉन्गेस्ट टर्न बनाई है 13 किलोमीटर की, उसमें एस्केप वाला भी है, टोटली 26 किलोमीटर, ये कंप्लीटेड टर्न है अबाउट 6 ईयर्स। 6 साल में मैनुअली करने के लिए आप एक फेस पर काम नहीं करेंगे ना, यू नीड मल्टीपल फेस। तो मल्टीपल फेस बनाने आपको नंबर ऑफ एडिट्स मिलते हैं। तो एडिट हम लोगों ने अपने आप अपनी इंजीनियरिंग से एक जगह टर्न 6 किलोमीटर थी, सीधा ऐसे ग्रेड में थी, फिर पहले पता लगेगा कि इसमें एडिट नहीं बनाया हमने, कोई टर्न कर दिया, तो हमने उस टर्न को बाद में एडिट बनाया, जबकि एडिट वो 900 डिग्री, पहले एडिट शुड नॉट बी मोर देन 5 मिनट, लेकिन उस एडिट के चलते वो टर्न के बाद में आपको सेफ्टी रेस्क्यू काम भी करती है और ड्रेनेज काम भी करती है, पानी की। नहीं इसे सिंगल सब सिंगल है, 2 चनाब ब्रिजेस है वो तो ट्रैक, एक ट्रैक एक डाला गया है। अंजी ब्रिज के मैं बताऊँगा वहाँ पे एक ट्रैफिक रोड है। एक्चुअली क्या है कि हम लोग जब रेलवे में सर्वे करते हैं ना, मैं इंडियन सी बात करता हूँ, अभी आप JNK में करा तो लोग कहते हैं वहाँ तो कोई कि हमने ROR नहीं होते, ROR
रिटर्न रेट ऑफ रिटर्न क्या होगा आपका कैपिटल को, जो ट्रैफिक सर्वे करते हैं तो रेट ऑफ रिटर्न नेगेटिव आता है। तो पहले तो इसलिए इसको नेशनल प्रोजेक्ट किया गया, तो ये पता कि इससे रेगुलेशन को तो मिलेगा नहीं, तो नेशनल प्रोजेक्ट रखेगा कि सेंट्रल गवर्नमेंट ने डायरेक्टली फंड कि भाई डेवलपमेंट के लिए ये सोचते हैं कि वी आर नॉट गोइंग टू गेट एनी जनरेशन और रेवेन्यू आउट ऑफ इट, लेकिन होता उठता है। द मोमेंट जम्मू उधमपुर जब था वो नेगेटिव में था, अब उसकी डबलिंग की बात हो रही है, पहले बिकम सर्टिफिकेट उधमपुर का ट्रायल बिकम सर्टिफिकेट, इसकी डबलिंग की बात हो रही है। अब इसकी भी बात हो रही है, अभी ट्रेनें चल रही है ना, अभी रात को ट्रेनें चल रही है विदाउट सिक्योरिटी से चलेंगी, तो उसकी कैपेसिटी 16 ट्रेन की है, 16 पेयर्स की, वो भी सेचुरेट हो गया, ठीक है, गुड्स भी लेके जाना आपको। अब दिल्ली एरिया में अगर आप ट्रेडिशनल प्लानिंग करेंगे तो अलॉन्ग द सेम अलाइनमेंट आप बदलेगी। अब चेनाब ब्रिज को आपने डिज़ाइन किया 2 लाइन के लिए, वहाँ तो फिर अगर टनल तो आप सिंगल ही है, तो आप कभी नहीं कर सकते, तो उसके रीज़न कुछ और था, तो जस्टिफाई करने के बाद आप जानते हैं विदाउट स्टेबिलिटी वी नीडेड ए बोर्ड, हमें 15 मीटर विड्थ डेक चाहिए था, हमें क्या बोला नहीं चेक करने में होता है कि अगर आप सिटी सोच कर रखते हैं ना, बिल्कुल इतनी हाइट पे आपको लॉन्चिंग करनी है, आप स्केलिंग के बोलते हैं, लॉन्चिंग करने के लिए कंट्रोल करना, वरना आपको कंप्यूटर गर्डर को टीम पे कनेक्शन देना और कंप्यूटर गर्डर इज एफिशिएंट, उसका वेट भी कम होता है, सिटी सोच रहेगा वो रखें।
ये आपका सीट सेक्टर है
तो हमारा मैं बता रहा हूँ कच्चा बंगाल सेक्शन सारे के सारा एक दूसरे छोड़ के सारे स्पीड के बीच
तो मेरा है कि गवर्नमेंट इफेक्ट से जो कुछ भी है 120 साल चलना है आपको, तो सरोजन क्या
सर इसमें बताता हूँ आपको। पहली बात तो जो हमारा एनवायरमेंट है सर, आप लोगों को पता होगा जो हमारा एनवायरमेंट होता है उसको 5 पार्ट में डिवाइड किया, C1 C2 C3 C4, C5 इज द मोस्ट कोरोसिव एनवायरमेंट जो सी शो होता है बॉम्बे, हमारा C1 टू हिल्स। उसके बाद भी सर चेनाब ब्रिज को 20 ईयर 30 ईयर पे पेंट करने की ऑर्डर की, और सिंस इट वॉज लमसम कॉन्ट्रैक्ट वी कुड नॉट, वहाँ पर कॉलेज पे पेंट लगाया, पेंट लगाया, इट विल लास्ट एक्चुअली फॉर 15 ईयर। 2 ब्रिज जो मैंने पक्का और रियासी का है, ये और है, हमने टेंडर में ही डाल दिया था कि हमें लॉन्ग लास्टिंग पेंट, तो उसमें चिकोको कंपनी का जैपनीज पेंट है, ये प्रोवाइडेड उसको C5 पेंट करता है, C5 जिसका उसकी लाइफ 25 है, तो जापान में तो वो वैलिडेट नहीं हुआ है, बट वी होप इट विल लास्ट फॉर उसके उसका नंबर इंस्ट्रूमेंटेशन में 4 बजे 4 वाले देख पे लिखा है,
अभी इसमें भी किया,
इस पे किया, चुनाव में किया, अंजी में किया है, रियासी में किया,
चुनाव में किया।
हाँ चुनाव
नाउ मेरा एक क्वेश्चन कि जो भी डेटा आप ट्रैक करोगे, लाइव करोगे, प्रोसेस करोगे, ये 120 साल का क्या
सर मैं बताता हूँ इसमें क्या है, आपका बहुत वैलिड क्वेश्चन है। गार्वेजिंग गार्वेजर वाले साथ में 24 आवर आई एम कलेक्टिंग लॉट ऑफ डेटा, तो हमने क्या किया है कि फ्रॉम द डिजाइनर वी आर टेकिंग 3 लिमिट्स, अटेंशन लिमिट, अलर्ट लिमिट और अवेयरनेस लिमिट, वो लिमिट्स आपने हर पैरामीटर की दी, तो उसी हिसाब से जो हमारा सेंट्रल कंट्रोल में जाएगा, जैसे कि विंड इज क्रिटिकल फॉर अगेन चुनाव, ठीक है, मेरी विंड जो मैंने कहा 72 km के ऊपर जाएगी, तो आई हैव टू स्टॉप माय ट्रेन, तो उसके लिए हमने एनिमेटर लगा रखा है, सिग्नल्स हैं, तो मूवमेंट हुआ है तो वो ट्रेन हो गया। इसी तरह के सारा जगह डेटा पे हमारे में लिमिट्स है, वो डेटा हम डे टू डे बेसिस मॉनिटर करें, एंड वी आर रनिंग ए जिस एजेंसी ने मॉनिटर लगाया उसी को एनुअल मेंटेन कंप्लीट किया जाएगा। उसको देखिए, अगर आपको पता ही नहीं होगा करना क्या तो क्या करेंगे, तो डिज़ाइनर ने ऑलरेडी कर रखा है कि अगर आपकी अवेयरनेस लिमिट आएगी तो क्या करना है, अटेंशन लिमिट आएगी तो क्या करना है, ट्रेन ओपनिंग के बाद क्या करना है, किस पार्ट में क्या चीज़ है, हर चीज़।
तो मेरा मतलब है कि ये जो भी स्पेशलाइजेशन से ले आई है, तो वो 120 साल तक काम करने के बाद
जैसा कि ये रिवॉल्व आज से 20 साल पहले 3 लोग कहते हैं फॉरवर्ड, हम टर्न बनाना मुश्किल हो गया, 2 जना आसान, आज हम 25 किलोमीटर करने बना रहे, 14 की हमने बना दी, 15 की कैमरा की बन रही है, अभी हाई स्पीड वाले 30-25 की बना रहे हैं, और टर्निंग का अब ये रिवॉल्व सब जगह रिवॉल्व कर रहे हैं, जितना डेटा हम जनरेट कर रहे हैं उसको डिसमिनेट करके और अच्छी प्रैक्टिस
नहीं हो गया। अभी यहाँ दिल्ली में स्पीकर भी था ना, ये कितने साल लगे,
पता है
अभी मेरा बैचमेट है जो उसको सिक्योरिटी के बनाया, तो वो अभी इंस्ट्रूमेंटेशन भी किया, पर उसका डेटा का नॉलेज लो।
क्या तू कोई फोन नहीं कर रहा है हमारे सिस्टम में रेलवे में नहीं होता, रेलवे में ऑलरेडी ये कौन करेगा, अभी से कंफर्ट रेलवे वगैरह खेली जाएगी कि आपको ही कोई डेटा रखेगा, नॉर्दर्न रेलवे का इंचार्ज, नॉर्दर्न रेलवे डिपार्टमेंट ऑफ रेलवे बोल रहा है, उस डेटा का पूरा यूज़ करेंगे। उसको हो सकता है कि देखिए अभी आप उस पर हमारा केबल सेट ब्रिज पे एक एक केबल को इंस्ट्रूमेंट करें, हर केबल में कितना फोर्स आ रहा है वही नहीं पता है, तो इसका नहीं यूज़ किया, आपको रजिस्ट्रेशन करना ही करना कोई सर ओन करना पड़ेगा ना काम को, अगर आपने इतना इंस्ट्रूमेंट किया है, सिस्टम को करना और सिस्टम को इम्प्रूव करना।
तो रेलवे का डेटा पूरा मिल गया,
तो रेलवे का आपको एक ब्रिज मैनेजमेंट सिस्टम होता है BMS, हर एक ब्रिज का सारा डेटा उस सिस्टम पे ऑनलाइन है, सारे इंस्ट्रक्शंस का रिजल्ट ऑनलाइन होता है, उस पर क्या आपका व्यूज़ है, क्या आपने रिपेयर किया है, वो ऑनलाइन आ जाता है। और अब तो एक और सिस्टम आ गया, सब ड्रोन से सर्वे, मैनुअली भी नहीं करते थे, ड्रोन से करके वो भी सीधा इनपुट होता है। तो ऐसे ब्रिज मैनेजमेंट है, ट्रैक मैनेजमेंट है, लैंड मैनेजमेंट है, अब टनल मैनेजमेंट भी बन रहा है। तो रेलवे ऐसा ऑनलाइन है, आप चेयरमैन रेलवे बोर्ड साहब अपने कमरे में बैठ करके सब देख सकते हैं, किस अफसर ने इंस्पेक्शन करा, नहीं करा, क्या करा, रेलवे इसका होता है सर। वेरी वैलिड पॉइंट, मैंने आपको बोला 2010 के अंदर मुझे कोर्स करें ये पॉइंट था, इससे ग्लोबल था, अब वो पंजाब पाकिस्तान में मरी से लेकर के नॉर्थ ईस्ट तक, यानी कि वी हैव टू क्रॉस दैट सर्टेन था थर्स्ट ऑफ क्रॉस, तो ये मेजर था। गलती क्या ही ना होता, जब हमने उधमपुर कटरा को नेगोशिएट किया था, मैंने वो आपको नक्शा लगाया मुझे आपको उसको भी हमने NGT को नेगोशिएट किया 2 बार, पहले इससे स्टार्ट किया, फिर क्रॉस किया, वो शिवालिक का और मरी का वहाँ प्रॉब्लम है कि सब में टोल नंबर 45 तक निकलते थी, वो क्लैश हो गई, उसमें जल बनने के बाद में सीरियस फ्यूजिंग और सीलिंग, ठीक है, और लाइनिंग भी क्रैक हो गई, तो हमको 1.8 किलोमीटर ब्लू करना पड़ा, वो हमें NTM से करते हैं, ब्लू ग्लास से करते हैं। तो वी थॉट कि NTM विल बी एबल टू हैंडल। यहाँ पे क्या लोचा था या जो पेज था, यहाँ पे मरे नहीं था, यहाँ पे सर्वन डोर ये थॉट कि NTM से प्रोफेसर डॉक्टर ग्रेट बॉल्सन ने इसको हैंडल किया सिंगल हैंडल पे, इसको भी कर देंगे, और किसी आगे सोचा नहीं, जब फंसे तो बोलने पानी कर देते, देन वी हैव टू टर्मिनेट डॉक्टर बॉल्सन। फिर हमने ITM को यूज़ किया, ITM को कमेंट करते हैं, बिकॉज इट इज वेरी वेरी कॉस्टली, पानी में टर्निंग करने में या तो आप ग्राउंड फ्रीजिंग करो या फिर ये करेगा आप दूसरा करो। पानी का ही पता था, पानी का ही पता था, क्रश ट्यूबर का ही पता था, लेकिन इस तरह का स्लरी निकलेगा ये नहीं पता। हम लोग आप ये नहीं करेंगे NTM से, मैं बता आपको 450 मीटर का एमपी था, 100 मीटर 50 मीटर में टैकल कर भी लिया था, लेकिन जब तक पानी ज़्यादा नहीं था यू आर एबल टू टैकल। अब इस तरह के स्ट्रक्चर में कैन यूज द रॉक रोड, क्योंकि वो नो यूज मेरे तो सारा रॉक रोड होता है, और वो हमारे डॉक्टर कॉल्सर के वो बोलिए जी रॉक रोड लगवा रहे हैं। एनीवे बट इट इज़ वेरी कॉस्टली, आई ऑलवेज से इस टेक्निक को बहुत ही समझदारी से इस्तेमाल करना है, वी कांट यूज़ इट आँख बंद करके 10 टाइम कॉस्टली है। हाँ वो तो इंडिया में जैसे एस्टिमेशन आता है ऐसे होता है, तो डीकर बनाते हैं, मैं आपको बताया था, मेरे को बता देता हूँ, ये प्रोजेक्ट सैंक्शन हो गया 1592 इसकी DPR बनी 3077 करोड़। कैसे DPR बनी, तो कुछ शीट के ऊपर जो राइट से अलाइनमेंट लगा दिया, उससे आपने कुछ फॉर्मूला लेकर जम्मू दम्पू के कॉस्ट में कंप्यूटर कर, ठीक है सर। उसके बाद में कुछ काम बढ़ा, कुछ आइडिया लगा हमको, कटरा बनिया के लिए सड़कें नहीं थी, कोई सर्वे नहीं हो सकता। अब हमारे बहुत अच्छे जियोफिजिकल टूल्स आ गए हैं,
जो आप मीनार से कर लेते हैं, हेलीकॉप्टर से कर लेते हैं, एरियल सर्वे कर लेते हैं, उस टाइप के हमने फोटो ले रखी NRSA के यूज़ करते हैं। तो जो बेस्ट पॉसिबल तरीका था उससे हम लोगों ने एक CC अप्रूव कॉस्ट में उसका एक्सपेक्ट कॉस्ट करते हैं वो 20,000 करोड़। और आप बिलीव नहीं करेंगे 2015 तक कटरा बनियाल सेक्शन का यूटिल एस्टेट बना वो मैंने और मेरे लोगों ने तो कुछ फचड़े पड़ रहे उसको सैंक्शन करा के वो 27,000 करोड़ का बना था। फाइनली अब ये 43,000 करोड़ का कंप्लीशन।
हाँ
How much time you have jumped?
देखिए टाइम का देखिए 94-95 में बहुत फंक्शन हुआ था। जो कटरा बनियाल का जो क्रिटिकल सेक्शन है ये हमें 2002 में टिका 2002 में नेशनल प्रोजेक्ट किया। तो वो तब ये आंधी और चुनाव के क्रम में कभी हुआ जब तक हम स्पीड पकड़ते लैंड रिक्वायर करते 2007 में वो हेलमेट का इशू हमारे दोस्तों ने चालू कर दिया। 2007 से 2016 तक प्रैक्टिकली निकली और मैं बताइए 16 से लेकर के 8 साल में अगर कोई मेरे से कहेगा मैंने 8 साल में कुछ जो प्लेटेज हो बोले चले तो वे आप प्रोजेक्ट करते हैं आप इंजीनियर की तारीफ करना चाहते हैं तो वो जगह आपने डिपार्टमेंट दूसरा नहीं मैंने उससे करनी 8 साल में। अगर आप हमें विजिट करना चाहते हैं इंजीनियर को विजिट से
8 साल में कोविड भी था।
कोविड का फिर कोविड आया पुलवामा केस आया पुलवामा में सारा एक्सप्रेसिव वाला मत हो गया यह तो चैलेंज बहुत चैलेंज था उसके बाद सैंड माइनिंग तो बैन हो गया सैंड नहीं था। ये सब हमने चैलेंज फेस करे हैं और वहाँ पे जो क्लियर साइकिल सुसाइड कर लेते तो ही वहाँ पर लेबर आती है बिहार से और बंगाल से पठानकोट में हमें लास्ट हुआ था ठीक है मतलब कि आपसे से बता रहा हूँ कि मैं तो फैमिली छोड़ के 15 साल सही करा मैं फैमिली वाले दिल्ली जैसे करके जो सेक्रीफाइस किया है मैं जानता हूँ। आफ्टर रिटायरमेंट सर मेरी स्लीप पैटर्न बदल गई रात को नींद नहीं आनी मतलब कि वो प्रोजेक्ट दिखता था और वाइफ बोलती थी आप रिटायरमेंट मोबाइल में क्या देखोगे अब तो प्रोजेक्ट नहीं चल रहा है। एनीवे अब अंजी ब्रिज के बारे में आपको बताना चाहता हूँ। आई कंसिडर इट्स माई बेबी इट वॉज सपोज टू बी अ स्मॉल चेनाब ब्रिज। इंडियन रेलवे में किसी की हिम्मत नहीं थी कि केबल स्टेट ब्रिज के बारे में सोच भी सके। सबको लगता है कि इसमें मूवमेंट्स होंगे ट्रैक पे क्योंकि ट्रैक में अगर 10 मिलीमीटर का मूवमेंट है तो ट्रेन रेल हो जाती है तो कोई सोच नहीं सकता था। 2011-12 में बिफोर प्रेजेंटेशन में आपको एक ब्रीफ दे रहा हूँ। जब ये अलाइनमेंट का इशू आया तो सीतारामन साहब ने ये बोला कि वॉज ऑल्सो कंसर्न फॉर अंजी ब्रिज एंड ही वॉज नॉट अवेयर कि हमने उनको निकाला किसने क्या निकाला। वी ओनली गेव अ ऑप्शन टू द कॉन्ट्रैक्टर वेदर यू वांट टू कंटिन्यू और नॉट। तो गैमन जेवी डिसाइडेड टू गो फॉर अ शॉर्ट क्लोजर। कुंकण रेलवे उन्होंने दे डिसाइड टू गो फॉर शॉर्ट क्लोजर। उनको पता था ये ब्रिज नहीं बन सकता क्योंकि लास्ट को दिखाऊंगा ये चुनाव के दोनों तरफ से बहुत स्पेस है। अंजी में जो कटरा एंड है वहाँ जगह ही नहीं है तो एक ट्रैवल निकलती है उसके बाद हार्डली 20 मीटर तो वहाँ पे आपको ना कोई केबल चेन बना सकते हैं। उनको समझ नहीं आता वो क्या सिस्टम बनाए जिससे कि आर्ट्स पे रखते हैं तो दे गॉट ए वेरी गुड अपॉर्चुनिटी कि आप शॉर्ट लोड करके मतलब ऐसा आर्टिफिशियल लोग कर सकेंगे। उसके बाद 2011 से लेकर के 2016 तक कुछ नहीं ये रेलवे वाले एलिजिबल सोचते रहे क्या करें उनको रेलवे लेके त्रिकोणों काम दे दिया इसे उसको दे दिया। आई लैंडेड इन 2012 और मैं 12 से 14 तक दिल्ली रहा उधमपुर कटरा कमीशन। उसके बाद ये आंधी चुनाव भी मेरे को मिला फिर हम लोगों ने इस वर्क को वापस हमको रेलवे को दिया था। इटालफर एक इटालियन पर्सन था उसको अपने कंसल्टेंट बनाया उसको बोला कि यू गिव अस ए सॉल्यूशन कि आप सबसे अर्लीस्ट क्या चीज़ बन सकती है। देन दे गिव अस ए सॉल्यूशन कि भाई यहाँ पे एसिमेट्रिकल सॉल्यूशन पॉसिबल है क्योंकि एक ही जगह है दूसरी जगह ही नहीं। देन ही गिव 2 ऑप्शन की या तो स्पेंडल आर्च टाइप का बनाना एक कैंसर से करते या एक केबल से भी होना। तो उसमें हमने जो उसकी स्टडी करी जो एनालिसिस करी कॉज एंड कॉन्स थे उसमें ये देखा गया कि केबल स्टडी वॉज मोस्ट अप्रोप्रिएट क्योंकि इट हैड ए डिफाइंड टाइमलाइन फॉर कंस्ट्रक्शन। उस पर हमने 4.5 साल एमसीएच किया था 5 साल एंड ही वॉज चीपेस्ट। और नेगेटिव बात ये थी कि इंडियन रेलवे में वी हैड नो एक्सपीरियंस ऑफ ए केबल स्टडी सर एक ही सेंटर से जो है 280 मीटर तो इसको जब हमने प्रपोज किया था एज चीफ मैंने उसको पूरी फाइल में लिख करके अप्रूव करवाया था और फ्रॉम दैट डे फ्रॉम स्टार्टिंग टू बिगनिंग और ख़त्म करने तक और इसमें लोड टेस्टिंग भी मैंने कराया। अभी वर्ल्ड ओवर लॉन्ग स्पैन ब्रिजेस का लोड टेस्टिंग कई बार भी कोडिफाइड नहीं बट हमने इस पर कराया
टाल पर से स्कीम ली, फिर लोड टेस्टिंग क्या होता है, आप लोडिंग करते हैं, रिफ्लेक्शन देखते हैं, फिर लोडर आते हैं, फिर रिबाउंड देखते हैं, यही होता है ना। तो हमने कहा हमें स्कीम बता के दीजिए, उस पर एक ट्रैक भी है और एक सड़क भी है। तो हमने ट्रैक को डिफरेंट लोडिंग पैटर्न पे लोड किया, जैसे फुल बलास लोडेड फ्रेट ट्रेन, और रोड के ऊपर ट्रक्स को लोड किया विद बलास। उसके फिर हमने टोटल स्टेशन से रिफ्लेक्शन नोट किए, उसका रिबाउंड नोट किया, प्लस GNSS है, GNSS ग्लोबल जो सैटेलाइट नेविगेशन सिस्टम होता है, उससे हमने फिर XYZ कोऑर्डिनेट निकाले, ते वर ऑलमोस्ट टेलिंग, और बहुत बढ़िया रिजल्ट्स हैं। तो फर्स्ट टाइम किया तो लोग आलोक वर्मा ही वॉज वेरी हाईली क्रिटिकल, वो बोलते हैं नहीं ये तो लोड टेस्टिंग गलत है, आप पता नहीं कौन सा सिस्टम क्या होगा। हमने हर चीज़ करी, और चेनाब ब्रिज पर लोड टेस्टिंग इसलिए नहीं हो सकती, द ब्रिज हैज बीन डिजाइन फॉर 2 लाइन्स, उतना लोड आप कहीं से ला ही नहीं सकते टेस्टिंग में, ऐसे देखो। तो आई विल टेक अप द नेक्स्ट रो। ये जैसे कहा कि इट इज़ इंडियन रेलवेज फर्स्ट केबल स्टीड ब्रिज। मैं इसे बताना चाहता हूँ कि दिस इज फ्यूचर ऑफ इंडियन रेलवेज। चेनाब ब्रिज इज ए मोनूमेंट, इज ए मार्वल, मे और मे नॉट बी रिपीटेड, मे नॉट बी रिक्वायर्ड, ठीक है, बट केबल स्टीड ब्रिजेस तो फ्यूचर है। अब रेलवेज को समझ आ गया कि वी कैन मेक केबल स्टीड ब्रिजेस। और जो हमें बड़े बड़े क्रॉसिंग्स हैं, अभी क्या हो रहा है आप लोग देखा होगा कि 2 यार्ड्स क्रॉस करते हैं क्रॉस, अब आप यार्ड को भी यूजिंग ए केबल स्टीड क्रॉस कर सकते हैं। इस केबल स्टीड में आपको बड़ा स्पैन मिलता है, यू कैन गो इवन अप टू 726 मीटर अगर आपका सिमेट्रिकल हो। ये तो एसिमेट्रिकल है, ये करीब 300 मीटर का स्पैन है। अगर 2 स्पैन वाला सिमेट्रिकल ब्रिज है तो हम 700 मीटर का भी केबल स्टीड ब्रिज बन सकता है, 2 लाइन के लिए 3 लाइन के लिए बन सकता है। तो जैसे दिस इज फ्यूचर ऑफ इंडियन रेलवे, और ये रेलवे के ऊपर है वो कितना आगे वो करता है। ये जब प्रोजेक्ट शुरू हुआ था तो ये हमारा स्कीमेटिक डायग्राम था जो बनाते हैं लोगों ने कहा था ये भी कैलेंडर पे आता रहेगा, ब्रिज बनेगा नहीं। तो उसमें ये था कि ये एक एंसिलरी वायडक्ट था शुरू में, क्या वो सीतारामन साहब कहते कुछ पुराने पियर्स बने थे उन्होंने तोड़ दिए। ये 120 मीटर का वायडक्ट है, बीच में 94.25 मीटर का सेंट्रल एम्बैंकमेंट है। फिर ये हमारा मेन केबल स्टीड ब्रिज है जो 473.25 मीटर का है, और बाद में एक 38 मीटर का एक और कनेक्शन है। फिर यहाँ टनल T2 आती है, T2 है मतलब पॉइंट टनल नंबर है, नया T34 है, और इधर एक टनल नंबर T3 है जो T35 में है। पोर्टल टू पोर्टल डिस्टेंस 770 मीटर। इसको ब्रिज करना था। अब आप ये पूछ सकते हैं कि भाई आपने केबल स्टीड ब्रिज के वायडक्ट को यहाँ तक एक्सटेंड क्यों नहीं करा। इसका रीज़न ये था सर, आई नीडेड अ स्पेस टू मेक माई वर्कशॉप में मेरे को जो डेक को इरेक्ट करके लॉन्च करना था, इसलिए मैंने इसको अर्थवर्क करा। और ये फर्स्ट टाइम इंडियन रेलवे में हमने सीमेंटेशियस अर्थवर्क किया है। जनरली अर्थवर्क आप करते हैं उसको कम्बैक्ट करते हैं, ये सीमेंट बेस्ड अर्थवर्क है, ये केस है। तो ये था, ये एज ब्रिज है, वो सीमेट्रिक आर्टिस्ट इंप्रेशन था। ये नवंबर 24 का है, पूरा ब्रिज बन चुका है। ये अप्रोच वायडक्ट है 120 मीटर का, ये 94 मीटर का एम्बैंकमेंट है। आप इतना पोर्शन अगर आप देख रहे होंगे ना, इसको बल्कहेड कहते हैं, ये इसको हम MA2 कहते हैं, मतलब मेन ब्रिज का अपार्टमेंट 2, क्योंकि ये एसिमेट्रिकल ब्रिज है। आप ये देखिए, ये मेन स्पैन है 290 मीटर का, और यहाँ पर हमने 38 मीटर का एक अलग से सिम्पल स्पोर्ट स्पैन डाला है, यहाँ टनल का पोर्टल आएगा। अब आप कह सकते हैं कि भाई आपने स्पैन को क्यों नहीं बढ़ा लिया, एक स्पैन ये एक्सपेक्ट डाला। रीज़न ये है कि जितना हम लंबा जाएंगे ये लेंथ विल हाइट ऑफ पाइलर वुड हैव बिकम अनकंट्रोलेबल। इससे क्योंकि इस केस में भी विंड इज क्रिटिकल, नॉट अर्थक्वेक। अर्थक्वेक कोई भी क्रिटिकल नहीं है, विंड क्रिटिकल, क्योंकि ये गॉर्जेस गॉर्ज में विंड का इफेक्ट होता है। तो ये टनल ये पाइलर की हाइट वॉज क्रिटिकल, इसलिए हमें हाइट ना बढ़ा करके हमने एक स्पैन को एक्स्ट्रा लगाया। हाँ, ये परफेक्ट हुआ है, इंस्टीट्यूट है, कॉन्क्रीट का बता दो आपका भी। आप ये देखेंगे कि ये एसिमेट्रिकल है, इसमें 24 केबल्स हैं, 24 इधर, 24 इधर, 48, और इतने पीछे होंगे तो बैलेंस करने के लिए। टोटल वी हैव गॉट 96 केबल। तो 12 केबल तो 12 सिमेट्रिकली हो गए, बाकी 12 को बैलेंस करने के लिए भी एसिमेट्रिकल है। यहाँ हमने एक बल्कहेड बनाया था, MA2 कहते हैं। इसके नीचे 2 वेल्स हैं जिससे इसको एंकर किया हुआ है, और अपलिफ्ट को रोकने के लिए जितना अपलिफ्ट आ रहा है उससे डाउनलिफ्ट 6 टाइम्स का फैक्टर से। ये इसका GD है, ये मैं बता रहा, ये जो बल्कहेड है जिसमें हमने 12 केबल्स को एंकर किए। ये आप देखेंगे 24 केबल्स हैं, तो लेफ्ट में 24, राइट में 24, ये सेंट्रल स्पैन है 290 मीटर का, ये पाइलॉन है। ये पीछे हमारा 70 + 80, इसको हम MP2 कहते हैं।
एक बीच में हमको सपोर्ट देना इससे जरूरी था, इसलिए नॉट हैव बीन रिक्वायर्ड, क्योंकि जब ट्रेन इस एरिया में आएगी पूरी ट्रेन तो यहाँ पे अपलिफ्ट आएगी। ये पियर है और पियर पे हमने होल्डिंग डाउन केबल लगा, उसको इस सुपर स्ट्रक्चर को इससे टाई आउट किया, इसी जब यहाँ ट्रेन आएगी तो इसने अपलिफ्ट। इसी तरीके से यहाँ पर भी डेक को हमने होल्डिंग डाउन केबल से बांधा हुआ, तो ये हमारा 290 मीटर हो गया। और जितने केबल 12 केबल जो यहाँ पे एंकर हो रहे हैं, इनका लोड इन 12 केबल को बैलेंस करना है, यानी कि ये अपलिफ्ट जा रहा है और सारा लोड इस पाइलॉन से नीचे, तो सारा जो ब्रिज का लोड है, डेक का लोड है, ट्रेन का लोड है, पाइलॉन। तो इसलिए ये जो दो हमने वेल्स बनाए हैं, ये एक तरह के एंकर है, ये जो कि इतना लोड ले रहे हैं, करीब 40,000 टन का लोड नीचे है और ऊपर 6,000, तो और 5-6 का जो हमने इनोवेशन किया सर, ये जो हमारा मेन पाइलर का जो फाउंडेशन है, ये वेल फाउंडेशन, ये 20 मीटर डाया है और ये इस एरिया में यू कैन डू वेल्स, तो हमने इसमें माइक्रो पाइलिंग करी कौन सकते हैं माइक्रो पाइल करी है, तो माइक्रो पाइल की डेप्थ 40 मीटर, क्योंकि हमारा प्रोबेबली जो डेप्थ थी 20 मीटर, तो ये माइक्रो करके ये 40 मीटर है, जबकि डेप्थ 20 मीटर, 20 मीटर का एक्स्ट्रा गिर भी लिया। फिर उसके बाद इसको बिल्डअप किया है, इसको करके मैं आपको दिखाता हूँ फोटोग्राफ। ये वाई शेप, इन्वर्टेड वाई शेप है, और यहाँ पर हमारे केबल्स एम्बेड होते हैं, वहाँ पे टेंसाइल फोर्सेस भी आते हैं, कंक्रीट की कंप्रेशन भी होता है, इसलिए कंपोजिट स्ट्रक्चर, इसमें स्टील के बॉक्सेज है और कंक्रीट ऊपर पर, ये सारा आरसीसी और ये कंपोजिट आरसीसी स्टील, और इसमें जो केबल्स हैं, इसमें ये फिक्सड है स्ट्रेसिंग पर, ये देखिए
इसमें भी इंस्ट्रूमेंटेशन किया
आप पूरा ये एक स्कीमेटिक स्केच है, ये टॉप ऑफ फाउंडेशन है, ये यहाँ से अगर पहला लेंगे 193 मीटर, डेक लेवल तक 51 मीटर है, ये वाई यहाँ पे खत्म हो रहा है 71 और ये 71, इसे इन्वर्टेड वाई, और इस पर एक कैप है जो कि प्रीस्टेस्ट है, ऊपर भी टॉप पे प्रीस्टेस्ट है, और जो केबलिंग है ये इस वर्टिकल शाफ्ट में है, जो कि कंपोजिट है, ये वाई हो गया, फिर ये और ये सारा का सारा जो हमारा डेक है ये कंपोजिट फर्स्ट है।
कंपोजिट में क्या क्या
कंपोजिट में तो हमारा ये ट्रायंगुलर सेक्शन है, हमने MNS वो मैक्सिमम वेक्टर रिस्पांस सूरत है, वहाँ पे सारा फैब्रिकेशन अफसोस किया, PCA हमारे एजेंसी जो हमारी सेक्शन करती है, उसको सब पार्ट्स को लाए और यहाँ वर्कशॉप में डायरेक्ट करके लॉन्च किया, और उसमें फिर ऊपर हमने इसको डेको कास्ट किया, तो फिर उस पर इसमें फ़र्क है, इसमें यहाँ पे हमने बैलेंस करके बैलेंस कर, लेकिन थोड़ा सा कैम्बर का जो मूवमेंट होगा उसमें PLT करेंगे तो क्रैक आ सकता है, इसलिए क्या कहते हैं, जब क्रैक को हम बैलेंस करके दूसरे को लेके आते हैं तो उसको 4-4 मीटर में खा सकते हैं, जिसकी 10 मीटर क्रैक चेनिंग होते हैं, चेनिंग इफेक्ट जब ऊपर नीचे कैम्बर क्यों देते हैं, जब ट्रेन आएगी तो वो हॉरिजॉन्टल नीचे आएगा, तो जब वो नीचे होगा तो अगर आप गैप नहीं देंगे तो क्रैक होगा, तो ब्रिज को 4-4 मीटर पे आपने 10 से गैप दे दिया, तो चेनिंग की तरफ से देख लिया, 290 मीटर देंगे तो आपको 1 मीटर के साइज काट सकते हैं, तो इसलिए हमने इस सेक्शन में बैलेंस किया। अब ये आंजी ब्रिज है, इट इज़ द फर्स्ट रेलवे इवोल्यूशन आइडिया। अब यहाँ पे केबल सेट क्यों बना, पहले हम आज की क्या रीज़न थे, initially designed as a RP like Chenab Bridge, work lot to Jammu JV in 2004 along with Chenab Bridge. Due to pendency works 2008, alignment issues जो stability issues थे, तो work was short. ये not delivered work. फिर 2010 से 15 में there was no work because of PLDs. 2016 में इटाल्फा जैसे हमारा राइट साइड एरिया में इंडियन रेलवे का, ऐसे ही इटालियन रेलवे का भी कंसर्न है इटाल्फा, तो इटाल्फा इज द गवर्नमेंट ऑर्गेनाइजेशन, उसको हमने हायर किया फॉर गिविंग अस द कंसल्टेंसी किस तरह का ब्रिज बनाना है, जो बनाना है उसका फर्दर ही वाज आवर कंसर्न। सो द होल स्कीम वाज रिव्यूड फ्रेश एंड टेकन व्यू वाज टेकन टू कंप्लीट द ब्रिज इन ए टाइम एज वेल एज टू अकोमोडेट एग्जिस्टिंग। अब टर्नल तो हमारे फिक्स है, हमें कम से कम टाइम में ब्रिज बनाना है और कैसे बनाना है वो हमने सिलेक्शन दिया था। अब ड्यू टू स्पेस कंस्ट्रेंट्स, इंस्टेबिलिटी इशूज, स्लो स्टे इशू, कटरा एंड बिल्कुल जगह नहीं, मैं आपको अपनी फोटो दिखाता हूँ, तो वी थॉट ऑफ गोइंग फॉर ए एसिमेट्रिकल सोल्यूशन, इस सारा काम वहाँ करेंगे। तो केबल स्टेज एक्सपेंडर तो हमने केबल स्टेज को करा, और बिकॉज ऑफ टाइम, कॉस्ट एंड मेटेरियल। अब मैं आपको 2 मिनट की एक मूवी दिखाऊंगा कि इवोल्यूशन ऑफ ब्रिज। इस पर भैया आप आइए जरा, ये इसको क्लिक करेंगे भैया, प्रेजेंटेशन बाहर आकर ना कर लीजिए।
History of 168 years, the Indian Railways is building the most challenging project mankind can ever imagine. Kashmir Railway. The Udhampur-Srinagar-Baramulla Rail Link project. The most challenging project in the history of Indian Railways. Bridges after bridges and tunnels after tunnels. Looking at this project, it seemed that not even Mother Earth could stop the Indian Railways from building this new line. Some iconic displays like the Udhampur Railway Tunnel and the unique Chenab Bridge all fall on this line. Chenab Bridge, the world's highest railway bridge, recently completed its arch. Work on the other stretches are also going on in full swing. But among the glory of Chenab, another iconic engineering marvel failed to catch up the attention that it deserves. Construction of this underrated structure was so challenging that the engineers found the Chenab Bridge to be easier than this. It's none other than the Anji Bridge. The Anji Bridge is India's first cable-stayed railway bridge, but that too in an unwanted manner. That's a long story, so let's start explaining. The Anji Bridge is going to rest on a 196 meters deep canyon near Riyasi. Typically, such a height was decided to be joined with an arch bridge, which is similar to the mighty Chenab Bridge. While designing that bridge, something was discovered that became a matter of worry for the engineers. The load of the main span of an arch bridge is evenly distributed onto abutments or foundations settled on the slopes of the mountain. But in case of Anji Bridge, engineers found that the slope of one side of the mountain was extremely unstable to hold the foundation of that arch, making it impossible to build a bridge like Chenab. There is no way in which a pier or a foundation could be built on that slope. Finally, with no choice left in hand, the plan to build the arch bridge was dropped. But something had to be built there. Without the bridge, it was impossible to complete the railway project. Finally, a new plan was made and an asymmetric cable-stayed bridge was proposed. Unlike conventional bridges, the asymmetric cable-stayed bridge was designed to distribute almost the entire load of the bridge on one side of the canyon, just by making a single pylon. As a result, the other slope that was found to be unstable was freed from bearing the load of the foundation. Just a minor abutment was planned to receive the span.
स्मॉल करेक्शन, जिसने बनाई थी कमेंट्री से दी है, स्लोप वॉज नॉट कंस्टेंट, प्रॉब्लम वॉज स्पेस कंस्टेंट। अगर उसके लिए हम ज़्यादा काटते तो स्टिंग में है बिकम कंस्टेंट। एंड वी वॉट अबाउट 100 मीटर स्पेस वी कुड हैव गॉन फॉर ये आज से जाते तो अगर हमको बसा, क्योंकि जो डिफिकल्टी थी तो सबसे कम टाइम हो सकता है। मैं हैप्पी टू टेल यू जो प्लान किया था एग्जैक्टली उसी टाइम में। अगर आप देखेंगे वी स्टार्टेड द ब्रिज इन May 2006, हमने फाउंडेशन काफी मे ब्रिज की बात कर रहे हैं, और May 23 में हम लोगों ने इसकी डेक का वर्किंग कंप्लीट किया, और चुनाव को लगे थे 15 साल।
ये केबल से जो एक्स्ट्रा डोर ब्रिज
पता है
ये उतना पड़ता है, ये 50 तो एक्स्ट्रा डोर चलता है,
एक्स्ट्रा डोर में बेसिकली सर बहुत शॉर्ट
ये उतना ना, बट 250 तो
एक्स्ट्रा डोर तो सर उस पैंट और सब कुछ
अब तो
उसको थोड़ा बनाने के लिए यूज है केबल
100 मीटर की।
इसका प्रिंसिपल तो अलग है, ये सारा लोड फैला है। नॉर्दर्न रेलवे का मेन क्लाइंट जिसे बताया गया हम लोग थे, कोंकण रेलवे वाला कंपनी, इसमें भी गेम हुआ था, एक कौन सा रेलवे काम दिया था, फिर हमने ट्रांसफर किया, जो होता है पॉलिटिक्स। SCC was the construction contractor, क्योंकि इनके पास वैसे वो वॉली सीलिंग वाला ब्रिज का सीलिंग था, they got the contract, लेकिन जब काम शुरू किया तो जो लोग बनाने वाले जा चुके थे फिर जमीन हो गई, ऐसा कोई एक्सपर्ट नहीं था, काम क्या होगा। Udhampur was the consultant, is a good consultant, I am really happy with that, तो दूसरे consultant से मेरा इंट्रैक्शन हुआ है, चुनाव वाला वो छोड़ करके, they were quite good। IIC बेंगलोर, IIT दिल्ली ने सब किया था काम। कोविल UK was the pro consultant, ये चुनाव पे भी थे हमारे। टास्क का USA इन लोगों ने 3D अंजी का चौक और लोगों से कर दिया। फैब्रिकेशन वर्क को हम लोगों ने साइट में बिल्कुल नहीं किया क्योंकि बड़ी वर्क स्टैब्लिश करनी पड़ती इतना टाइम नहीं था। वी डिसाइडेड टू आउटसोर्स द फैब्रिकेशन, तो हमारा क्योंकि हमें एक ही वर्कशॉप में आउटसोर्स करते तो हमें डिले होता, तो हम लोगों ने 4 वर्कशॉप में इसको आउटसोर्स किया। इंडियन रेलवे ने ऑलरेडी 2-3 कंपनीज को सर्टिफाई कर दिया है, अप्रेस कर दिया है कि दे कैन डू थर्ड पार्टी इंस्पेक्शन इन एडिशन टू RDSO, कि RDSO रखते हुए काम नहीं करना होता है। तो ECI करके है, CEI सर्टिफिकेट इंजीनियर्स इंटरनेशनल लिमिटेड करके है या सर्टिफाइड, तो हमारे प्रोजेक्ट में सारा थर्ड पार्टी एंड और अच्छी क्वालिटी में हुआ है। ये 4 कंपनीज थी, मेजर सूरत से आया था। फिर विंड टनल टेस्टिंग सर हमारे रोवन विलियम डेविड RWDA कनाडा में तब विंड टनल टेस्टिंग की थी जब हमें आर्च मिला, तो वी यूज दैट डेटा एंड वी गॉट इट रीवैलिडेटेड थ्रू मिलान पॉलिटेक्निक, जब हमने टाइप ऑफ ब्रिज को चेंज रीडू, तो इसके कारण फिर विंड टनल टेस्टिंग में किसी ने पूछा था, मैं तो बता दूँ इसका रीजन क्या होता है। विंड टनल टेस्टिंग में 2 चीज़ होती है, एक तो फोर्सेज आपके ब्रिज में कितने आ रहे हैं, चनाव और अंजी ब्रिज दोनों में विंड इज क्रिटिकल नॉट आपके ऊपर विंड को कैटर करने के लिए 2 चीज़ होती है, एक तो आपका तो डेक की फिट कराते हैं, इसीलिए वहाँ पर 2 लाइन पे कहते हैं यहाँ पे हमने फिट करा दिया, हमने एक का रोड कर दिया, एक का दूसरा भी बिकॉज ऑफ विंड टनल टेस्ट आपको विंड अपर्चर डिजाइन करते हो कि जो दोनों तरफ अपर्चर लगाते हैं जिससे कि आप वो एरोडायनेमिक स्ट्रक्चर एरोडायनेमिक स्ट्रक्चर जो डेक पर लगाते हैं तो विंड को मॉड्यूलेट करते हैं, जैसे एयरप्लेन के विंग्स होते हैं उसको मॉड्यूलेट करते हैं, यहाँ पर देखोगे उससे विंड के इफेक्ट को मिनिमाइज, तो वो किया गया था इन्होंने। और साइड में IIT दिल्ली IIT रुकी ने किया था। स्टील केबल इंस्टॉलेशन BSL ने किया। BSL इज स्टेट ऑफ द आर्ट कंपनी, तो मेरे को इंडिया में 50-60% BSL करती है, लेकिन सिंगल एंड बेस इंडिया में। डायरेक्ट एंट्री मेसर ब्रिजको ने बनाया, दिल्ली में मेट्रो में इनका आधे बिल होगा, और इंस्ट्रूमेंटेशन मेजर मेसर इंकार्डो रखती है। ये ब्रिज का कॉन्फ़िगरेशन है, मैं ऑलरेडी बता चुका हूँ सर। मेन 290 का मेन स्पैन था, 80+ सेंटीमीटर का रियर स्पैन है, 28.25 का जो बल्क है। ये सिंगल का 94 मीटर है, इसलिए पहले 120 मीटर का है। एक कनेक्शन 38 मीटर का, दूसरे ये 40 मीटर डीप वेल हमने बनाया था यूजिंग मेट्रो पाइप। इस वेल फाउंडेशन बनाने में तो उसके बाद थिंग्स हमने इस यहाँ पे वेल फाउंडेशन में टाइम पर देख करके जो पीछे जो MA2 में जो वेल फाउंडेशन बनाई थी वो भी इसी तरह बैंक ऑफ इंडिया डिजाइन, तो उसे टाइम बचाने के लिए हमने उसको MATM पे तो कॉस्ट आ रही होगी, टाइम होता है। फिर ये वेल है 20 मीटर का था, डेप्थ 20 मीटर है, हाइट ऑफ द वेल क्या 120 में पूरा पाइलॉन है। बॉटम ऑफ अंजी बेड से 330 मीटर की हाइट आती है टॉप की। मटेरियल नीचे तो इन्फोर्स है, ऊपर कंपोजिट रहता है जहाँ पर कि हमारे केबल एंकर। ये सारा स्टील ट्रस गर्डर है विद कंप्लीट एंकर कंपोजिट। डेक की विड्थ 15 मीटर है, विड्थ ज़्यादा इसलिए करके ज़्यादा बाय एयर वेलोसिटी उसको मिनिमाइज करने का मोड स्ट्रक्चर को विड्थ चार्ज चाहिए, तो हमने क्या कि एक पे ट्रैक डाल दिया, एक को अपनी सर्विस हो गई। फिर डेक विड्थ है 14.5 आगे पीछे, तो ये हो रही है। फिर 96 केबल है, मैंने ऑलरेडी आपको बता दिया। ये 31, 32, 43 स्टैंड, ये बेसिकली स्टैंड अब केवल से ब्रिजेस के स्टैंड जो है 1-1.5 साल पहले का इंडिया में नहीं, जो HTS वगैरह आती है, जो हम PSC का करते हैं, पूजा मार्टिन टाटा स्टील बनाते हैं, वो इंडिया में नहीं होती क्योंकि वी नीड हाई रिलैक्सेशन एंड लो फटीग। तो ये हमने स्लोवाकिया से इम्पोर्ट किया था मैकेनिक कंपनी से। नौ आई एम टोल्ड कि अब ये लोग पूजा मार्टिन बनाएंगे। ये स्टैंड होते हैं, एक स्टैंड होता है 15.7 mm, तो 6-7 लगे होते हैं। और उसको कोरोजन रेजिस्टेंट के लिए हमने बॉम्बे वाले सेंटर करेंगे सीपल। इसमें जो जिंक कोटेड है, फिर वैक्स कोटेड है, उसके पीयू शीट है, तो फाइनल डाया बनता है 18.7 तो ऐसे हमारे स्टैंड हैं, तो उसके बंचेस होते हैं 31, 37, 43 के एक पे।
तो इसका क्या गारंटी कितना लॉस नहीं लगेगा?
नहीं सर, ये पूरा टेस्टेड है,
टेस्टेड है 50 का
120 गैस की लाइफ है, उसके बाद कुछ हो जाता है तो देगा भी रिप्लेस सभी केबल का प्रॉब्लम। और जो टोटल एक केबल में 31, 37, 43 का कॉम्बिनेशन का एफर्ट देंगे, तो जितना स्ट्रैंड्स हमने रीड किया है उसकी लेंथ अगर हम स्टैटिक्स में आप पसंद करेंगे तो उसकी लेंथ अगर हम जोड़ेंगे 650 किलोमीटर है फ्रॉम अंजी टू दिल्ली, तो इतनी हमें रीडिंग करी। तो चुनाव है ना दिल्ली का मैं इतनी करी है तो एफर्ट कितना ऐसे करता हूँ, तो करीब 850 टन केबल लगा है। और वो कोविड के टाइम में इम्पोर्ट किया था, मैं घर तक कम पड़ गया था। ये मैंने बताया था कैसे हमने करा इसका। और इसमें रियल 12 को हमने 28.2 एंकर किया था, और सारी बेरिंग में स्पेरिकल बेरिंग है जो मेगावे में।
ये स्पेरिकल बेरिंग चल रही है
सर, इसकी जनरली लाइफ बेसिकली जो पीटीएफ बेरिंग होती है उसकी लाइफ डिपेंड करती है पीटीएफ ठीक है, मूवमेंट का कुछ नहीं सकते 20-25 साल इतनी देर नो पीटीएफ। इसमें एक रोबो फ्लेट करके मेटेरियल होता है जो कॉपरेटिव मेटेरियल मिलेगा, उसकी लाइफ पर पीटीएफ होती है, लेकिन ऑलर
सिग्नेचर बेरिंग स्पेरिकल
वगैरह तो एक किसी को लाइफ अच्छे से लाइफ हो सकती है, ये उसकी नहीं मानते। और पीटीएफ सर ये 120 साल के लिए डिज़ाइन है, 100 km की स्पीड है, सिंगल पीजी ट्रैक है, एमपीजी लोडिंग 87 है। जो लोडिंग है वो इंडियन रेलवे कोड से की गई है सर, और डिज़ाइनिंग किया गया है वो ब्रिटिश स्टैंडर्ड और यूरो कोड से। उसमें 260 km क्रिटिकल के खिलाफ में या 213 km क्रिटिकल है, साइज जोन 5 है, लेकिन साइज और साइज कराया गया है 0.34 G मेरे का इसका मैक्सिमम करियर रखो इसका, और 0.27 G इसका पीजी।
तो मेरा इसमें क्वेश्चन है कि आई वांट दिस स्ट्रक्चर टू बनाए रेजिलिएंट मतलब कि जो भी ग्लोबल वार्मिंग का, क्लाइमेट चेंज का एंटिसिपेटेड इफेक्ट होगा 120 साल तक
सब लिया
दिया
सब लिया सर, रेलवे में यही रेलवे वाले स्टैंड में थर्मल का इफेक्ट पूरा नहीं होता है डिज़ाइन में कि आपको आश्चर्य होगा कि गर्मी में ट्रैक नीचे आता है, सर्दी में लेकिन जैसे टेम्परेचर बढ़ेगा तो ट्रैक को आपका स्टैंड एक्सपेंड तो ट्रैक नीचे, ठीक है। अगर सर्दी आएगी तो वो कॉन्ट्रैक्ट करेगा, नीला टूटेगा। जो इनिशियल कैमरा देते हैं उसमें इस इफेक्ट को डिजाइनर देखेगा। तो हमारा जो ब्रिज है अगर मैं आपको दिखाऊंगा उसमें थोड़ा क्रिटिकल 40 सेंटीमीटर कैमरा दिया हुआ ऊपर, जो डिजाइन से दिख गया था दूसरे को देर को दिख जाएगा आपको, जब ट्रेन आएगी तो एक्चुअली टूट जाएगा। ये क्वांटिटी है जो आपको दिखाएगा कि इतना क्वांटिटी लगी है, नथिंग मच। ये मैं बता रहा था कि आपने केबल एंकर जो किए हैं, पता अभी स्लो स्टेबिलिटी में आऊँगा, ये सब स्टैटिस्टिक्स है हो गई। ये पायलट गाइड होगी, ब्लास्ट लोडिंग, इसके लिए भी हमने वो डिज़ाइन करके बनाते हुआ चेक पे 40 kg PET के लिए डिज़ाइन और पीएफ को 20 मीटर दूरी पर 100 kg के लिए ये ग्लास यूज करते हैं। फर्स्ट एंड सेकेंडरी अर्थवर्क किया है, बताइए आपका सर। ये अर्थक्वेक फोर्स साइड IT ने करा उसकी ने। इस पर पहली बार एक जिस पे हमने एक सर्विस रोड दी है, 15 रुपये चार्ज दी थी, तो इट विल सर्व फॉर सर्विस कंडीशन फॉर इमरजेंसी इसलिए दिस रोड विल बी यूज्ड। स्टेट ऑफ द आर्ट इंस्ट्रूमेंटेशन और स्ट्रक्चरल मॉडलिंग का बना दिया है। ये है सर, ये 213 km की मैक्सिमम स्पीड है, इतना छोटा स्केल लगा है सर। अब ये इम्पोर्टेंट है, जस्ट के अंदर आपको इंटरेस्टिंग लगेगा सीक्वेंस और लॉन्चिंग पॉलिसी। केवल सिर्फ इसमें लॉन्चिंग सीक्वेंस को ऐसे ढंग से भी करते हैं कि आपकी बाकी एक्टिविटी चलती रहे, बाय द टाइम आपका डेक पूरा होगा तो ब्रिज ही पूरा होगा। आप ये नहीं वेट करेंगे मेरा पहला बन जाए तो मैं लॉन्चिंग शुरू करूँगा, पायलॉन नहीं बनता रहेगा, लॉन्चिंग चलती रहेगी। लॉन्चिंग की दो तरह की होती है, एक कुशन पुल से होगी और कितनी केबल से होगी, सारे के सारे केबल से नहीं होंगे। तो ये कंस्ट्रक्शन मेथोडोलॉजी है, लॉन्चिंग सीक्वेंस है। ये बेसिकली एक इस पर्टिकुलर ब्रिज के लिए और हर केबल से ब्रिज की जो लॉन्चिंग स्कीम होती है वो साइड से हमारे कभी नीचे बहुत डीप कॉर्ड है तो मैं सेगमेंट नीचे से नहीं उठा सकता क्योंकि सेगमेंट डेक की बोल सकता तो मैं इसकी मेथोडोलॉजी गेट्स मांगूंगा इसलिए मेरे को वहाँ हो सकती है। तो इसमें क्या है कि पहले हमने मेन पायलों को बनाना शुरू करा, ये एक रिवर एक्टिविटी है, साथ साथ हमने अर्थवर्क का और वर्कशॉप इस्टेब्लिश करी DRCI पे। फिर सुपर स्ट्रक्चर को हमने 3 पार्ट में डिवाइड किया और हमने 12 का आउटसोर्स किया। हमने डिसाइड किया कि हम एक 10-10 दिन का शेड्यूल बनाएंगे, उसको लॉन्च करेंगे। विथ 15 मीटर है और लेंथ 30 है। ये हमको सारा कोई भी हमने बिल्डिंग ऐसे नहीं करी, सब वर्कशॉप हुआ। साइड पे से हमने इसको एक्सटेंड किया और फिर इंक्रीमेंटल लॉन्चिंग इस कुशन जो हमने नॉर्मल लॉन्चिंग करी वो करी 200 मीटर। इसके आगे मैं नहीं कर सकता, वो मिल गिर जाए। अब हमने को प्रयोग किया। फिर लॉन्चिंग बाय सेगमेंटल लॉन्चिंग, डायरेक्ट लॉन्चिंग यूजिंग स्टे केबल करीब 240 मीटर 24 सेकेंड। और फिर उसका कंक्रीट स्लैब जो मैंने डेक कास्ट करा वो 3 से कास्ट किया। मैं एक साथ नहीं कर सकता क्योंकि मेरे को अपने डेक की प्रोफाइल को ऐसा डिजाइनर डिसाइड। तो मैं आपको एक एक करके दिखाता जाऊँगा क्या स्कीम। ये बताइए, ये फेज़ 1 है कि आपने पायलॉन को ये वेल फाउंडेशन शुरू कर दिया था, अगर 1 साल किया तब तक हमने अर्थवर्क किया, यहाँ वर्कशॉप सर्विस करी और तब तक हम लोगों ने ये MA2P बना दिया ट्यूबवेल के साथ। ये सब काम पैडल में चलता था। जब मेरा पायलॉन डेक लेवल पे आया देन आई वॉज रेडी फॉर लॉन्च। ये MPTP बन गया। फेज़ 2 आया, हमने यहाँ से वर्कशॉप बन गई और वर्कशॉप बन चुकी है और लॉन्चिंग नोज से हम लोगों ने 10,000 मीटर को कैबिन को जोड़ करके पुश एंड पुल मेथड लॉन्चिंग का क्या होता है, हम जैक्स यूज़ करते हैं, जैक से स्ट्रैंड को पुल करते हैं और पीछे एक स्प्रेडर बीम होती है, उस बीम को जब हम पुल करते हैं तो वो डर को पुश करते हैं। पुल एंड पुश करते हैं। मैं आपको वीडियो देता हूँ। तो इसलिए हम लॉन्चिंग करके व्हील को राइट अप टू ईयर, फिर यहाँ से जब हम क्रॉस करें लॉन्चिंग रोज को हम छोड़ते जाएंगे और करीब 200 मीटर तक हम लॉन्च ऐसे कर देंगे तो स्टे केवल। तब तक पायलट का काम पायलट में चलता है। फेज़ 3 नाउ माय लॉन्चिंग बाय पुश एंड पुल इज कंप्लीट और मेरा पायलट में करने को ये हमने 10 मिनट किया क्योंकि ऐसे ही हुआ। बाय द टाइम मैं यहाँ पहुँचा मेरा पायलट पूरा हो चुका था और जो मेरा ये वाला अपार्टमेंट है मैंने इसको 2/3 कम कास्ट किया था क्योंकि मेरे को इस डेक को एकोमोडेट करना। अब ये लॉन्चिंग करने के बाद में मेरा थर्ड काम आता है फेज़ 4 में कि मेरे को इस अपार्टमेंट को पिकअप करना था लेवल। फिर ये जो मेरा डेक था इसको हम लोगों ने इस अपार्टमेंट से रिजिडली कनेक्ट किया। एक बड़ी इंपॉर्टेंट है, आपने इंटीग्रेटेड बेरिंग का नाम सुना होगा। फिक्स बेरिंग के लिए हमने इंटीग्रेटेड बेरिंग, तो फिक्स बेरिंग में तो फिक्स कर दिया। इतने बड़े स्पैन को फिक्स से काम करेगा नहीं चलेगा।
इसका क्या है, इसका क्या है, कुछ इसको तो आ रहा है।
ये इंटीग्रेटेड बेरिंग है, इसमें इस पूरे डेक को HTS वायर्स के साथ 28 मीटर में हम फिक्स करके फिक्स पकड़ लेते हैं। तो इतने बड़े उस पर यही काम आता है। ये फर्स्ट स्टेज यहाँ पे किया गया। फिर नेक्स्ट स्टेज आता है आपका, अब ये पूरा बन गया, इंटीग्रेटेड बेरिंग बन गई और एक डायरेक्ट गेंट्री को जिससे कि हम सेगमेंट लॉन्च करेंगे उसको डिज़ाइनर ने कहा था इस एंड पर हम इरेक्ट करें। हमने इसको चेंज किया साइड से, तो हमें मुझे करना था यहाँ पॉसिबल नहीं था क्योंकि जो मेरी टावर क्रेन थी इससे सारा काम हुआ है। वो टावर क्रेन की जो बूम लेंथ है वो करीब 35 मीटर थी, हम जा सकते उसके आगे नहीं कर सकते। तो हम लोगों ने अपने आप में डिसाइड किया कि मैं डायरेक्ट को यहाँ पर इरेक्ट करूँगा और रेल से रख के इसको यहाँ मुक्त करूँगा। तो डिज़ाइनर है हरी रोड इशू क्यों उनको भी झक मार करके उनको बनाना पड़ता है, जो आपसे पैसे और लेते हैं कि वो चेक करेंगे कैलकुलेट करके वो मांगे। तो हम लोगों ने डायरेक्ट को यहाँ इरेक्ट करके यहाँ मुक्त करा। फिर सेगमेंट को उसके बाद हमने यहाँ पे डेक को कास्ट किया, इतने डेक को कास्ट कर दिए जैसे कि हम यहाँ पर सेगमेंट को मूव कर सके। फिर 2 रेल डाली, एक ट्रॉली बनाई जो मोटराइज थी, उस पर सेगमेंट को लोड करके यहाँ लाना। लेकिन इस डायरेक्ट में 125 ये डायरेक्ट का जो कैपेसिटी है 220 वो कि मेरी लिमिटेशन है कि आई हैव अ विड्थ ऑफ 15 मीटर और केबल्स का भी है। तो और ये जो एज है 200 टन से ज़्यादा का डायरेक्ट दे सकता। तो डायरेक्ट सीम्स टू वेरी फ्रेंडली, लेकिन डर लगता था ये 150 मीटर से ना उठाया जाता, तो कुछ प्रॉब्लम हो। ये मेरा अपना करके लेता, आई वॉज वेरी वेरी स्क्रैच जब पहले। तो यहाँ पर इस सेगमेंट को लोड करने के लिए अगर मैं बिना कोई केबल स्ट्रेस करे करता हूँ तो ये कोलैप्स होता है। तो डिज़ाइनर के हिसाब से 2 केबल होकर स्ट्रेस करता हूँ विदाउट एनी सेगमेंट एडिशन। 2 केबल्स को हमको इरेक्ट करके लॉन्च करके स्ट्रेस करना पड़ा। अब मैं यहाँ पे सेगमेंट ला करके मैं लोड तो नेक्स्ट फेज में हम लोगों ने ऐसे 10 सेगमेंट लॉन्च करे। सेगमेंट लॉन्च करते हैं, उसके बाद में गेंट्री को सेगमेंट की ओर मूव करते हैं और पीछे से केबल लगा के स्ट्रेस करते हैं एंड वी गो फॉर अनदर। लेकिन एक खास बात है, हर सेगमेंट को लॉन्च करने के बाद में डिज़ाइनर को मेरे को इस टेक का प्रोफाइल, पायलॉन का प्रोफाइल और इसके मूवमेंट डिज़ाइनर को जरूरत है जो थ्योरेटिकल से कंपेयर करके हमें वो हमें आगे बढ़ना या कोई रीच। तो 10 दिन का सेगमेंट था जो हमने बनाया था। वो कहते थे कि नहीं 15 दिन में ये करोगे। वी डिड 3 सेगमेंट्स पर मंथ। वी इंश्योर्ड इट। उस पर रात को 2 बजे PM इतनी वाले कालों को उठा लेंगे। कभी हमारे एक बैकपेट जो इंट्रोड्यूसिंग करके हैं उनमें कहते हैं यू आर द प्रोजेक्ट मैनेजर जाते हैं तो यू आर द ब्रिज टू गुड फ्रेंड। तो हमें तो हमारा काम नहीं रुका। वी डिड इन 11 महीने में हमने केबल का काम पूरा कर लिया था। 12 महीने में सारे जगह लॉन्च। फिर ये जब पहला स्टेज पूरा हो गया, इसकी हमने फिर टेक कास्ट करी। उसके बाद में क्या होता सर, रीस्ट्रेसिंग। ये बहुत इंपॉर्टेंट है। जब इतना करने के बाद में जो आपकी थ्योरेटिकल प्रोफाइल है उसके नीचे चले तो आपको केबल्स की रीस्ट्रेसिंग करनी है। ऊपर से होती है हर केबल को अगेन टू रीस्ट्रेसिंग और जो हमें थ्योरेटिकल प्रोफाइल के ऊपर ये एक बार फिर फाइनल करना पड़ा। फिर हम आगे बढ़े। फिर हमने फर्दर सेगमेंट को लॉन्च करा और यहाँ से पूरा कर दिया, केबलिंग हो गई। फिर लास्ट के जो 3 से 4 सेगमेंट 3 सेगमेंट होते हैं वो विदाउट स्टे केबल एनुअल। ठीक है, लास्ट सेगमेंट वो विदाउट स्टे केबल लॉन्चिंग एंट्री सेगमेंट। अब ये लॉन्चिंग एंट्री यहाँ पर आ गया। अब यहाँ से इसको हम निकाल देंगे। लेकिन निकालने से पहले हमें अभी हटाना नहीं है इसको। हमें फाइनल स्टे केबल्स को स्ट्रेच देखिए। जब आपका लास्ट सेगमेंट अटैचमेंट फिर नीचे भी जा सकता है तो क्या करते हैं आप, इसलिए आपको बड़ा केयरफुली चलना है कि प्रोफाइल लेकर के कि लॉन्चिंग प्रॉपर हमारे प्रति प्रॉपर लॉन्च चाहिए। क्योंकि आपने डिज़ाइनर से बात करके जो भी करेक्शंस करते थे। ये करने के बाद में यहाँ पर हमें एक टेम्प्रेरी लोड लगाना है। वो इसलिए लगाना पड़ा क्योंकि मेरे को इन केबल्स की फाइनल स्टेजिंग, अगर मैं इसको लोड नहीं करता तो ये टिप टूट तो और फिर फाइनल स्टेजिंग करी, ये फिर स्टार्टिंग करी। उसके बाद में जब फाइनल स्टेजिंग के बाद में ये बचा हुआ टैग में कास्ट कर टैग कास्ट करने के बाद में सारे केबल्स का फिर पोर्ट चेक है। अब इसमें एक और इशू आता है, जब हम केबल्स का पोर्ट चेक करते हैं कितना फोर्स आ रहा है तो हम जब रिवील करते हैं सिंगल जैक से करते हैं एक साइड की, और जब फोर्स निकालते हैं मल्टीपल जैक से पूरा करते हैं बोले केवल कितना लोड है। ये एक्सेलरेटर बार बार नहीं कर सकते। वो इसका एक तरीका होता है एक्सेलरेटर रेजोनेंस। ठीक है, इसमें हम क्या करते हैं सर कि केबल के कुछ हर केबल के ऊपर एक एक्सेलरेटर का एक रैक करते हैं, कंप्यूटर कनेक्ट करते हैं। जितना लोड हमने मल्टीपल जैक से निकाला एक्सेलरेटर चेक करते हैं उसमें कितना रेजोनेंस आ रहा है। उस तरह से हम कोऑर्डिनेट करके उसको हम कैलिब्रेट करते हैं। अब फ्यूचर में जिनको केबल में फोर्स निकालना है तो एक्सेलरेटर निकालना है उसको एक्चुअली जैक यूज करके देख ये बाद में फिर फाइनल चेकिंग होगा। एक्सेलरेटर को भी करेगा एक्सेलरेटर से और टेंसिंग करके रिक्वायर्ड हमारा ये हमें रीटेंसिंग की जरूरत नहीं। ये फाइनल ब्रिज है, कंप्लीट हो गया, ये टैगिंग कास्ट हो गया।
ये आपने इतना सिस्टम ऐसा बनाया, इसमें एनेबलिंग स्ट्रक्चर जो है
आएगा ना। अब फिल्म देखिए आपको एनेबलिंग स्ट्रक्चर मिलेगी। अब चले गए यहाँ से। इसको करके उसको एक्चुअली मैं काट दिया, सॉरी।
ओके,
इसे वापस जाके ना एक मैं करता हूँ, एक सेकेंड। ये वीडियो चला रहा है।
तो प्ले ऐसे नहीं होगा, मेरे को प्ले उसको ना इस पे नहीं आ रहा है, इस पे नहीं आ रहा है मेरे को।
इसको फुल स्क्रीन करिए।
करना है यार।
इसकी फीस पे रखिए ना, उसकी वजह से आ रहा था।
इसको थोड़ा स्टार्ट से कर, मैं कर देता हूँ। ओके हो जाएगा। हाँ, अब ठीक है, ठीक है। एक बार फिर और आना पड़ेगा, फिर हो जाएगा। ये पैरा एनेबलिंग स्ट्रक्चर बता देता हूँ। ये वर्कशॉप है, ये लॉन्चिंग नोट्स का रेशियो होगा 24 मीटर का, 10-10 मीटर सेगमेंट है। ये जैक्स है, ये स्प्रेडर बीम है, ये स्किड बीम्स है, ये गड़ों बिल्डअप करा। और ये डायरेक्ट एंट्री है। ये मैं अभी काट देता हूँ, मैं दूसरी फिल्म दिखाता हूँ, ज़्यादा अच्छा है। चलिए इसको मैं रिपीट कर दूंगा, आप देख लीजिए। ये ट्रैवलर है, ट्रैवलर में जा रहा है सेगमेंट। रोटेट इसलिए कर रहे हैं कि ये 15 मीटर जाएगा नहीं। ये हॉइस से उसको उठाएंगे, इसका आगे मूव करेगा कैंटिलीवर पे और रोटेट करेंगे एंड लोअर करेंगे। इसको क्लोज कर दो इसको। इसको और चलाना है, इसको ओके कर दो इसको। इसमें मूवी है, यहाँ पर लेंगे प्ले करके, पहले प्ले कर लो। एक प्ले करके आया, ठीक है। ये सिर्फ सेगमेंटल लॉन्चिंग है, थोड़ा क्लियरिफिटी है इसका। ये 10 मीटर का सेगमेंट हमने लिया, इसको इरेक्ट किया, इसको लिफ्ट किया, अब इसको फॉरवर्ड लाएंगे। ये मोटराइज ट्रॉली है, इसको लोअर किया, इसको रोटेट इसलिए कर रहे हैं 10 मीटर में केबल से नीचे जा सकता है। ये रेज ऑलरेडी हमने लेकर दिए डेक पे, अब ये अपने सेल्फ मोटराइज है। आपको बिल्कुल केयरफुल रहना पड़ेगा कि कोई प्रॉब्लम है। आ गया तो ठीक है, चल जाएगा ना। पीपीटी पे से ले आना, पीपीटी मोड पे कर दो बस। तो केबल्स के बारे में सर मैं आपको बता ही चुका हूँ। जैसे कि हर सेगमेंट के बाद में टेक प्रोफाइल, पायलट रिफॉर्म, एमपीओ सबका हमें करना पड़ता है। ये सर वो एरोडायनेमिक स्ट्रक्चर है जो ब्रिज 213 km के लिए क्रिटिकल स्पीड आई है और 3 सेकंड का एरोडायनेमिक स्ट्रक्चर। ये एरोडायनेमिक स्ट्रक्चर कहते हैं। ये सिर्फ सेंट्रल स्पैन में लगा है और बहुत अपस्ट्रीम एंड डाउनस्ट्रीम साइड। ये स्टेनलेस स्टील का होता है और ये लास्ट में लगा है। ये देखिए इस तरीके से ये बड़ा कर्वीलिनियर है और ये इससे कि विंड को मॉडरेट करता है। तो ये एक बड़ा स्पेसिफिक फीचर है। चनाब में देखेंगे वो बड़ा रफ ट्राइंगल देता है इस तरह का। ये स्फेरिकल पेयरिंग है, मैं आपको ऑलरेडी बता चुका इसके बारे में। ये इन्होंने यहाँ गलत देखा, पीके में नहीं, ये इंटीग्रेटेड है, उसको हमने यहाँ डिस्कस किया। ये जस्ट जो कटरा एंड की जो क्रिटिकल है जगह नहीं थी, ये टर्न का पोर्टल देखिए, ये इसके टर्न है, फिर 2 स्पेस जो हमने ये फाउंडेशन बनाई है, तरीके से बनाई है। तो पहले इसकी सिचुएशन ये थी, यानी वजन यहाँ कैसे आप पहले बना सकते। अगर आप आरसी बनाते तो क्या यहाँ पे फाउंडेशन बन नहीं सकते। स्टेबिलिटी के आपको बहुत ज़्यादा एक्सपेक्टेशन करना पड़ता, आप अंदर से अनस्टेबल। तो हमने यहाँ मिनिमम स्टेबल स्पॉट स्टेप किया और ये सारा हमने इसकी स्टेबिलिटी करी है। इसके भी आपको मैं फिर दूँगा। ये दूसरे एंड का है सर, जो हमारा रियासी एंड है, उसका पहले ये पोजीशन थी। ये पुराने पियर बने थे तो हमने डिसमेंटल की कैमरे वाले, तो ये नया ब्रिज बना। ये स्लोप स्टेबलाइजेशन जो हम लोगों ने करी है, इस पर हमने केबल एंकर भी यूज़ कर रहे हैं, एसटीएल भी कर रहे हैं, ये बोर्ड भी कर रहे हैं। ये अब फिर तो आपको फिर दिखाता आगे कोई है, बड़ी इंटरेस्टिंग है। लास्ट पर नाउ आई एम जस्ट कंक्लूडिंग। ये पवाई नहीं करी है वेरी वंडरफुल जॉब। बहुत सी जिस तरह
Anji Bridge, an engineering marvel in the making, is Indian Railway's first cable-stayed bridge and is a part of Udhampur-Srinagar-Baramulla Rail Link section of Northern Railways in Jammu and Kashmir. It's been constructed by Konkan Railway Corporation Limited. The slope stabilization works at Anji Bridge is characterized by many challenges such as complex geology, steep slopes, working at slopes in handy position. For slope works at Anji Bridge, advanced solution of cable anchors, also known as pre-stressed post-tensioned grouted ground anchors, is used. 598 numbers and 15,122 100-meter cable anchor are used for slope stabilization. These anchors transfer load to ground to take care of stresses generated due to loss of effective stresses. The various steps involved in cable anchoring works are as follows. First one is drilling of hole with portable pneumatic drilling machines. Then, fabrication of cable anchor further consists of following activities: cutting of HT strands as per approved drawings, epoxy painting of HT strands for corrosion protection, spraying of silica quartz sand for fixed length, tying of strands of cable anchors with spacer. The fixed length is covered with SWC pipe and grout pipe. The free length of strand is coated with epoxy paint, greased and sealed with HDPE sheathing and grout pipe, then installation of fabricated cable anchor. After that, primary grouting of cable anchors along with field tests such as flowability test and 28 days compressive strength. Then, stressing of cable anchors with jacks. And last one is fixing of protection cap and final secondary grouting of anchors. As this work is carried out in handling position for steep slopes, extra safety precautions are taken such as use of safety belts, safety ropes, helmets etc. are considered as priority.
Finally, the bridge is complete. Now track has been laid. ट्रैक किया सर मैंने ऑलरेडी का बैलेंस्टेड है और इस पर मेन रेल होती है तो हमें उसके रेल यूज करनी है तो 60% में वहाँ से इम्पोर्ट करेंगे बाद में फिर मीटिंग ले सकते हो तो जनरल सीधे बनाए ये 110 यूटीएस की हेड आर्म है जिससे कि हमें रिप्लेसमेंट का आगे होता है ये गार्ड रेल है जो अगेन 52 kg सेक्शन है अगर कोई ड्रिलमेंट हो तो कोच कैप्साइज है इसलिए ये बैलेंस्टेड है ये हमारे जो आप देख रहे हैं बड़े बड़े ड्रम्स ये बेसिकली इस पर डैम्पर जिससे कि वो केबल्स जब कुछ गाड़ी चलेगी तो आपको बिल्कुल भी मूवमेंट नहीं तो हर एक केबल में डैम्पर्स हैं और जितने हमारे 96 केबल पे थे 60 केबल को हमने इंस्ट्रूमेंट किया हुआ है उसमें लोड सेंसर लगा रखे हैं तो वो रिप्रेजेंटेटिव केबल है वो 16 केबल से हम बाकी केबल्स का वो एक्स्ट्रा कर बाकी तो सिंपल हो गया तो नेक्स्ट है इसका ये हमारे ब्रिज एक्सटेंशन क्योंकि इससे ब्रिज 290 मीटर का स्पैन है तो इसमें ब्रिज के एक्सटेंशन काफ़ी होगा तो मैगावा ने ब्रिज एक्सटेंशन मुझे सप्लाई किया है तो मेन केबल का मेन ब्रिज पे 720 mm तक का वो एक्सटेंशन को केबल करता है इसके साथ ही क्योंकि ब्रिज एक्सपेंड करेगा तो आप ट्रैक में रिकॉर्ड करेगा जनरली आप ट्रैक में जो लॉन्ग मटेरियल डालते हैं तो सिर्फ एक्सटेंशन वेरिएंट डालते हैं इसके 120 mm का जनरली मैक्सिमम मूवमेंट डिज़ाइन बट दीज आर स्पेशल रेल एक्सटेंशन बेल्ट जो हमने वॉस्को से लिए हैं जिसमें हमारा मूवमेंट 500 मिलीमीटर तक जा सकता है मैं सारे बड़े ब्रिजेस ये इंडियन रेलवे में फर्स्ट है ये जैसे बताया था 26 अप्रैल को केबल इंस्टॉलेशन वर्क आउट कम्प्लीटेड 11 महीने में और 25 मई को मेरा लास्ट है और फिर डेक पे कास्ट करना है तो 5 ईयर अगर वो ना हो तो एक 10 मिनट का एनिमेशन है वो अगर आप झेल सकते हो चला दे तब तो फिर मैं नीचे बढ़ जाता हूँ आप चला दो ये सिंपल एनिमेशन है मेड बाय HCC इसमें A to Z सब दिख रहा है प्योर एनिमेशन तो मे नॉट बी वेरी टेक्निकल लेकिन ठीक है मैंने आपको दे दिया अब इसे डेस्कटॉप पे है मेरा पूरा फोल्डर है यू कैन जिसको चाहिए ले लीजिए आप बार-बार देखिए इसको
engineering marvel built in extreme geographical conditions. It is India's first cable-stayed railway bridge connecting Katra to Riyasi in Jammu and Kashmir on the Udhampur-Srinagar-Baramulla Rail Link project. This asymmetrical cable-stayed bridge crosses the deep gorges of Anji, a tributary of the river Chenab. The bridge connects Tunnel T2 on the Katra side and Tunnel P3 on the Riyasi side. Initially, the plan was to build an arch bridge similar to the Chenab Bridge, which was abandoned due to concerns over the vulnerability of the structure, primarily due to concerns over the geological stability of the region. Hence, in October 2016, Indian Railways decided to build a cable-stayed bridge at Anji. The total span of the bridge is 750 meters, which includes a 473-meter long asymmetric cable-stayed bridge. The bridge has a 290-meter span on the north side, Katra side, with a 183-meter span on the south side, Riyasi side. The bridge has a single-line railway, 5-meter, with a 3.75-meter wide service road, a 1.50-meter wide footpath on each side of the deck, resulting in an overall width of 15 meters. Once completed, the bridge deck over the Anji River will rise 196 meters above the riverbed. The main pylon of the cable stay is 193 meter tall, taller than the 126 meter tall Bandra-Worli sea link, with an inverted Y-shaped design. The top of the main pylon rises over 338 meters above the riverbed. It is built in reinforced concrete. The upper part of the tower, about 71 meters, hoists anchorages of stay cables and is made of a composite steel concrete structure. The pylon is designed to hold 96 cables on both sides, that is, 48 cables each on the lateral span towards Riasi and central span towards Katra. The cables totally weigh 848.7 metric tons. The main bridge consists of 47 structural steel segments having an average weight of 150 metric tons, of size averaging around 10 by 15 meters. These segments are fabricated in sections and transported to the project site workshop where they are assembled. The launching of all the segments is divided into 3 stages. In the first stage, the segments from segment 26 to segment 47 are progressively launched, pushed by hydraulic jacks from the workshop, crossing to MP2 and MP1 sequentially. It is followed by concreting of the deck slab, totaling a length of 198.75 meters. This consists of a cantilever portion of 48.75 meter away from the central pylon. The second stage involves launching of segments in cantilever method from 25 to 16 using derrick gantry. The derrick gantry is erected at the end of segment number 26 to launch and lower the segments. The sequence of work starts from the assembly of the segment in the assembly yard, followed by lifting and placing on the trolley. Afterwards, the trolley is moved with the segment below the derrick gantry, where it is lifted by the derrick using the lifter setup fitted in the segment. A G-card cable bridge is equipped with a structural health monitoring system by providing special sensors like strain gauges, accelerometers, force sensors in cables, anemometer, temperature sensors, etc. Furthermore, the segment is shifted to the cantilever position and lowered to the final position where the segment-to-segment assembly work starts. Finally, using the torquing platform, all the parts of the segments like bottom and top chord members, diagonals, bracing, cable ducts, walkway are fixed. After the final torquing, the gantry lifter is pulled back to its original position and moved forward over to the erected segment. After this, the erected segment is attached by the stay cables to the pylon, while simultaneously attaching the respective segment on the lateral side to achieve the cantilever position. The strands for this bridge are specifically designed and imported from Czechoslovakia with a diameter of 15.7 millimeters, zinc-coated wax filled plus PU HDPE cover over the strands, which are not manufactured in India. The cable's length ranges between a minimum of 80 meters up to 295 meters as a maximum. The stay cables are composed of 31, 37 or 43 strands. This process is done for the next 10 segments, that is, till segment number 16 from segment number 25. Then, the deck slab casting work starts for the next 100 meters, which includes placing the deck sheet with lattice reinforcement, providing stability and friction for the slab. After fixing the deck sheet, the reinforcement binding work is completed, followed by casting. Stage 3 involves the same process for segments 15 to 1 for the remaining 142 meters, out of which segment 3, 2, 1 do not have a stay cable. After the complete launching of segments, all cables are checked for the final forces and the deck geometry is checked. After completing all segment erection up to segment 1, an aerodynamic structure will be erected on both sides of the central span. This aerodynamic structure is similar to the front edge of an airplane wing that offers additional stability to the deck of the bridge from gusty winds. Anji Bridge is the first bridge to incorporate such a technical structure in any type of bridges in India.
Thank you for such a interactive, presentation from Mr. Gupta, who was actually the flag bearer of this project, with a lot of videos, which especially keeps the listener engaged. So thanks for this wonderful presentation. With this, I will ask Dr. Usmani to kindly facilitate our speaker on the stage. So we at IIT Delhi Department of Civil Engineering, we also have a lot of guest lectures for our UG students. So I will, in future, I'll definitely ask Dr. Gupta to kindly come for our UG students also, because bilkul for everyone. Sure. Professor K.S. Rao, Professor Gupta, Dr. Mr. Gupta, everyone is kindly invited. I'll make sure that happens soon. So with this, thanks everyone for being here to make this good success, grand success, and being a part of this. As we draw the curtain on this inspiring exploration of engineering marvels, that is the Chenab and the Anji Bridge, we stand in awe of what ingenuity can do. These structures are not just feats of engineering, they are testament to human tenacity, innovation against odds, and the relentless pursuit of progress. So, it was quite tangible when Mr. Gupta was speaking, that he was the one who got it done, because eventually you need that energy. Professor Rao also focused on the fact that he actually made sure that the things go ahead. So in every system we want somebody who is like that, who is like the go-getter, and that was quite tangible when they were speaking. So yes, it's a relentless pursuit of progress and development that we should all aim for. As we leave today, let us carry forward this spirit, that is, build boldly, innovate fearlessly, and bridge not rivers but possibilities. And these bridges will not only make the trains to travel, they will also progress humanity along with it. So it's not only the trains that railways have built, but it's the humanity around us that for coming century, that these will set the epitome of what Indian engineers can do in an indigenous manner. So with that, thank you everyone. Thank you for being a part of it. Thanks to our guest speakers. Thank you everyone who has been a part. Thanks to our team, Dr. Usmani, Sumit, everyone. Thank you. Thank you with that.
ट्रांसफर हो
क्लोज हो गया सर के बस ट्रांसफ़र लगा दिया था, बट ये कुछ टाइम ज़्यादा दिखा एलसीया हम सर एक काम करेंगे कि
इसे हम
ग्रुप
बाद में
शेयर
ट्रांसफ़र कर
है
देंगे,
ना?
पीडीएफ बना के कर देंगे, ठीक है।
हाँ, क्योंकि ये काफ़ी टाइम लेगा अभी। हाँ सब कुछ है, वो कंप्रेस करके एक सिस्टमेटिक वे में वी विल डू दैट। हाँ एज अ मेल और ग्रुप में जैसे रहेगा।
ये सौरभ आपका भी थी?
हाँ
बस ठीक है।
मतलब
नहीं ऑफिस का किसका है?
ये हमारा ही मतलब मेरे पास ही।
ठीक है।
ये इसको मैं अपने अच्छे से प्रॉपर एक फोल्डर बना के
एक फोल्डर बना देना जी।
और हाँ उस सुमित सर को मैं बॉक्स पे शेयर कर दूँगा।
हाँ बॉक्स पे ठीक है। फॉर्म राइट।
Govind, Radhe Govinda. Hello. Hey Gopal, Radhe Krishna, Govinda, 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 Radhe Govinda, Govinda. Hey Gopal, Radhe Krishna, Govinda, Govinda. Hello, hello, sound check. Hello, 1, 2, 3. Hello, hello. Hello, hello, sound check. 1, 2, 3. Hello, 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 sound check. 1, 2, 3. Hey Gopal, Radhe Krishna, Govinda, Govinda. Hey Gopal, Radhe Krishna, Govinda, Govinda.
ब्रज रानी हमें ब्रज दूल बना दे, रानी हमें ब्रज दूल बना दे। हरे कृष्णा हरे कृष्णा हरे कृष्ण।
Krishna Krishna Hare 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 Rama Hare Rama. हाँ अभी कहूँगा वो जोंग को लाऊंगा अभी खाली पानी की बोतलें बोतलें और कुछ नहीं है। हैं बढ़िया मेरी दी है उन्होंने। हे गोपाल राधे कृष्ण